Hi everybody, am I audible? Am I visible? I want a quick good to go from all of you. Yes, can you see me, hear me absolutely clearly? Yes? Hi everybody. Am I live? Yup. Hi Abhishek. Hello people. Yes, thank you so much. I am perfectly visible and audible to each one of you, right? Wait a second. Just a second, guys. Hi, hello Ved. Hi, honey. Give me 1 second, guys. Hi everyone, am I live? Quickly tell me people, there was this glitch that I was facing and now I guess it's fixed. Hi everyone, am I live everybody? Quickly tell me, is there a lag? Is there a problem? Very quick. Can you see me? Can you hear me clearly? Absolutely clearly. Hi Rishabh, hello honey. Am I visible? Am I audible to everybody? Yes, Hitesh. Goofy. Ah, okay. Okay. People, very quickly tell me if there is any glitch in the audio video. I'm facing certain technical glitch here, so I don't want any disturbance to happen throughout the session. It's going to be a long and a very rewarding session for all of you. It's a full syllabus revision session for mathematics from last 10 to 15 years. JEE Main and JEE Advanced hand-picked questions will be discussed today. So tell me if I am perfectly visible and audible to everyone out there. Yes, ma'am? No, ma'am? Yes? Okay, all good? Will you do questions as well? I will be doing tons of questions, Skandesh. Tons of questions. Too many questions. And if you take this bank of questions and actually write it properly, keep it properly in a separate notebook, it will be of tremendous help in these last few days. I can guarantee you that you are not going to get anything beyond these set of questions. That is something which is a big promise, but I have covered every bit of concept which you can be asked in the paper, which the examiner can ask you in the paper from every possible direction. So I'm not saying the question exactly will be repeated, but definitely the concepts, the results, the shortcuts, the ideas, the approaches, the varieties which I have handpicked to share with you today are literally very rewarding, very promising. So you have to make sure that you are extracting the most from today's class. And if there is any doubt, stop me then and there. It's going to be, as I said, a long session. So grab your something to drink, something to munch, and let's get started, everyone. Everybody quickly mark your attendance by hitting the like button. Quickly share the session with all your friends, all your folks, all your classmates. Invite them here. This is going to be a fantastic session and I want all of you all to take the most from this. So let's get started, everyone. Am I visible, audible perfectly? Focus is conic section. Bhupendra is saying, Abhishek is saying, okay, fine. You'll get your lemonade then. Not an issue at all. Alrighty, folks, so there is something I want to share with you before I dive into math. So because you're so close to your examination, there are 10th folks, there are 12th folks, there are droppers who are facing or who are struggling with a lot of questions. Questions related to revision strategy, question related to syllabus completion, question related to paper attempting, question related to how to maximize my marks, question related to every challenge that you are facing in the journey of your preparation, be it academic or non-academic. So what we have done is we together have brainstormed upon all these questions, all the teachers, all the team members, we've brainstormed upon all these questions and we have come up with something called a webinar. So what are we doing here? This is a live one-to-one mentorship webinar. What is it? It's a live one-to-one mentorship webinar, everybody. Live one-to-one mentorship webinar. Here you get to ask your queries, all your confusions, all your doubts, as I said, academic or non-academic, to a teacher, a renowned teacher, a counselor, and that person helps you resolve all your issues. So this is something which is happening at 7 p.m. for class 10, 12, droppers of NEET or JEE. Basically, it's for everyone. The tips that will be shared, the context that will be there in the session, in the webinar, is going to be of tremendous help to each one of you. Okay, so make sure you extract the most from this as well. Don't forget to tune in at 7 p.m. All right? Yup. Let's go then. बहुत डर लग रहा है, मत डरो, डरने की जरूरत नहीं है. Let's get started, everybody. I don't want you to be scared of even one bit. There should be not even an iota of fear inside you, because you are bigger than the exam. You're bigger than any challenge which comes your way. So let's dive into mathematics and let's crush, let's kill, let's smash every question. Ready? Let's start. We will cover algebra, we will cover calculus, we will cover conic sections, we will cover vector 3D, we will cover set theory, we will cover everything. Everything under the sun, under the roof, and not just everything, important parts from everything. My aim is to get you to 55 to 65. That is my target. 55 marks to 65 marks is something which you will 100% get if you attend this session today thoroughly, fully, attentively. Alrighty? Yes. Let's start. Let's see, as per the questions proceed, whatever theory, whatever content is required for me to explain you there, I will be doing it, but with the help of questions, because now we have to make sure we are doing exam-oriented preparation, and especially for mathematics, you have to make sure you take the question to theory route, not theory to question to theory route. Okay? Okay? Let's start. Let S be the set of all integral values of alpha for which the sum of squares of two real roots of t of the quadratic equation, this is minimum. What do you think? Come on, very quickly. Some are JEE main level questions, some are JEE advanced PYQs, and some are really new questions from different other examinations which can really benefit you in your preparation. So tell me. Yes. S is the set of all integral values of alpha for which the sum of squares of two real roots of this quadratic equation is minimum. I am given a quadratic equation, everybody. I am given a quadratic equation. What I want is sum of squares of the real roots of this quadratic equation has to be minimum. Make sure you read the statement carefully. Make sure you understand what the question is asking from you, asking you to do. So the quadratic equation is what? 3x square plus alpha minus 6x plus alpha plus 3 is 0. Please tell me, people, what is the first thing which is catching your attention? It says sum of squares of two real roots. Sum of squares of two real roots. Arey Baba, for me to compute sum of squares of two real roots, it should first have two real roots, na? It should first have two real roots. Na? That means somewhere the question is trying to give me a hint that this has two real roots. The moment I know this quadratic has two real roots, that means its discriminant is non-negative. So b square minus 4 into a into c is non-negative. Tell me if this is clear. Vansh, very good, awesome job done. AOD bhi hai, sab kuch hai. Don't worry, very good. Discriminant is where you should strike you. Discriminant is what should strike you at this point in time. Very, very good. So what do you get? Alpha squared plus 36 minus 12 alpha minus 12 alpha minus 36 greater than equal to 0. So this and this cancels out. Alpha square is greater than equal to 24 alpha, or rather minus 24 alpha is non-negative. Tell me. Alpha minus 24 is non-negative. That means you use your baby curve method. This is 0, this is 24, this is plus, and then minus, this is plus. Greater than equal to 0. Greater than equal to 0 means alpha has to be less than equal to 0 or greater than equal to 24, everyone. Is this clear? This is the restriction upon alpha if you want to guarantee that your quadratic equation has real roots. Chalo, cool. Next it's written, what is written? Sum of squares has to be minimum. Sum of squares has to be minimum. Sum of squares of these roots, alpha square plus beta square, I have to minimize this. What is this? Alpha plus beta whole square minus 2 alpha beta, right? Sum of the roots is what? Minus b by a. So 6 minus alpha upon 3. Product of the roots is c by a. Alpha plus 3 upon 3. This is what I have to minimize, everyone. A minus infinity to 0 union 24 to infinity. Perfect. Perfect. Abhishek, as and when required, I will be revising. For example, here you know, if I want sum of the roots, it is minus b by a. Minus of coefficient of x upon coefficient of x square. If you want product of roots, it is c by a. Constant term upon coefficient of x square. Right? This is the relationship between roots and coefficients which is tested again and again in a JEE Main exam. So this is how we are through the questions revising the concepts, the results, the ideas as well. Okay, what about this? Open this up. You will get 36 plus alpha square minus 12 alpha upon 9 minus 2 by 3 alpha plus 3. So 9 is your LCM. You get 36 plus alpha square minus 12 alpha minus 3 into 3. So 6 alpha and 6 3s are 18. Isn't this alpha square minus 18 alpha plus 18 upon 9? Is this okay? I have to minimize this. That means I have to minimize this. I have to minimize this. That means I want 1 by 9 as it is. I want the minimum value of alpha square minus 18 alpha plus 18. Alpha square minus 18 alpha plus 18's minimum value. What is it, guys? Who will tell me? First derivative. Oh, you want to compute the first derivative? You can go ahead compute the first derivative. Let's say this is f of alpha. So f dash alpha comes out to be 2 alpha minus 18. Equate with 0. Alpha is 9. 9 is here. This is plus. This is minus. So 9 is actually point of minima. So this is one approach, everyone, to get to the minimum value. This is one approach. This is one approach. The other approach is what? You complete the square. From there you can get the answer. And yet another approach is you plot the graph. You plot the graph. From there also you can get the answer because the vertex is the point where you get the minimum value. The vertex is the point where you get the minimum value. So corresponding to alpha equals 9, you will get the vertex. Is that okay? So 3 approaches I am telling you. Number 1 is differentiate, which is use your AOD approach to get the minimum value. Next is completing the square. Next is draw the graph. Okay? 1 by 9 also. Very good. Is that okay? Is that okay? So at alpha equals 9, this f of alpha is minimum. That means the minimum value of this entire expression is 1 by 9 into f of 9. 1 by 9 into f of 9. Yes or no? That means what? 1 by 9 into 9 square minus 18 into 9 plus 18. Should I report this as my minimum value? I don't want this minimum value. My question is only saying S is the set of all the integral values of alpha for which this is minimum. So the possible integral values of alpha for which this is minimum is alpha equals 9. So is 9 my answer, everyone? Please tell me right now. Question is not asking you to compute the minimum value, everybody. Question doesn't want you to compute the minimum value. Question is saying for what integral value or values of alpha are you getting this to be minimum? So should I say for alpha equals 9, 9 is the only integral value for which I am getting my function to be minimum. Should I say this? Answer is 1. That means S is the set of all integral values. Then S is singleton 9. S has to be in that case singleton 9, right? It's a set now, so I have to describe it in the set format. I can't describe it in the cardinality format that S has 1 member or 2 members. Question says S is equal to what? It is singleton 9. Yes, Priyanshu says no. Yeah, absolutely correct, people. Absolutely correct. This is a very, very catchy step. You have to make sure that your real roots are arising if and only if alpha is satisfying this condition. Alpha has to be either less than equal to 0 or greater than equal to 24, and alpha equals 9 does not fall in this category. If alpha equals 9 does not fall in this category, that means there is no possible acceptable valid alpha for which this equation has real roots and the sum of squares of its roots is minimum. The answer is that S is equal to empty set, everybody. It is not a singleton set, which majority of students generally mark and have marked before when this question was asked in JEE Main. Because it happens in that pressure situation, you are bound to forget this condition. This seems like such a ordinary condition that you end up just getting excited that I got alpha equals 9, which means S is singleton 9, which means it is a singleton set. Actually, this is wrong. S is technically 5. Plus 4, congratulations. Is that okay? Any doubt, anyone in this question? Is this clear? Very famous, very frequently occurring question. Let's see, Athriya, let's see. We've just started. Let's see. All right, next question, people, on your screen from MND. Every question is cherry picked, so make sure the concept which drives that question is something which you take away very, very honestly. That has to be taken away by you very honestly, very diligently. A is given to you, B is given to you. A has alpha unknown, B has alpha unknown. Alpha comes from C. Then the absolute value of the sum of all values of alpha for which determinant of AB is 0. How do you think you will approach this question, guys? How do you think you will approach this question? Very nice question. A question which seems like an easy one, but it has a catch. Tell me. I want absolute value. Read what you want. I want absolute value of the sum of all values of alpha. Absolute value of the sum of all values of alpha. So first I need all values of alpha, then I will add them, and then I will compute the absolute value. Understand the sequence. I'll compute alpha, then I'll add all possible values of alpha, and whatever that answer comes out to be, I will take its mod, the absolute, and report that as my answer. But determinant of AB is 0. How do you deal with this? When you say determinant of AB is 0, how do you deal with this? Let's find out. I have A, I have B. This is a 2 cross 3 matrix. This is 3 cross 2 matrix. So when I compute AB, my answer will come out to be a 2 cross 2 matrix. Okay. First row into first column, you get 2 plus 2 plus 4 alpha. So 4 plus 4 alpha. First row into second column, you get alpha minus 4 minus 5 alpha. So minus 4 minus 6 alpha. Now minus 4 minus 4 alpha. Yes, correct. Second row, first column, you get 2 alpha minus 2 minus 4. So 2 alpha minus 6. Second row, second column, you get alpha square plus 4 plus 5. This is alpha square plus 9. Please tally, everybody. Algebra is too much about the computations. Please tally. Okay. Now, when I say determinant of AB is 0, product of diagonals minus product of off diagonals. You know this, right? Determinant of a 2 cross 2 matrix is product of diagonals minus product of off diagonals. What will you get? 4 plus 4 alpha into alpha square plus 9 minus, this will become plus 4 plus 4 alpha into 2 alpha minus 6. This is 0. So 4 plus 4 alpha as it is. Inside you have alpha square plus 9 plus 2 alpha minus 6. Check this out. हाँ ठीक है. So 4 common, alpha plus 1, this is alpha square plus 2 alpha plus 3 is 0. Now, something which a lot of students do, I'll just tell you. The moment you look at this equation, it seems familiar. You say either alpha plus 1 is 0 or alpha square plus 2 alpha plus 3 is 0. Yes or no? Yes or no? You say either alpha plus 1 is 0 or alpha square plus 2 alpha plus 3 is 0. So from here you get one acceptable value of alpha, which is minus 1. And the moment you jump onto the quadratic, you realize that, ma'am, the discriminant is b square minus 4ac, which is negative. So this has no real roots. No real roots. That means there is only one acceptable value of alpha, which is minus 1. I want the sum of all possible values of alpha and then its mod. So there is only one acceptable value of alpha, minus 1. Its mod will be 1. My answer will be 1. My answer will be 1. It's not there in any option. See, so many people are saying 1. Why is it not there in any of the options then? One is the answer. Now, then why is it not there in any of the options? Absolutely correct. Alpha belongs to C, everybody. Such a minute piece of information, but a nuclear bomb piece of information. Nobody is asking you to only consider alpha, which is real. You are allowed, you are permitted to take even the imaginary values of alpha or complex values of alpha. So go ahead and solve this equation. Alpha is equals to minus b plus minus root over b square minus 4ac upon 2a. So minus 2 plus minus 2 root 2 iota upon 2. That means minus 1 plus minus root 2 iota. Please check this out. Is this okay? Yes, absolutely correct, Skandesh. Now you have 3 acceptable values, everybody. 3 acceptable values. You want the sum, which means minus 1 plus root 2 iota plus minus 1 minus root 2 iota. So first I will get the sum. This cancels, you get minus 3. This is the sum. First I wanted sum. This is my sum. Now I want the mod of the sum. Now I want mod of the sum, which is mod of minus 3, and that gives me 3 as the final answer. Absolutely correct. Any doubt, anyone? Stop me right now, ask me right now, bug me right now. Is that okay? 1-3 is the right answer. Is that cool? Everybody, are we sorted with these two questions? +8 in your pocket? Yup. Awesome then. Let's go to the next question, everybody. Any doubt? All good, right? All good? Let's go to the next question then. Let me show you the next question on your screen. Here it comes. Yup. Tell me. Alpha is given to you. Be very careful. It's an easy question. It's a very easy question. Alpha is given to you. Beta is given to you. The inverse trigonometric functions are taking principal values. This equation, the very equation whose roots are alpha and beta, it's based upon the formation of quadratic equation. If the roots are known to you, how do you write the quadratic equation? X square minus Sx plus P equal to 0. Any scalar, non-zero scalar times this also works, but in general we say it is x square minus sum of the roots times x plus product of the roots. Everybody, you are aware of this, right? You are aware of this, right? That's the concept which is getting used here. But first, I need to simplify my alpha and beta. If I don't get an easy peasy value of alpha and beta, I will not be able to compute their sum. I will not be able to compute their product, and hence I will not be able to get my equation. So how to solve alpha? How to solve beta? Ma'am, in this, can we assume cos inverse as theta? Yeah, you can. Go ahead. Apply the sine 2 theta formula and tell me if you're getting the answer from that approach. Yeah, you can. Not at all a problematic approach. No. Somebody is saying D. Bhupendra is saying D. बहुत जल्दी कर लिया. Bhupendra is saying D. See, understand the approach which I am inclined to use is, look at this. I'm solving alpha right now. What is this? 2 cos inverse x. I remember 2 cos inverse x. This is cos inverse of 2x square minus 1. How many of y'all remember this? How many of y'all remember this? Yes, 2 cos inverse x is cos inverse of 2x square minus 1. So 2 cos inverse 1 by root 5 is equal to cos inverse of 2 into 1 by 5 minus 1. Yes, this gives you what? 2 minus 5 minus 3 by 5. Okay, this gives you what? Pi minus cos inverse of 3 by 5. Is that okay? See, little bit what I mean is basic of ITF you should know. I am not saying spend too much time on studying ITF, because ITF I know is something which is not a strength for many students. But don't leave the topic completely, people. If we are solving this question, which involves 3-4 results of ITF, and through this question you are getting to revise that chunk of ITF, please do that. Embrace that learning. Okay? Now, this is your 2 cos inverse 1 by root 5. This part has been expanded. Further, we have sine of 2 cos inverse 1 by root 5. This means what? Sine of pi minus cos inverse 3 by 5. Now, sine of pi minus theta is sine theta. This gives you sine of cos inverse 3 by 5. But obvious, people, I will be trying to convert cos inverse into sine inverse. So I have cos inverse 3 by 5. I know cos inverse 3 by 5, let's say, is theta. So 3 by 5 is cos theta. Yes, ma'am, no, ma'am. This is, let's say, theta. This is 3, 5. 25 minus 9 is 16. This gives you 4. So you end up getting what? Sine theta is 4 by 5, or theta is sine inverse 4 by 5. This gives you sine of sine inverse 4 by 5. Obviously, this comes out to be 4 by 5. Is that okay? Is that okay? Now you just want, see, this much part is resolved. Now I want tan 5 by 16 of this quantity. So tan 5 by 16 of 4 by 5 gives you tan of 5 cancels out 1 by 4. Oh, 5 pi by 16. Okay, this is 5 pi by 16. So this is pi by 4. This is pi by 4, and tan pi by 4 is 1. So alpha, something which was looking so fancy, alpha, something that was looking so fancy, is equal to just 1, everybody. It's equal to just 1. Similarly, we can talk about beta. What is beta? Cos of sine inverse 4 by 5 plus sec inverse 5 by 3. Now it's your choice. It's completely your choice. You can convert this into tan also. Tan inverse A plus tan inverse B, you can apply the formula. Even that can work. And eventually you can convert tan inverse into cos inverse. Cos of cos inverse will give you your answer. Another approach can be to convert everything into cos directly. You can first convert into tan, basically tan inverse, apply the formula, then convert into cos inverse, or you can directly convert into cos inverse. Okay, so sine inverse 4 by 5 becomes cos inverse 3 by 5, and sec inverse 5 by 3 will be what? Obviously, sec inverse 5 by 3 will be cos inverse 3 by 5, and outside also there is cos written. Any confusion? Any confusion? I've just converted sine inverse to cos inverse, and sec inverse I have. Yes? Okay. So this gives you what? Cos of 2 times cos inverse 3 by 5. I just told you cos inverse, 2 cos inverse x is cos inverse of 2x square minus 1. So 2 cos inverse x is cos inverse of 2 cos 2x square minus 1. 2 into x square 9 by 25 minus 1. Tell me, minus 7 by 25. This is cos inverse of minus 7 by 25. Tell me. Yeah, sure, Vansh. Take your time. So this is coming out to be minus 7 by 25. That's your beta. You've got alpha. You've got beta. Yes, ma'am, no, ma'am? Same? Very good. Alpha is 1, beta is minus 7 by 25. So the quadratic equation will be x square minus sum of the roots into x plus product of the roots equal to 0. So this gives you x square minus 18x by 25 minus 7 by 25 is 0. So 25x square minus 18x. 25x square minus 18x minus 7. 25x square minus 18x minus 7. D is the incorrect answer, Bhupendra. C is the right answer. C is the right answer. D is the wrong answer. Same. Is that okay? Is this question understood? We have used a lot of results of ITF. Is every result, every conversion clear to you? Because this is a very basic approach to solve such a question. And your aim and dharma and karma is to take away the approach. Whenever you get a question like this, you should know how do you have to proceed, what is the direction you have to follow. And the soul of this question is the result, 2 cos inverse x is cos inverse of 2x square minus 1. But I already told you, you can even take cos inverse of 1 by root 5 as theta and then proceed also. That also works. It will give you the same answer. Hashtag HTCC everybody, high definition, crystal clear. Everyone? Perfect. Awesome job done then. Let's go to the next question now. Everybody brace yourself. Let me take you to the next question. Let's start. Yup. Chalo. I'll give you 1 minute. Try and solve this. If for the complex number z, which satisfies this inequality, maximum value of this expression is attained at a plus iota b, then what is a plus b equal to? So the maximum value is attained at a plus iota b. It is same as saying it is attained at a comma b. Saying that it is attained at a plus ib is same as saying that it is attained at a comma b. What is then a plus b equal to? Circle. Once don't leave complex numbers completely, yaar, please. If you're doing some question which is involving some concept, then please learn the concept through that question. Because if you get a very easy question from a chapter like complex numbers, you literally will go back in the race by a lot of margin. And that is not something that I want. If there is an easy question coming from a tough chapter, you should be able to crack it. But if on the other hand, there is a tough question coming from an easy chapter, you are allowed to leave it. That is the intelligent approach to go about with cracking questions. So don't leave a chapter completely, because if you get a very easy question, even this one is a very easy question in my opinion. If you get a very easy question from this chapter which you've completely left, you will be full of regret, full of remorse, full of pain. Don't do that. Tell me, circle is correct. So when you say z minus 2 plus 2 iota. This mod is less than equal to 1. This is a circle. This is a circle, definitely. The center is 2 comma 2. Radius is 1. Is that okay? If you convert this in the x plus iota y format, this will give you x minus 2 whole square plus y minus 2 whole square equal to 1. I have converted the inequality into equality for now, just for understanding. So 2 comma 2 is my radius, 2 comma 2 is my center, and 1 is the radius. All right, cool, 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 cool. 2 comma 2 is the center, 1 is the radius. Now tell me, inner portion of this circle, very good Priyanshu, when you say mod of z minus z naught is less than equal to 1, that means I want all the points sitting on the circle and inside the circle. I want all the points sitting on the boundary of the circle and in the interior region of the circle. That is what I want. So this is what this represents. What? This. This is what it represents, everything on the circle and everything inside this circle. All right? This is my center. Now, question arises, I want maximum value of this expression. Let's see what this is. 3 iota z plus 6. 3 is common. You get iota z plus 2. Okay, this is mod. So, you get mod 3, which is 3. And this is iota z plus 2. How do you go about solving this? If I take out even iota common, I'll be left with z plus 2 upon iota. This is what I'll be left with, z plus 2 upon iota. But 1 upon iota is minus iota. So I got minus of 2 iota. Now this becomes 3 times mod iota, mod of z minus 2 iota. What is mod iota? Arey baba, mod iota is 1 only, na? So this gives you 3 times mod of z minus 2 iota. This is what I have to maximize, everybody. I have to maximize this expression. Find the maximum value of this expression. What does that mean? Arey baba, English mein pata hona chahiye na. What does this mean? When you say mod of z minus 2 iota, I want to maximize this. This means find z which is farthest from 2 iota. That is 0, 2. Find z from where? Find z from the shaded portion. Find z from the shaded portion which is farthest from 2i. That means 0, 2. I want to maximize this distance. This is the distance I want to maximize. So which complex number out of everything sitting in my shaded region, which complex number is farthest from the complex number 0, 2, which is same as 2i? The distance always is measured along the common normal. Yes or no? Do you know this? Yes. So from this point, I will be drawing my normal, passing through the center. This is my diameter only, na? This is A, this is B. So AB actually is nothing but my diameter. Yes. And this line that I have just drawn, this is my normal. Yes, ma'am? Yes, ma'am? Yes or no? Whenever you want to talk about the distance, it always occurs along the common normal. So from the external point P, I drew a normal, which is a line passing through the center. That gave me AB as a diameter. Now along this normal only, what are the complex numbers sitting? What are the complex numbers sitting in picture? One is this point A, one is this point B. From point B, my point P is going to be at the farthest distance. And what is my point B? Who will tell me? Radius is 1 unit, everybody. Radius is 1 unit. So this will be what? 3, 2. Yes? Yes or no? P is farthest from 3, 2. Sitting in my shaded region. P is farthest from 3, 2. If somebody asks you what is the maximum distance, you calculate the distance between P and B. Calculate the distance using distance formula between P and B. What I am saying, or what the question is saying, is tell me the complex number from where P is farthest. So P is farthest from 3, 2. So 3, 2. This is 3 plus 2 iota or 3, 2, and that is why 3 plus 2 is your answer, which is 5. Is this absolutely correct? Is this absolutely correct? Question didn't ask you to maximize this. Like, don't find the maximum value. Tell me what is that Z in the shaded region which is sitting at maximum distance from 2 iota, corresponding to which this expression will become maximum. Don't maximize it. Question says just tell me the Z sitting in that shaded region which is farthest from 2 iota, corresponding to which this distance is completely maximum, the highest. Is the question clear? Hi Kamlanand, this is a live session going on. Guys, is this clear? Hashtag HDCC. Completely. Yes, that's just for the magnitude. Absolutely correct. Is that okay? Okay, Vansh is saying, ma'am, what about 3? I'll tell you. If somebody asked you, what is the maximum distance? You will say 3 times distance between P and B. That's it. So 3 times PB. This is your maximum distance. If the question said, what is the maximum distance? It was 3 times the length of the PB segment, which means 3 times under root of 3 minus 0 whole square plus 2 minus 2 whole square. This is 3 into 3, which is 9. Okay? So 9 would have come out to be the maximum distance, this distance. From here to here, this distance was 9, which was the maximum distance. But question is not asking me to compute the maximum distance. No. Question is just saying, give me the complex number from where P is maximum, and that complex number is 3, 2 or 3 plus 2 iota. So 3 plus 2 is 5. Okay? Absolutely correct. Not the position, not the Z, but it affects the magnitude, the final answer, the distance it affects. Pretty long. Okay, then is this clear, guys? So questions like these, if you get from complex number, don't leave them. They require some amount of visualization and very basic concept understanding. So through these questions, if you're able to learn the concept, please embrace them, learn them, write them down in your notebook. No need to deep dive into the chapter of complex numbers right now. But through these questions, if some easy and very important, relevant questions are being revised, then please take away. Absorb that. Absorb that. Okay? Let's go to the next question, everyone, then. Okay, come here. The number of elements in this set where I is a 2 cross 2 identity matrix is what? The number of elements in this set. What is the set? Guys, the set has to be checked very precisely. It has all the 2 cross 2 matrices of the form A, B, 0, D, where A, B, D are coming from the set -1, 0, 1. I minus A whole cube is I minus A cube. The moment you see I minus A whole cube, you are getting desperate to apply your identity of A minus B whole cube. It's very natural. As a student, if I think the moment I see I minus A whole cube, I will get desperate to apply my identity of A minus B whole cube. Yes or no? No, Kaylee Hamilton for sure. Yep. Very true. So what I'm saying is here you would want to apply your identity A minus B whole cube. Can you do that? Is that allowed? Answer me. Your thinking is correct, but is it allowed for you to use A minus B whole cube over here in this situation? Is it allowed? Can you do that? Athreya says yes, Vansh says no. Why yes and why no? Very good, Athreya, because I and A are commutative. AI is equal to IA, people, and that is why when it comes to A and I, any algebraic identity will hold valid in the case of matrices. So A minus B whole cube, right? Or A cube minus B cube. This is A minus B whole cube. Is this okay? Huh? A cube minus B cube minus 3AB A minus B. Check this out. Most probably we can 100%. Bhupendra, आप डरा देते हो मैम. अरे तो बाबा reason चाहिए ना. You can't just be doing stuff for the sake of doing it. You have to give me proper logic, proper reasoning behind it. So you get I minus A cube minus 3A plus 3A square. But this is given to be equal to I minus A cube. Okay, fine. So I cube cancels out. You are left with 3a square is equal to 3a. 3 cancels out. A square is equal to a. This is a jumbo conclusion which you have got. Because this conclusion says that satisfying this condition is equivalent to satisfying a square equal to a. So now the question has transformed. It has changed. Now it says a set consists of all the matrices A, B, 0, D, where A, B, D are coming from the set -1, 0, 1, such that A square is equal to A. Let's compute A square. When you say A square equal to A, that means A, B, 0, D into A, B, 0, D is equal to A, B, 0, D. Guys, try and solve this out. Chill. Perfect. Answer is what? 8. Okay, let's see. So this is A squared. This is AB plus BD. This is 0. This is 0 and this is D square is equal to AB 0 D. Now two matrices are same. That means their corresponding entries are same. So what will happen? A square will be equal to A, AB plus BD is equal to B, and D square is equal to D. All these things simultaneously will hold true. A square is equal to A and D square is equal to D and AB plus BD. AB plus BD is equal to B. Chalo then. Let's see what is the intersection of all these three conditions. This is where you have to be a lot focused. When you say A square equal to A, please understand A, B and D can only take values from this set. So when you say A square equals A common, A minus 1 is 0, A is 0 or 1. A can only take two values, 0 or 1, allowed. Similarly, D square equal to D. So D square minus D is 0, D common, D minus 1 is 0. That means D can take values 0 or 1. Chalo, this is also cool. Perfect. A can only take two values, D can only take two values. Now, majorly the condition which will impact my answer is this condition. See, B common A plus D is equal to B. So, B common A plus D minus 1 is 0. Now, guys, please understand, if you want the product of two quantities to be 0, at least one of them has to be 0. Right? So, let's start with both the cases. Case 1, if B is 0. Okay? If B is 0, or rather let me take the first case as B is non-zero. Very good. Let's say B is non-zero. This implies B has only two options, 1 or minus 1, right? If B is non-zero, then B has only two options, 1 or minus 1. Now let's start. You have A, you have B, you have D. If B is 1, A plus D minus 1, A plus D minus 1, this has to be 0. That means A plus D has to be 1. Now for A plus D to be 1, what would you get? A is 0, D is 1, or A is 1, D is 0. Yes or no? Yes or no? If B is 1, then for A plus D to be 1, A 0, D 1 or A 1, D 0. Or what can happen is, let's say B is minus 1. If B is minus 1, then again A plus D minus 1 has to be 0. Yes, that means A plus D has to be 1. That means A 0, D 1 or A 1, D 0. So I am getting 4 matrices. Can you see 4 outcomes for ABD? Every outcome for ABD is giving me 1 matrix. So 4 outcomes for ABD is giving me 4 matrices. So this case is giving me 4 matrices corresponding to B non-zero. What if B is 0? Let's start. Let's start. This is case 2. What if B is 0? Then A plus D minus 1 can be 0 or may not be 0. How does it matter? Baba, if B is pakka 0, then A plus D minus 1 is 0 or is not 0. How do I care? I don't care what A plus D minus 1 is. If B is pakka 0, I don't care what A plus D minus 1 is. Or are you understanding? What is the value of A plus D minus 1? Is this understood? Is this understood? Tell me quickly. So this is A, this is B, this is D, this is 0. And A and D are only allowed to take 0, 1, 0, 1. Now A and D can take anything because I don't care what is the value of A plus D minus 1. It is 0 or non-zero, I don't care. So this will be 1, 0, 0, 1, 1 both or 0 both. That's it. These are your 4 cases, 4 outcomes. Corresponding to case 2, if B is 0, A plus D minus 1 has no condition. It can be 0, it may not be 0. Getting my point? So I don't care what is the sum of A and D. I don't care. I have used all the possible values which A and D can get. A can be 0 or 1, D can be 0 or 1. Accordingly, I have made the permutations. Both 1, both 0, any one 1, other one 0. So here also you have 4 matrices. Is this understood, everybody? Is this understood? 4 matrices, 4 matrices, 8 matrices. Please pull back. Pull back means this. You want to take a screenshot? Take a screenshot. Is this understood? The moment you reach this condition, this into this is 0. At least one of them has to be 0. Let's pick B. If B is non-zero, these 4 matrices. If B is 0, these 4 matrices. In total, 8 matrices. Is it okay? You got it? Very nice question, voluminous question, rich question. Something for which you need to be attentive because there are cases involved, guys. Is this clear? Is this clear? Very good. Yeah. Priyanshu, go ahead. Is it okay? Cool. I'm moving ahead now. I hope this is clear. The commutative property is also something which is very important to understand here. Why are we able to use the algebraic identity of A minus B whole cube? Because I and A are commutative with each other. And after that, the case formation and 8 being the answer. Cool? Chalo. If this question is done, can I move ahead? Plus 4 here. Perfect. Perfect. Come to this question, everybody. Let's take a read. Lambda is non-zero, lambda is real, alpha and beta are roots of this equation, alpha and gamma are roots of this equation. So you have two equations, x square minus x plus 2 lambda is 0. The roots are given to be alpha and beta. Always try to visualize the question statement first. Next says 3x square minus 10x plus 27 lambda is 0. Here it says alpha and gamma are the roots. What does this mean? Very good, Vansh. I am so impressed. So impressed, absolutely impressed. Alpha is a common root. Now question says find out beta, find out gamma, find out lambda. But first we will find alpha. And how will you find alpha? How do you think we have to proceed with finding the common root? Who will tell me? This you have figured out very perfectly that ma'am, alpha is a common root. But how will you find it out? Yes, it satisfies both. Perfect. Because it satisfies both, this is a very good start, Vansh and Priyanshu. Vaibhav, you are perfectly correct. High five. Very, very good, Shiv. Very, very good. Satisfies both, right? You are saying satisfies both. So you get alpha square minus alpha plus 2 lambda is 0 and 3 alpha square minus 10 alpha plus 27 lambda is 0. Let's simplify or solve them simultaneously. I will use my elimination method. Multiply the first equation by 3. This is 3, this is 3 and this is 6. Please subtract. This is plus, then this is minus. So this cancels out. We're left with 10 minus 3. 7 alpha plus 4 lambda is 0. 6 minus 27. This is not. So 21 minus 21. Minus 21 lambda is 0. So this means 7 alpha is equal to 21 lambda or alpha is equal to 3 lambda. How many of you all are getting this? Are you getting this? Alpha equals 3 lambda, everyone? Hi Kavyansh, welcome to the class. Alpha is 3 lambda. What you do is, you plug this value in the first equation. Okay, not this equation, the original one. This 3 and this is 2. Plug it here. Now what is the problem? Plug it here. What do you get? 9 lambda square minus 3 lambda plus 2 lambda is 0. So 9 lambda square minus lambda is 0. Lambda common, 9 lambda minus 1 is 0. Lambda is 0 or 1 by 9. But lambda is given to be non-zero, so I cannot accept 0. That means lambda has to be 1 by 9. That means alpha is what? 1 by 3. Very good. It can't be 0. Very good. Perfect job done. Yes, Shiv, Vaibhav, Vansh, Athreya, Kavyansh, is it clear? So I have got my common root, everyone. Did you realize? This is my common root. I have got the value of common root very easily, and you only have told me how to get the common root. I didn't teach you only. You were telling me in the comments and I was doing just what you were saying. So congratulations. Congratulations. Now, what do you need? Lambda you have, beta you don't have, and lambda you have, but gamma you don't have. Now see, because this has roots and as alpha and beta, I know sum of the roots is minus b by a, which means 1. Which means 1. So you get what? Beta is equal to 1 minus alpha. And what is alpha? 1 by 3. So you get 1 minus 1 by 3, which is 2 by 3. Beta is obtained. Beta is obtained. Similarly, here if you come, sum of the roots is alpha plus gamma. Sum of the roots is alpha plus gamma is minus b by a again, so 10 by 3. Alright, 10 by 3. That means gamma is 10 by 3 minus alpha, which is 1 by 3. So 9 by 3, which means 3. 9 by 3, which means 3. And that is why when you say beta gamma upon lambda, beta is 2 by 3, gamma is 3 upon lambda is what? 1 by 9. What is the answer? 18 is the answer. 54 is not the answer. Somebody was saying 54. 54 is not the answer. Shiv was saying 54. Bache, it's the wrong answer. See, this is what happens. When you feel the question is very simple, sometimes it deceives you. You feel, aha, this is very simple. What happens as a result is you get overconfident, you miss out on the accuracy part, and you end up committing errors and losing your marks. Please, please, please don't get overconfident when you see a question which is familiar to you or which is something that you have solved a lot of times, which is from your strength chapter. Don't get overexcited when you see that question. Don't. Okay? Ma'am, can we use determinant? You can, not a problem. But generally, we don't remember that approach, na? So I'm telling you a generic approach which doesn't create too much load over here. I'm telling you a generic approach which is more logical and more commonsensical. Is it clear? Yes? Is this question hashtag HDCC? Galti se ho gaya Shiv, then acha, okay, fine. Hashtag HDCC, everyone. Every question is highlighting a very important concept, everybody. I'm not saying this question exactly will get repeated, but the concept which I'm sharing with you is something which is a major takeaway from today's class, from every question. Okay, these are not random questions. They have been picked with a lot of brainstorming from last 10 to 15 years. Okay, chalo. Let's go to the next question now. Yup. Very famous, very common, has been repeated so many times, and I believe you should know the shortcut to crack it. By now, you should know the shortcut to crack it. A is given to you as a 2 cross 2 matrix. B is also 2 cross 2. Q is given to be A transpose B A. Inverse of this matrix is what the question asks. Question is not asking you to give this matrix. It says give me the inverse of this matrix. A Q to the power 20, 21, A transpose whole inverse. This is the ask. Very, very good. Very, very good. Very good. That means you people have solved some PYQs. Very good. See, first of all, when you say A Q to the power 20, 21, A transpose, this means A into Q into Q into Q into Q and so on into Q into A transpose. How many times I've written Q? 20, 21 times. Chalo, cool. But what is Q? It is A transpose B A. So you will get A here. Again, A transpose B A. Then A transpose B A. Understand? One last time and then you can remember this as a result. A transpose B A and so on. A transpose B A and then there is a A transpose. Again, how many times are you getting this? 20, 21 times. Now listen to me carefully. A into A transpose using the associative law. A into A transpose, A into A transpose, A into A transpose, A into A transpose, A into A transpose. How many times? 20, 21 times. Yes or no? But what is A into A transpose? As so many of you all are saying, which is absolutely correct. A into A transpose. What is A? 1 by root 5, 2 by root 5, minus 2 by root 5 and 1 by root 5. This into its transpose. So row becomes the column. So 1 by root 5, 2 by root 5 and then minus 2 by root 5 and then again 1 by root 5. Okay, so A into A transpose, this will come out to be I, everybody, which is 1, 0, 0, 1. 2 cross 2 identity matrix. So that means you are getting I raised to the power 20, 21. And B is being multiplied with itself how many times? B into B into B into B into B, 20, 21 times. This is the magic. This is the magic. You started with A into Q to the power 2021 went to A transpose. You are getting just B to the power 2021. That's the magic. You can remember it as a result over here. When you raise Q to the power N, that means you are raising this to the power N. It will end up coming out to be just B to the power N. This is the result I want you to remember. Provided A transpose is identity. Remember it as a shortcut. Yes, absolutely correct, Sahil. Absolutely correct. Is this okay? Now, if you want B to the power 2021, how would you proceed? Arey Baba, B to the power 2021. How will you proceed? First, you calculate B square. This will be 1, 0, iota 1 into 1, 0, iota 1. Please calculate. 1 into 1 gives you 1. This is 0. This is I plus I, 2I, and this is 1. When you calculate B cube, everybody, you will get 1, 0, 2I, 1 into B. B is what? 1, 0, I, and 1. So this becomes 1, this becomes again 0, 2I plus I, 3I, and this is 1. I am able to see a pattern. Can you see this? B to the power 2021 will be 1, 0, 2021 iota, and then 1. This is my B to the power 2021. It is 1, 0, 2021 iota, and then 1. What do I want? I want inverse of this matrix. What I want A Q to the power 2021, A transpose whole inverse. That means I want, what is this equal to? B to the power 2021 whole inverse. That means inverse of what? 1, 0, 2021 iota, and then 1. This inverse I want. And inverse of a matrix is adjoint of that matrix upon determinant of that matrix. Adjoint of that matrix upon determinant of that matrix. What is the adjoint? Adjoint upon determinant, isn't it? What is the adjoint? Adjoint of a 2 cross 2 matrix. Interchange the diagonals and put a minus sign in front of the off diagonals. This is 0. This becomes minus 20, 21 iota. Divided by the determinant. Determinant is just 1. So 1 upon 1. Is this clear? That means inverse which you are searching for is coming out to be 1, 0, minus 20, 21 iota, and then 1. That's your answer. Yup, for a 2 cross 2 matrix, it will be you interchange the diagonals, interchange their positions. Right now, the both are 1, so doesn't impact my interchanging, and put a minus sign in front of the off diagonals. Put a minus sign in front of the off diagonals. Interchange the diagonals and put a minus sign in front of the off diagonals. If it is a 3 cross 3 matrix one, then you have to actually compute the cofactors. And then transpose of the cofactor matrix will give you the adjoint of that matrix. First you compute the cofactor matrix, take the transpose, you will get the adjoint of that matrix. Okay, very, very good. Shreyansh ne likh diya hai. Take a note, everybody. Is this okay? Is this question clear, everyone? B is the right answer. So something to remember, something to take away, something to actually catch as a result is this fact which I told you, that A Q to the power 2021 A transpose is nothing but B to the power 2021. Please remember this. Otherwise, of course, you can also do it again, but to save time, definitely remember. Okay? Is this understood? Hashtag HDCC, everyone. Perfect. Perfect. Let's take our discussion to the next question. Very nice question, guys. Take a look. Set of all values of k greater than -1 for which this equation has real roots. Now, this equation is not a very ordinary equation. See, this is a quadratic expression raised to the power 2. K plus 1 into quadratic, again a quadratic, plus k times quadratic whole square is 0. How do you think you will go about solving this question? Tukka. Tell me. What substitute, Priyanshu? What substitute? किसको? What do you want me to substitute t as? What? Look carefully. You have 3x square plus 4x plus 3. Here you have 3x square plus 4x plus 3. Here you have 3x square plus 4x plus 2. And here again you have 3x square plus 4x plus 2. So ideally 3x square plus 4x plus 2 should be taken as t. So what you get at the end is t plus 1 whole square, because there is a plus 3, minus k plus 1 times t plus 1 into t plus k times t square is 0. Please check this. Is this okay? Huh? Is this okay? That means you get what? T square plus 1 plus 2t minus k plus 1 times t square plus t plus kt square. So what is the answer? You get t square plus 1 plus 2t minus kt square minus t square minus tk minus t plus kt square. This cancels out. This also cancels out. You are left with what? Huh? It will work. It is working. See, 2t minus t is t, and then there is a plus 1, and that's it. Plus 1 minus tk is 0. Right? Right? So t common, 1 minus k plus 1 is 0. How do you plan to work with this? Or you can write this as k minus 1 times t is equal to 1. Same thing. Same thing. How are you planning to work with this? Now understand, please understand, when you have solved this using substitution, the conclusion is k minus 1 times t is equal to 1. So k minus 1 times t was 3x square plus 4x plus 2. This is equal to 1. Yes? Yes ma'am, no ma'am. So this gives you 3 times k minus 1 x square plus 4 times k minus 1 x plus 2 times k minus 1 minus 1 is 0. So 2k minus 2, this is what? 2k minus 3. Can I write it like this? This completely will be 2k minus 3. Now people, please get this straight that this has real roots. X is representing the roots of this equation. Na? This is the same equation which was written in such an expanded form in the question. It is the same equation which we have written over here in such a simplified version. Because it has real roots, its discriminant is going to be non-negative. So b square minus 4 into a into c is non-negative. Solve this. Solve this. This is 16 k square plus 1 minus 2k and then minus 12. This is k minus 1 into 2k minus 3. Let this be k minus 1 whole square only. Huh? Tell me. Solve this, guys. Absolutely correct. Greater than equal to 1. Very good. D has to be greater than equal to 0. See, k minus 1, 5 minus 2k is greater than equal to 0. Please check this out. Please check this out. Are you getting this? Yes, ma'am. No, ma'am. If you want, you can open this up as well. This will give you 2k square minus 3k minus 2k plus 3. You get 2k square minus 5k plus 3. And this one, when you open, you get k square plus 1 minus 2k. Okay, that's it. That's what I've done. Here and here, both these quadratics I've subtracted along with a 16 scalar here and 12 scalar here. Are you getting this, Nishant? Very good. Atriya, solve it out. Please solve this. Quadratic. That is quadratic. Solve, simplify. Are you getting k minus 1 into 5 minus 2k non-negative? Nishant is getting. Anybody else? Anybody else? Please check this out. Please solve this. The moment you get these two values, you get what? 1 here, 5 by 2 here, plus minus plus. Greater than equal to 0. When you say greater than equal to 0, what do you need? Yes, very good. Very good, Parag. Very good, Priyanshu. When you say greater than equal to 0, that means k has to be less than equal to 1 or greater than equal to 5 by 2. Can it be less than equal to 1? I think this has to be less than equal to 0. Guys, please check this out. Is this less than equal to 0? Bhupendra, Vansh, Priyanshu, please check. Is this less than equal to 0? K is less than minus 1. Please tell me, is this less than equal to 0? Huh? Any doubt, anyone? Yes, ma'am. Parag is saying yes. Anybody else? Please solve this, people. You didn't change the sign of k. That's what I'm saying. When I change the sign, my greater than equality will convert into less than equality. So accordingly, what I am getting is k belongs to closed 1 comma 5 by 2 closed. But there is a catch. There is a catch. Can k be 1? If k is 1, if k becomes 1, then this will not be satisfied. If k becomes 1, I will get 0 into something equal to 1. That is a contradiction. That means k is not allowed to be equal to 1. I will have to keep an open interval sign at 1. So k belongs to open 1 closed 5 by 2. Very, very good, everybody. I am so impressed. Quadratic will be very, very good. If k is 1, there is a panga. If k is 1, there is a panga. K is not allowed to be equal to 1. Yes, it says k is greater than minus 1, but the realization that k cannot be 1 is something which we have to come up with. K cannot be 1. The moment you write this step, it should pop up in your head that Baba, k is not allowed to be equal to 1. Okay? Okay, open interval, Parag. Perfect. Bhupendra, yes. Is it okay? Okay, fine. Chalo. Is it okay? So open 1 closed 5 by 2. Open 1 closed 5 by 2. The moment you get a question like this, people, this is forming a variety. You should know what you have to do. Use the concept of substitution. The moment you have it in terms of t, you know what you get. You get k minus 1 times t equals 1. Now you substitute back your t and now you get a quadratic which is manageable. And that is where you use the fact that it has real roots. Real roots means d non-negative, and then you are solving it using the wavy curve method. You get the answer. Okay, fine. Chalo, let's go to the next question now. I hope this is clear. This variety is clear to you. Next question, everyone. This one I want everybody to smash. Please kill this question. For my sake, kill this question, guys. Please kill this question. Kill it, smash it, completely conquer it. The only thing that you need is adjoint of k times a is k to the power n minus 1 times adjoint of a. And another result is determinant of adjoint of adjoint of adjoint of adjoint of a. Where I've written adjoint, let's say k times. And this is equal to determinant of a to the power n minus 1 to the power k. Property alert. Hashtag property alert. So write it down first. English को math में convert करते हैं. So you get determinant of 2 times adjoint of 2 times adjoint of 2a. All right. This is 2 to the power 41. Cool, not a problem. Let's start with the innermost adjoint. So adjoint of 2a is 2 to the power n minus 1 times. That means 2 to the power 4 times. 4 times n minus 1 is 3 minus 1, which is 2. So 2 square times. That means 2 times adjoint. Then again 2 times adjoint. 2 square adjoint of a. Is it cool? Please check this. This is 2 square means 4 times adjoint of a. Again same logic everyone. Adjoint of 4 times a matrix. Adjoint of 4 times a matrix, 4 comes out with power 2, n minus 1. So 2 into 4 to the power n minus 1, you're left with adjoint of a. Check this out carefully. Outside adjoint is sitting as it is. This is 2 and that's it. Yes? Clear? Clear? Again the same logic, Baba. What is 4? 4 square 16. 16 into 2 is 32. So this becomes 32. Again, adjoint of constant times a matrix. Adjoint of constant times a matrix, this constant will come out with a power 2. So you get 2 into 32 square adjoint of a equal to 2 to the power 41. Now comes a property which I didn't tell you will be used, but it is being used. Determinant of k times a is k to the power n times determinant of a, n is the order of a. Similarly here, this complete constant is sitting like a scalar. It will come out of the determinant with the power of this, the order of this matrix. With what power? Order of this matrix. What is adjoint of adjoint a is order? It is 3. So this constant will come out with power 3. You will be getting 2 into 32 square to the power 3 determinant of adjoint of a. Perfect. Is 2 to the power 41. Now 2 cube 32 to the power 6. Determinant of adjoint of a is determinant of a to the power n minus 1 to the power 3. See this. This is 2 to the power 5. So this is 30. 30 plus 3 is 33. So 2 to the power 33, determinant of a to the power 8 is 2 to the power 41. So determinant of a to the power 8 is 2 to the power 8. Yes, that means determinant of a is plus minus 2. Yes, is this clear? Is this clear, everyone? Many properties I have used. Many properties. Actually, these 3 properties, but I've used them multiple times again and again as per the demand. And I've just used my focus and undistracted attention to get this question right. I want determinant of a whole square. Yes or no? What do I want? I want determinant of a square. See, determinant of a square is determinant of a whole square. Determinant of a is plus 2 or minus 2. Whole square will give you 4 as the final answer. Any doubt? Are the properties clear? Are they on your fingertips? Is this question clear? Hashtag HDCC plus 4. Very good. Very good, guys. Very good. Okay, I'll move on to the next question now. Chalo. Yep. Now you might say, ma'am, this seems like a calculus question. Why have you brought it in the section of algebra? But let's see. Let's see how do you plan to attack this. Let's see how do you plan to attack this. It's a very, very, very nice question. This is a must do, people. Not because this question might repeat, but the approach which this uses to get cracked is something that you must know. You must know the approach. As a JEE aspirant, if this approach is something that you are not comfortable with, then you are not prepared for the exam. It is that important. It's like one of the organs that a person has. Without it, you're incomplete. Without this, your preparation is incomplete. Yup, somebody is saying, e to the power x ko t le lo. Cool, let's take that. That means t is positive. T is pakka positive, na? E to the power x is completely above the x-axis. This is positive. So what is f of t equal to? This is t to the power 4 plus 2t cube minus t minus 6. Number of real roots is what I want. Now there are two approaches, everybody. I want number of real roots of this equation. There are two approaches. I'll tell you, there is a method 1 and there is a method 2. Now what do students do generally is, they break this function into two different functions. They take it as t to the power 4 plus 2t cube equal to t plus 6. Now how do they proceed? I want number of real roots of this equation, means I want all those real values of t for which my left hand side function is equal to my right hand side function. So they start plotting both these functions on the same Cartesian plane. Let's do that. Let's try and do that. Okay, let's try and do that. When you say t plus 6, y equal to t plus 6, that means when, or x plus 6, when x is 0, y is 6. When y is 0, x is minus 6. So it will come out to be something like this. This is, let's say, your t plus 6 line. Okay, fine. One thing is sorted. This is 6 here, this is minus 6 here. What about t to the power 4 plus 2t cube? T to the power 4 plus 2t cube, let's say this is g of t. So if I take g dash t, this will be 4t cube plus 6t square. So you get what? 2t square as it is, 2t plus 3. Yes ma'am, no ma'am. So minus 3 by 2 is a critical point. Minus 3 by 2 is a critical point. 0 is an inflection point. I don't care. But minus 3 by 2 is a critical point. Yes? No. No, it's not. No, it's not a critical point because t is e to the power x, which is always positive. No matter what value of x you put, e to the power x is always positive. So 2t square into 2t plus 3 is always positive for every t. So g dash is positive means this function, left hand side function, is strictly increasing. At 0, it's 0 and it is strictly increasing. It is strictly increasing. Yes, very good. It is strictly increasing. Now the problem with this method 1 is, this is your t to the power 4 plus 2t cube. The problem with this approach is, I don't know when and where these two functions will meet. I don't know. And we can't comment upon this precisely. It's difficult, it's doubtful, it is a bit iffy. And that is why this is the approach which I do not recommend students to follow. Don't try to always plot individual functions. Plotting two individual functions and then studying their interaction is recommended in few cases, but here, for example, it's not. How will method 2 serve right for me? I'll tell you. See, what is f of t? It is t to the power 4 plus 2t cube minus t minus 6 equal to 0. Let's start. Let's take out f dash. This is 4t cube plus 6t square minus 1. Now listen to me carefully. First of all, this is a biquadratic polynomial, yes? So, as t tends to infinity, f tends to infinity. As t tends to infinity, f tends to infinity. Yes? And I want only tends to infinity because t is a positive number. My graph will only be drawn corresponding to the positive x-axis. So I'm not interested in t tending to minus infinity. It will never tend to minus infinity. My aim is to plot the graph of f of t, where t is e to the power x. It is always positive. So my entire graph of f will be drawn corresponding to the positive x-axis. Okay, so I am interested in t tending to infinity, not minus infinity. When that happens, even f tends to infinity. Cool? Is that understood? But the problem is, that's okay. This is fine. Also, f of 0 I know is nothing but minus 6. Chalo, cool. This is so fine. This is so fine. This much analysis is fine. But what about the change in the increasing decreasing manner? What about that? I need the critical points now, but there is a problem in getting the critical points. This is a cubic polynomial. And in order to get the roots of a quadratic polynomial, it's very simple, but to get a cubic polynomial and its roots, it's very complicated again. I will have to use my hit and trial method, then I will use the long division method. Is there an easy way to kind of reach to the analysis of f dash so that I can comment upon the increasing decreasing part, the minima maxima point part? Is there any approach? Is there any alternative? Yes, ma'am, there is. See, I want the analysis of f dash. Right now, I'm not able to comment anything upon f dash because it's a cubic polynomial. So let me, and listen to this carefully, people. This is the approach I was talking about. Let's take this to be g of t and compute g dash t, which technically is f double dash t. This will come out to be 12t square plus 12t. This gives you 12t common t plus 1. Okay, and what does this mean? Everybody, what does this mean? T is e to the power x. This is positive. So you technically are getting f double dash positive. This means f is concave up. ठीक है भाई? F is concave up throughout the positive real axis for all t positive. F is concave up, but also g dash is positive, which means g is strictly increasing. Baba, there are two perspectives. No, one is to see this as f double dash. One is to see this as g dash. So when g dash is coming out to be positive, that means g is strictly increasing. G is strictly increasing. What is g? What is g? G is 4t cube plus 60 square minus 1. 4t cube plus 60 square minus 1 and g dash is positive. Also, bachche, g of 0 is equal to minus 1 and as t tends to infinity, g tends to infinity. It's a cubic polynomial, Baba. That means if I start plotting the graph of g, at 0 it's minus 1 and then it is strictly increasing, tending to infinity. What does this tell you? That g is intersecting the x-axis exactly once. Let's say at alpha. Is this clear? At 0 it's minus 1. After that it's strictly increasing. That means it definitely from bottom to top. To go from bottom to top, it will have to cut the x-axis at least once. Intermediate value theorem. But because it is strictly increasing, it will cut the x-axis exactly once. Let's say at alpha. So g dash, or rather g of alpha is 0. Alpha is the only root of g. This means alpha is the only root of f dash. This means alpha is the critical point for f now, everybody. When you plot alpha, what can you see? Before alpha, g is negative. After alpha, g is positive. That means in the neighborhood of alpha, f dash is changing its sign from negative to positive. That means alpha is the point of minima for f. Alpha is the point of minima for f. Alpha is the point of minima for f. Yes or no? Alpha is the point of minima for f. Huh? Tell me quickly. Alpha is the point of minima for f. What is the question saying? Number of real roots of this equation. How many real roots will there be? Arey Baba, it's now to very easy na. It's now very easy when it comes to f now. Let me change the color. Let me go back to f. At 0, it's 0. At alpha, it is attaining its minimum value and going like this. See, what was f of t, everyone? It was t to the power 4 plus 2t cube minus t minus 6. Oh, at 0, it's minus 6 and then like this. Yeah, this is the correct graph. At 0, f is minus 6. At alpha, it's attaining its minimum value and then going up. Decreasing before alpha, increasing after alpha. Tell me. Any problem, anyone? Stop me right now and tell me. Ma'am, we could have just thought logically. Oh, tell me how. Tell me how. Tell me now how. Priyanshu, is this hashtag HDCC, everybody? Guys, I want your vote on this question. This is very important. The moment you got your f dash as a cubic polynomial, After this, we did not analyze that cubic polynomial. What did we do? We took it as an individual function, and that is what we differentiated further. So G dash came out to be positive, which means F double dash was positive. F is concave up. You can see, yes, F is concave up. There are two ways of concave up. Now, one is it could have gone simply like this. At 0, it's -6, gone like this, concave up. Other was like it is going right now, which is this. So, two ways of concave up. Two ways of concave up. For that, I wanted the point of minima and maxima's analysis. I found out only one point of minima, and that is why this is the concave up, which happens to be the case. Okay. Actually, two concave up fashion. There are two fashions of concave up which F would have adopted. Out of the two, which one it adopted? This one, because there is a point of minima at alpha. See, a lot of what you are saying is what I have done only. Is it that because I'm explaining, it is taking time? Otherwise, it's the same. Okay. If you are able to visualize, it's great. Is it cool, people? Are we done with this question? Is the approach clear? Hashtag HDCC, everyone. Perfect. Now, come here and tell me, how do you plan to solve? How do you plan to solve? The system of equations has no solution if k is equal to. Hashtag HDCC. High definition, crystal clear, Hanish. This system has no solution. But this system is a non-homogeneous system. If it has no solution, Vansh is saying Cramer's rule. This system has no solution. What does it mean? Very interesting question, people. Kx plus y plus z is 1. X plus ky plus z is k. X plus y plus again kz is equal to k square. It's a non-homogeneous system. And this has no solution. This means del to pakka has to be 0. Del to pakka has to be 0. Now, after this, we have to check at least one out of del 1, del 2, del 3 is non-zero. Right? But del is pakka 0. If you compute del 0, you will get k 1, 1. 1 k 1 1 1 k. This is 0. Can you solve this and tell me what are you getting? Expand with respect to any row and tell me what are you getting. See, you are going to get k into k square minus 1 into k minus 1 plus 1 into 1 minus k. This is 0. So you are getting k into k square minus 1 minus of k minus 1 and minus of k minus 1. So minus 2 times k minus 1 is 0. So k minus 1 as it is, k into k plus 1 minus 2. You get k minus 1, then you get k square plus k minus 2 is 0. This is what? K minus 1 into k plus 2. And this is again k minus 1. Is this what you are getting? Is this what you are getting? Let's see. Don't jump. Don't, please, bache, this one thing I really want to say. I know there are many topics which you have excelled, which you've mastered, you've studied a lot, revised them. But don't try to jump on the conclusion, because this is where I feel the most pain. When you know the question, you know how it's solved, you know the approach, you know the strategy, but you're so excited, you're so overconfident that in that excitement, in that overexcitement and overconfidence, you screw up the question. You screw up the calculation and you end up getting the wrong answer. Okay? How k plus 2? See, na? Arey baba. K square plus k minus 2. What is it? K minus 1 into k plus 2, na? Break the middle term. K square plus 2k minus k minus 2. Yeah? Just breaking the middle term. Nothing else, Vansh. Breaking the middle term. And already there is a k minus 1 here. So you get k minus 1 whole square into k plus 2. So k is technically coming out to be 1 and minus 2. Achha. Now the problem starts, and listen to me carefully. If k is 1 and minus 2, now the problem starts. Why? I don't want you to compute del 1, del 2, del 3. Cramer's rule is not something which will help you save your time. You have to make sure you apply the killer shortcut, guys. You have to apply the shortcut. What is the shortcut? Consider these three equations as three planes, na? And now you plug in the values of k. When you plug in k as 1, your equations become what? Your equations become x plus y plus z is 1. Again, x plus y plus z is 1. Again, x plus y plus z is 1. Can you imagine? This is corresponding to k equal to 1. All the three planes are actually identical, which means infinitely many solutions because they are turning out to be coincident planes, one on top of the other. Basically, they are one only. Distinctively, there is only one plane. These three are having every point in common. So, infinitely many solutions. So, k equals 1 is not my answer. I cannot accept it. What about k equal to minus 2? If I take k as minus 2, let's see what I get. So, minus 2x plus y plus z is 1. Again, x minus 2y plus z is k. And again, x plus y minus 2z is equal to k square. Now, k is again minus 2. K square is again 4. Now tell me, how should I somehow make them interact with one another to get my desired output? What I mean is, pick up any two planes. This is plane 1, this is plane 2, this is plane 3. Pick up any two planes. Try to get a linear combination which is comparable with the third plane. Pick up any two planes and try to come up with their linear combination, any of their linear combination which is comparable with the third plane, the left out plane. Which one do you think is going to work? See, it's very simple. 1 plus 1 is 2 and here is a minus 2. If I go ahead with P2 plus P3, I will get 2x minus y minus z is equal to 2. And if I now write P1, I get minus 2x plus y plus z is equal to 1. So if I consider minus P1, I will get 2x minus y minus z is equal to minus 1. That means, bache, this is 2, this is 2, this is minus 1, this is minus 1, this is minus 1, this is minus 1. So the DRs of both of them are same. The direction ratios are same. That means both these planes are, bache, parallel. Both these are parallel, but their right hand side constants are unequal. Because their right hand sides constant are unequal, they are parallel with some positive distance between them, which means they are not touching or intersecting or cutting each other, which means there is no solution. This means there is no solution. So k equal to minus 2 is accepted, but k equal to 1 was rejected. The only brainstorming is you have to come up with a linear combination of any two planes which is comparable with the third plane. Like in this case, they both are comparable now. They have the same DRs. That means they are parallel. Now check the right hand side constants. Because they both are drastically unequal, that means no solution. Parallel and non-intersecting. Clear? So please don't use your Cramer's rule, people. No use. Please go ahead and use the shortcut which I've taught you n number of times. Again, I've taught you today. All right? Chalo. Come to this question now. Around 150 should be your target. Harnish. Okay. Acha, okay. Around 10 questions. Try to attack 9 to 10 questions perfectly. Not just attack, kill them. Z1, Z2 are two complex numbers such that argument of Z1 minus Z2 is pi by 4. Z1, Z2 satisfy this equation. Imaginary part of Z1 plus Z2 is what? Now you have to make sure you understand whenever the locus is not identifiable, convert your Z as x plus iota y. So you will get mod of Z minus 3 means x minus 3 plus iota y. X minus 3 plus iota y is real part of Z. This is under root of x minus 3 whole square plus y square equal to x. So squaring both sides, this is what you get. Yes, that means x square plus 9 minus 6x plus y square equal to x square. This cancels out. You are left with y square equal to 6x minus 9. What is this, people? What is this? Y square equals 6x minus 9. What is this? Who will tell me? 6 common, x minus 9 by 6 is 3 by 2. What is this? Yes, absolutely correct. It's a parabola. Did you imagine? We are doing complex numbers and parabola has come into picture. We are doing complex numbers and from somewhere parabola has popped in. 4a here is equal to 6, which means a is nothing but 3 by 2. The vertex is 3 by 2 comma 0. So that means, see what's happening is, understand the language, people. 3 by 2 comma 0 is your vertex of the parabola. All right, not a problem. This is 3 by 2 comma 0. Question says Z1, Z2 are complex numbers which satisfy this equation, which means Z1 and Z2 are lying on this parabolic curve. Z1 and Z2 are lying on this parabolic curve. Z1 and Z2 are lying on this parabolic curve such that when you join Z1 and Z2, this angle is turning out to be of 45 degrees, which is pi by 4. Argument of Z1 minus Z2 is pi by 4. So when you connect Z1 and Z2, when you join Z1, Z2, the angle which it makes with positive direction of x-axis is equal to pi by 4. Is this clear? Very good. Very good, Priyanshu. Very good, Kamalanand. Very, very good. Shifted. Perfect. Okay. Now see, what is Z1? AT square comma 2AT. A is what? 3 by 2. So A t square comma 2 into 3 by 2 into t. So 3t. And this is what? AT2 square. This is T1, let's say. Okay. So 3 by 2 T2 square comma 3T2. All right. All right. What is the question saying? Z1, Z2 are satisfying this imaginary part of Z1 plus Z2. Now make sure you please realize this, that this line joining Z1 and Z2, let's say is L. In that case, slope of L is equal to tan 45, which is 1. So slope of the line joining Z1 and Z2 is equal to 1 because the angle of inclination is 45. But I know using the 2-point form also I can get the slope, na? y2 minus y1 upon x2 minus x1. y2 minus y1 upon x2 minus x1. So 3 times t1 minus t2 upon 3 by 2 times t1 square minus t2 square. So t1 plus t2 into t1 minus t2. Obviously t1 and t2 are distinct quantities. So you are getting what? 3 cancels out, 2 upon t1 plus t2. This is something which you can remember as a result as well. This is something you can remember as a result, but even if you don't remember, deriving it is just going to take a few extra seconds. So not a problem at all. Not a problem at all. This means what? This simply means t1 plus t2 is equal to 2. Now, what is your agenda? Your agenda is to find the imaginary part of Z1 plus Z2. Z1 plus Z2's imaginary part is imaginary part of Z1 plus imaginary part of Z2. So, this is 3 times Z1, 3 times T1 and 3 times T2. Yes or no? So, 3T1 plus 3T2, which is 3 times T1 plus T2. But T1 plus T2 I just found out is equal to 2, and that is why 6 is your final answer. Wasn't this a brilliant question? Huh? It's literally a brilliant question, everyone. Yes, ma'am? No, ma'am? Is this understood? Of course you can. Of course you can. Not a problem, Priyanshu. Not a problem. See, whenever the locus is not identifiable that clearly, you can use your z equals x plus iota y, convert it to Cartesian, not a problem. Okay? Is it okay, everyone? Have you understood? Have you understood? This question somehow involved conic sections and that too parabola in a very beautiful form. So I hope the blend is appreciated and the approach is also absolutely clear. Okay? Oh. See, when you say argument of z minus z1 equals alpha, that means the line segment joining z and z1 like this. So let's say this is z and this is z1. The angle which the line segment joining Z and Z1 makes with the positive direction of x-axis, that is theta. So you say argument of Z minus Z1 is equal to theta. This is what it means. So here it was written argument of Z1 minus Z2 is pi by 4 and Z1, Z2 are lying on the parabolic curve. So I joined them and there the line joining them, that line makes an angle of 45 degrees with the x-axis. That is the meaning of this expression. Got it? Yes? All right. Perfect then. Perfect. Let's go to the next question, everyone. Please brace yourself. Yup. Chalo, tell me. Consider the quadratic equation. Let S be the set of all integral values of C for which one root of this equation lies in this interval, other one lies in this interval. Let S be the set of all integral values of C for which one root lies in 0, 2. Acha. One root lies in 0, 2, other one lies in 2, 3. One root lies in 0, 2, other one lies in 2, 3. Now there are two cases here. I'm just imagining and this is coming in my head. Right now, I don't know what is the sign of C minus 5. Sign of C minus 5 can be positive or negative. It obviously can't be 0, otherwise this will not be a quadratic equation. So it can be ideally positive or negative. Yes. If it is positive, that means it's an upward opening parabola with one root lying between 0 and 2, other one lying between 2 and 3. But if let's say it is negative, this is 0, this is 2, this is 3, even if it's negative, even then I will have such a situation where one root is lying between 0 and 2, other one lying between 2 and 3. What is the problem? There is no problem. Yeah, Vansh, everything. What is the problem? Is there a problem? Is there a problem? B, C minus 5. Okay, C minus 5 is positive or C minus 5 is negative. Is there a problem? If C minus 5 is positive, I want one of the root to be between 0 and 2. That means what is the situation coming out to be? F of 0 positive, F of 2 negative. Yes, that means F of 0 into F of 2 negative. Similarly here, if I want one root to be between 0 and 2, what is the outcome? F of 0 negative, F of 2 positive. That means F of 0 into F of 2 negative. And I also want another root to be between 2 and 3. So in the first case, I have F of 2 negative, F of 3 positive. That means F of 2 into F of 3 negative. And also in the second case, I have ulta. I have ulta now. F of 2 positive, F of 3 negative. F of 2 positive, F of 3 negative. But again, the product is negative. So no matter C minus 5 is positive or negative, the conditions are coming out to be exactly the same, everyone. The conditions are coming out to be exactly the same. So please don't brainstorm upon whether it's an upward opening or a downward opening parabola, because the leading coefficient is given to you as C minus 5, which is not a fixed definite real number. The only thing which you know as a matter of fact is that C is not equal to 5. Otherwise, my equation will not remain quadratic. Is this okay? Is this okay? So the first thing is F of 0 into F of 2 negative and F of 2 into F of 3 negative. So F of 0 gives you what? C minus 4. F of 2 gives you what? 2 square is 4 times C minus 5. Minus 2 into 2, 4. 4C plus C minus 4 is negative. So what is the answer? Very good. Very easy inequality. 4C minus 20 minus 4C. 4C cancels out. Plus C minus 4. What is the answer? Yes. Less than 0. You get a 4 here, 24 here, plus minus plus. C belongs to 4, 24. Is this what you are getting? Next part is F of 2 into F of 3. F of 2 again is 4 times C minus 5 minus 4C plus C minus 4. This is F of 2. F of 3 is 9 times C minus 5 minus 3 into 2, 6C plus C minus 4 is less than 0. Check this out. This part though was C minus 24. Next one is, yeah, that also you can do. Not a problem. This is negative. So you are getting 49 by 4. 49 by 4 and 24 again plus minus plus. C belongs to 49 by 4, 24. So obviously, what is the intersection? What is the intersection? It's very simple. this is 4, this is 49 by 4, and this is 24. So one part says it lies here, one part says it lies here, so intersection is this. So C belongs to 49 by 4, comma 24. 12 point something, open bracket. So integral values. Tell me, S is the set of all integral values of C. That means C can take what all values? 13, 14, 15, 16 till 23. How many values, everybody? 11 values. It says number of elements in set S is 11. 12 nahi Shiv, 11. Please tally. 23 minus 13 gives you 10 plus 1, 11. Please tell me if there is any doubt, any confusion. Stop me right now and ask me. Is it clear? Is it clear? Yes, we have used the concept of location of roots, and here the only catch was that you could have been confused that the sign of C minus 5 is positive or negative. If it is positive, I have such a situation. If it is negative, I have such a situation. But it doesn't matter because eventually the conditions that I am getting to work with are exactly photocopy the same. So don't bother about C minus 5 being positive or negative. Just bother about C not being equal to 5. Is there C equal to 5 present in my set? No. If it would have been present, I would have removed it. Right now, it's not present. I am taking all the 12 point something values from that point onwards. So 5 is very far. 5 is not there in my solution set. If it would have been there somehow, I would have removed it in the end. That is the only take care you have to do. Okay? All right, people. Let's go to the next question now. Please brace yourself. Yep. This is the next question. Very nice question. Let the lines this and this. These are lines. This is one line. This is another line. These are all lines, everybody. Let the lines be normal to a circle C. This line is tangent to circle C. What is the radius? Just imagine, the question is very simple, but they have just given you the equation of the lines in the format of complex numbers, Z. That is why this question becomes tough. Otherwise, the language is very simple. There are two lines which are normal to a circle. If I intersect both the normals, if I solve both the normals simultaneously, I will get the center. I have a line which is tangent. Distance from the center to the tangent will give me the radius. Done. Question is done. The only problem is, what are the lines? What are the lines? Let's start. Line 1. Plug in Z as x plus iota y. 2 minus iota into x plus iota y is equal to 2 plus iota into z bar x minus iota y. So you get 2x plus 2 iota y minus iota x minus iota square. This gives you plus y. This is again 2x minus 2 iota y plus iota x minus iota square. So plus y. So plus y cancels out. 2x cancels out. 2 iota y plus 2 iota y is 4 iota y, and iota x plus iota x is 2 iota x. Iota cancels out. 2 cancels out. You get 2y equal to x. This is your line 1. Can you imagine? Can you imagine such an easy peasy line they've given us in such a complicated fashion? That is why complex numbers is not that complex, how much you have defamed it. Huh? Line 2. Line 2 is 2 plus iota into z is x plus iota y plus iota minus 2 into x minus iota y minus 4 iota is 0. So this gives you what? 2x plus 2 iota y plus iota x plus iota square. So minus y plus iota x minus iota square is plus y minus 2x plus 2 iota y minus 4 iota is 0. Now tell me, plus 2x minus 2x minus y plus y. That's it. 2 iota y plus 2 iota y is 4 iota y. Iota x plus iota x is 2 iota x minus 4 iota is 0. So 2 iota y plus iota x minus 2 iota is 0. Tell me. Line 2. So this is 2y plus x is equal to 2. That's it. This is line 2. I cancels out. No? Iota cancels out. That's it, people. Now the question is as simple as I was narrating it to you before. Line 1 you've got, line 2 you've got. Please compute line 1 intersection line 2. Solve both the lines simultaneously. They are normals to my circle. Any normal to the circle, any normal always passes through the center. So when you intersect the two normals, what you end up getting is the coordinates of the center. क्या आ रहा है? What are you getting as the coordinates of the center? Intersect both these normals. Now, one is x plus 2y equal to 2. Other one is 2y equal to x. So you get 2x equal to 2, x is equal to 1. Baba is 2. If 2y is x, plug it here. You get 2x equal to 2. That means x is 1. If x is 1, you get y as half. So you are getting 1 comma half. That is the center. Now the third line is also there. There is an L3 also, which is actually a tangent. So this is equal to what? Iota times x plus iota y plus x minus iota y plus 1 plus iota is 0. You get iota x plus iota square. So minus y plus x minus iota y plus 1 plus iota. Okay? What next? Huh? Tell me. See, x minus y plus 1 is as it is plus iota times x minus y plus 1. So you basically are getting x minus y plus 1 into 1 plus iota. Now 1 plus iota to I know na is non-zero. Baba, 1 plus iota is a non-zero quantity. I know as a matter of fact. That means x minus y plus 1 has to be 0, and this is my line 3. And this is a tangent. This line 3 that I have just found out is actually a tangent. Now, if I compute the perpendicular distance from the center to the tangent, this is nothing but the radius. Yes or no? Yes or no? This is the radius. What is the radius? From the center, you compute the perpendicular distance to the tangent. You get the radius, which is what? 1 comma half. 1 minus half plus 1 inside the mod under root of 1 square plus 1 square. This is half plus 1, which gives you 3 by 2. So 3 by 2 upon root 2, which gives you 3 by 2 root 2. Do you know how to compute the perpendicular distance from a point to a line? You know that, right? Perpendicular distance of a point from a line. Yes? Okay. 3 by 2 root 2 is the right answer. See, the question was not difficult. Yes, the question was not difficult. You have the two normals. When you intersect both the normals, you get the center. You have a tangent. From the center to the tangent, if you compute the perpendicular distance, you get the radius. So the approach was very straightforward. The only panga was everything was given in terms of z, which is what scares the students, and that is why they leave such an easy question. They literally, I'm telling you, students have left this question. Students have left this question and they have not been able to feel comfortable with this question, just because everything was given in terms of z. Okay? Guys, if you're liking the session, don't forget to hit the like button. Okay, everybody likes being liked. Okay, so just hit the like button and also subscribe to the channel if you've not done that yet. Got your mistake? Chalo. Aage badhte hain. Let's go ahead. Take a look at the next question now. Yep, this is your homework question. Now, after every 15 to 18 questions, I will give you a homework question. So right now, I guess we're done with 14 or 15 questions. I've given you one homework question. Make sure you are attacking this and cracking this and killing it and conquering it and leaving the answer in the comment section below. Okay, come here. Very standard question, but nice. Value of this is equal to what? Value of this is equal to what? 1 plus 1 upon 1 plus 2, 1 upon 1 plus 2 plus 3. How do you crack this sum? You first of all write the general term, na? Which is 1 upon 1 plus 2 plus 3 plus 4 plus r. This is your rth term. Huh? Is this your rth term? Is this your rth term? This is your rth term. So you get 1 upon sum of first r natural numbers is n plus 1 by 2. Baba, sum of first n natural numbers is n into n plus 1 by 2. Sum of first r natural numbers is r into r plus 1 by 2. R into r plus 1 by 2. This is your TR. So if I want summation 2 upon r into r plus 1, this should vary from where to where? R equal to 0 to n? 0 to 10. Is this correct? 0 to 11 actually. Tell me. Because 1 plus 2 plus 3 up till 11 will be n plus 1 by 2. So r has to be last 11. R has to be number 1, 1. No, 0. 0 into 0 plus 1. Yeah. Tell me quickly. 0 though will give me 0. What about 1? Yeah, 1 is correct. 1 is correct. 1 into 1 plus 1. Yeah, 1 into 2. That is correct. Yes, you are very correct. Yeah, very, very correct, Vansh. Please make difference in the numerator. Because this is actually a telescopic series, everybody. Please check this out. If you plug in r as 1, you will get 1 into 2 in the denominator. 2 is already sitting up. 2 cancels out. You're left with a 1. You're left with a 1, no. Huh? And if you plug in r as 2, you will get 2 into 3. 2 cancels out. You're left with 1 upon 3, which is this term. So r going from 1 to 11 is actually sufficing my purpose. This is where you have to give a 10 to 15 seconds investment to check whether your index is varying from the right input to the right input. The right lower limit to the right upper limit. That you have to check that your input is varying from right lower limit to the right upper limit. That much if you've checked. Now the question is very simple. 2 goes, let's say, outside. What is the next thing? Can I write it like this? R plus 1 minus R gives you 1. 1 upon R into R plus 1. This is Bachche telescopic series. R going from 1 to 11. This is a classic example of telescopic series. Okay? Telescopic series. What is the answer? You plug 1 here, plug 11 here. Your answer is 2. 1 minus 1 by 12. So 2 times 11 by 12. 11 by 6. Is it okay? So I just wanted to discuss this question with you so that you are familiar with 1 upon R into R plus 1 as one of the most famous and easiest telescopic series. Okay, Vansh? Is it clear? Can I go on to the next one now? Let's quickly get done with algebra, then we'll move on to calculus. Chalo, tell me. NCK is here. What is it saying? It's NCK if K is lying between 0 and N, and it is 0 otherwise. Okay, fine. Okay, fine. What is AK? Summation I going from 1 to 9. This is 9CK, and then you have 12C, 12 minus K plus I. Oh, plus summation 8CI, 13C, 13 minus K plus I. Chalo, cool. I going from 1 to 8, I going from 1 to 9. Okay, not a problem. Question is saying NCK is valid if K lies between 0 and N. NCK is valid if K lies between 0 and N. 12 minus K plus I. Batao. Baba, this expression is valid if and only if 12 minus K plus I is greater than equal to 0 and less than equal to 12. That means I is less than equal to K or K is greater than equal to Y. Right? K is greater than equal to Y. So this is valid when K is greater than equal to I. Right? Similarly, this is also valid when K is greater than equal to I. If K is less than I, my answer automatically will be 0. But if K is greater than equal to Y, my answer will be this expression. So K less than I is actually not serving anything for me. K less than I is not something which is relevant here, because for K less than I, my outcome is just 0. For K less than I, my outcome is just 0. Yes or no? Plus 0 is not going to impact my answer. That will not contribute towards anything. So K greater than equal to I is something corresponding to which I am calculating my values. Got it? Got it? Let's proceed with this. Okay. Now, the moment you look at this expression, what pops up? Everybody, please tell me. What pops up? What pops up? Here, what are you doing? You are multiplying binomial coefficients. What pops up when you multiply binomial coefficients? Sum of lower indices. Sum of lower indices. This should be constant. Is it constant? 12 minus k plus I plus k. This is 12 plus I. This is not constant. So how do you make it constant? You replace NCR with NCN minus R. So you end up getting 9ck, 12c, 12 minus 12 plus k minus I. So this is just k minus I. Tell me. Oh, this is 9ci. Okay, this is 9ci and this is also 9ci. Tell me. Plus I. This is not equal to constant, na? So what have we done? We have replaced NCR with NCN minus R. Now the sum of lower indices is k, which is a constant. What do students do is I is going from 1 to 9. They end up writing the answer of this expression as sum of upper indices, which is 21c, sum of lower indices, which is k. 21ck is what they end up writing, but is that the right answer? 21ck is what they end up writing, but is that the right answer? Let's see the next one till the time you are thinking about this. The next one says 8ci and 13c, 13 minus k plus I. Again, because binomial coefficients are being multiplied, what pops up is sum of lower indices. So I plus 13 minus k. This is not equal to constant again. So again, I will be replacing NCR with NCN minus R. What I end up getting is 8ci, 13c, k minus I. Again, now the sum is constant. Now the sum is constant. So what are you getting as the answer? Technically, my answer should come out to be sum of lower indices, C, sum of upper indices, C, sum of lower indices, 21ck. So is this correct? Is 21ck plus 21ck correct outcome? Is 21ck plus 21ck correct outcome? Yes or no? Is 21ck plus 21ck correct outcome? Yes or no? Huh? Up to 4 and 3, Ahmad is saying. It's not the correct outcome, bache, because you say the shortcut is valid, that sum of upper indices, C, sum of lower indices, provided all your terms are getting exhausted. All your terms are getting exhausted, but over here, corresponding to I equal to 0, the term is missing. 9c0 into 12ck is missing. Corresponding to I equal to 0, the term which should be obtained, which should be present, is missing. So you can't just write 21ck. You have to add and subtract what's missing, no? Which is 9c0 into 12ck. So when you add a 9c0 into 12ck, that's when you get 21ck. But as a compensation, you have to subtract as well. Subtract 9c0 into 12ck. Similarly, on the right hand side, corresponding to I equal to 0, the term is absent. 8c0 into 13ck is absent. When you add 8c0 into 13ck, that's when your series is completed, whose answer is 21ck. But as a compensation, you also have to subtract. So subtract 8c0 into 13ck. This is your right answer. So your right answer is 21ck minus 9c0 is 1 into 12ck plus 21ck minus 8c0 is 1, or 8c0 is 1. Yeah, 13ck. Check this out. So 2 times 21ck minus 12ck plus 13ck. Is it okay? This is AK. I want A4 plus A3. A4 obviously will be 2 times 21C4 minus 12C4 plus 13C4. What is this? What is NCR plus N plus 1 CR? Huh? Can you do this? A3 also you can calculate. It's 2 times 21C3 minus 12C3 plus 13C3. When you add A3 and A4, let's see what you are getting. 2 times 21 2 times 21C4 plus 21C3 minus 12C4 minus 13C4 minus 12C3 minus 13C3. But 21C4 plus 21C3 is what? 22C4? What is this? 22C4, na? Yes, ma'am? No, ma'am? Yes. So, you are getting 2 times 22C4 minus 12C4 plus 12C3 plus 13C4 plus 13C3. That's it. NCR plus NC. R minus 1 is N plus 1 CR. NCR plus NCR minus 1 is N plus 1 CR. Check this out. That's it. You are done. 2 times 22C4 minus this. This is your final answer. Is this okay? Can you calculate this? It's just arithmetic calculation now. Nothing else. But the properties, wherever it got used, I've told you. NCR plus NCR minus 1 is N plus 1 CR. NCR plus NCR minus 1 is N plus 1 CR. Okay? Is it okay? Is the question clear? The question was only and only emphasizing upon this massively important property that summation of product of binomial coefficients. How do you solve? Sum of lower indices has to be constant. If it is not constant, you make it constant by replacing NCR with NCN minus R. Now it's constant. So your answer by the shortcut comes out to be sum of upper indices, C sum of lower indices. But only when all the terms of the expansion are exhausted. Like here, 2 terms were absent. 1 term from here, 1 term from here. So add and subtract and then accordingly go ahead. Okay? Chalo. Let's go to the next question. So, of course, you can compute A4 plus A3. It is 2P. And from there, you can report what is P. What is this? Sn is given to you. Sum 2Sn upon n factorial minus 1 upon n minus 2 factorial. What do you think this is? What do you think this is? 1 into n minus 1 plus 2 into n minus 2 plus 3 into n minus 3. It's r into n minus r, na? What is the problem? Huh, Jay? Arey Baba, it's very simple, na? R into n minus r. What is the problem? R going from 1 to n minus 1. Please make sure you understand. It's going till n minus 1. Yes, this is your Sn. So what is this? Summation n outside, this is r minus summation r square. R going from 1 to n minus 1, r going from 1 to n minus 1. N as it is, sum of first n minus 1 natural numbers is n plus 1 by 2. Sum of squares of first n natural numbers is n plus 1, 2n plus 1 by 6. So n plus 1, 2n plus 1. This will give you 2n minus 2 plus 1, 2n minus 1 by 6. Yes? n minus 1 by 2 comes outside. You're left with n minus 2n minus 1 by 3. So this will give you n minus 1 by 6. n minus 1, n plus 1 by 6. Please check this out. Please check this out. Please check this out, everybody. n minus 1 into n plus 1. This is 3n minus 2n plus 1. So this gives you n plus 1 by 3 into 2 outside, so upon 6. Is this cool? This is Sn. N minus 1, n plus 1 by 6. Sn is n minus 1, n plus 1 by 6. Now what do you want? You want summation n going from 4 to infinity 2 Sn upon n factorial minus 1 upon n minus 2 factorial, Baba. What is this? Huh? What is this? It's very, very interesting. 2 times Sn, so n minus 1, n plus 1 by 6. Okay, upon n factorial. So 6 and then n factorial minus 1 upon n minus 2 factorial. Tell me. How will you resolve? Baba, 2 upon 6 to chalo is 1 upon 3. How else will you resolve? This is what? n minus 1, n plus 1. Here you will get n minus 1, n minus 2 factorial. This gets cancelled out. Left with minus summation 1 upon n minus 2 factorial. There is a 1 by 3 outside. So you are left with 1 by 3 summation n plus 1 upon n minus 2 factorial minus summation 1 upon n minus 2 factorial. Chalo, now you tell me. Now you have to tell me what will I do. Now you tell me what. Please don't spread wrong information that your admit card is out or something. If it is out, we'll let you know, guys. Don't waste your time, please. Now see, in order to match this somehow, I can write this as n minus 3 plus 2. Or no, n minus 2 plus 3. Yes, n minus 2 plus 3. Correct. So what will you get? 1 by 3 times n minus 2 upon n minus 2 factorial, n minus 2 upon n minus 2 factorial plus 1 by 3 times and 3 plus 3 summation 1 upon n minus 2 factorial, and then you're left with minus summation 1 upon n minus 2 factorial. 3 cancels out, and now even this summation cancels out. You're left with 1 by 3 as it is. This is n minus 2 upon n minus 2 into n minus 3 factorial. This gets cancelled out. You're left with 1 by 3 summation 1 upon n minus 3 factorial. And now it makes sense that n is starting from 4 and going till infinity. So 1 by 3 is as it is. You get what? 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus and so on. What is this, people? What is this? Don't forget. What is this? 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on. So e to the power 1 will be 1 plus 1 plus 1 by 2 factorial plus 1 by 3 factorial plus and so on. There are 2 ones. So e minus 1 is what is 1 upon 1 by 2 factorial plus 1 by 3 factorial plus and so on. It is actually e minus 1. This complete expression is e minus 1. Your answer is e minus 1 by 3. This is your sum. Sum is e minus 1 by 3. Is this understood? E minus 1 by 3. Such a brilliant question, yaar. E minus 1 by 3. Is this understood, people? Summation r square you've resolved. After this, the expression was what demanded simplification from us. Pure algebra question. Pure algebra question. Okay? I hope it's clear. There should be no doubt ideally. Should be no doubt. Now see, let's come to probability. It says an electric instrument consists of 2 units. Each unit must function independently for the instrument to operate. Each unit must function independently for the instrument to operate. Probability that the first unit functions is 0.9. The first unit functions is 0.9 and that of the second unit functioning is 0.8. Instrument is switched on and it fails to operate. If the probability that only the first unit failed and second unit is functioning is P, then 98P is equal to. What is this? Conditional probability based theorem? Yes or no? Probability that when you switched on the instrument, it failed. Oh, the instrument failed. if the probability that only the first unit failed and second was functioning. For one complement means one failed and second was functioning. Okay. This is capital F, let's say. So capital F actually means failed. Okay. This means what? What is the probability? This is probability of I dash intersection second. First complement, first failed, second was functioning, provided the entire instrument failed, upon probability of failed. Tell me. Probability of failed. The first unit functions is 0.9. When will it fail? When either of the two units fail. So first unit fail is 0.1. First unit fail is 0.1. See, when all can the entire instrument fail? When either one unit fails, other one is functioning, or other one fails, first one is functioning, or both fail. If both fail means 0.1 into 0.2. Then if the first one fails, it is 0.1 and second one is functioning is 0.8. If the first one is functioning is 0.9, second one fails is 0.2. Now first fails, second is functioning, numerator. First fails is 0.1, second functioning is 0.8. That's it. That's it. Answer is 8 upon 28. This is your P. So, yeah, 98 P will be 28. Can you calculate now? P you've got. Is this clear? It's just a matter of understanding the statement and converting into mathematics. This is pure Bayes theorem, formula and application. Pure Bayes theorem. Pure Bayes theorem, guys. Is it okay? Is it clear? Aditya, it says probability that first unit functions. Probability that first unit functions is 0.9. So probability that the first unit does not function is 0.1. Probability that the second unit functions is 0.8. So probability that it does not function is 0.2. It switched on, but it failed. So failed is a given incident, given event. Probability that only first failed, second is functioning. So probability that first failed and second is functioning provided the entire unit has failed. This is what required Bayes theorem. Okay? Is it okay? Chalo. Bayes theorem, very important, people. You must know how to crack questions from Bayes theorem. Come to this question now, based upon palindrome. A number is called a palindrome if it reads the same backward as well as forward. For example, 285582. Backward, forward, backward, forward, backward, forward, same. So you read it from back to front or front to back, it's the same. 285582, 285582. Number of 6-digit palindromes, which are palindromes, which are divisible by 55. Divisible by 55 means 5 and 11. I want a 6-digit palindrome. 1, 2, 3, 4, 5, 6. 6-digit palindrome. 6-digit palindrome will look like what? A here, so A here. B here, so B here. C here, so C here. This is how my 6-digit palindrome will look like. This is how my 6-digit palindrome will look like. This is how my 6-digit palindrome will look like. But because I want my palindrome to be divisible by 5, it has no choice but to end with a 5 or a 0. But whatever it ends with, that is the same number it has to start with. Whatever it ends with, it is the same digit it has to start with. It can't start with 0. That means it can't end with 0. So the only possibility is keeping a 5 here and keeping a 5 here. Now, next is, it should be divisible by 11. By 11 means sum of digits at even places minus sum of digits at odd places. That means 5 plus C plus B. Sum of digits at odd places minus sum of digits at even places. The absolute value should be either 0 or a multiple of 11. Arey Baba, the absolute value of this difference is coming out to be 0. Yes, this is coming out. This is equal to 0 for every B and C. I don't care what B and C are, na? I don't care what B and C are. For every B and C, this difference is coming out to be 0. And 0 is allowed. 0 is allowed. That means your B can be anything from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. and C also can be anything 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So B can be filled in 10 ways, C can be filled in 10 ways. 10 into 10 is 100. 100 is my answer. Got it? Got it? 100 is my answer. Is this understood, the palindrome question? Clearly understood? I can fill B in 10 ways, C in 10 ways. The first and the third place is already filled by 5. There is no other option. So I have only 10 into 10, 100 ways to form these type of 6-digit palindromes which are divisible by 55. 100 such 6-digit palindromes. Okay, cool. Chalo. A, B, C are 3 events such that probability that exactly one out of A and B occurs, exactly one out of A and B occurs is 1 minus K. Probability that exactly one out of B and C occurs, 1 out of C and A occurs. What is the meaning of this? Exactly one out of A and B occurs. It means if say this is A, this is B, this part union this part. Probability that A occurs and B does not occur. A occurs and B does not occur is this union. B occurs and A does not occur is just this. So when you say exactly one out of A and B, it is this union this, basically, plus. So what is this? Probability of A intersection B complement is probability of A minus probability of A intersection B plus probability of B minus probability of A intersection B. This gives you probability of A plus probability of B minus 2 times probability of A intersection B. This is the meaning of, I'm telling you, this is the meaning of exactly one out of A and B occurs. This is what it means. From the union, you are removing the intersection. That is what you get. Okay, so what is the question saying? Question is saying probability of A plus probability of B minus 2 times probability of A intersection B is equal to 1 minus K. Similarly with B and C. So probability of B plus probability of C minus 2 times probability of B intersection C is equal to 1 minus 2K. Then C and A also. Probability of C plus probability of A minus 2 times probability of C intersection A is equal to what? 1 minus K. If you add all of them, what will you get? If you add all of them, what will you get? You get probability of A plus probability of B plus probability of C 2 times minus 2 times probability of A intersection B plus B intersection C plus C intersection. Tell me if this is clear. Tell me if this is clear. And 1 minus K plus 1 minus K is 2 minus 2K. So 2 minus 2K plus 1 minus 2K is 3 minus 4K. This is equal to 3 minus 4K. This is what you are getting when you are adding. So you can do one thing. From here 2 and 2 you can take out common and you can send it here upon 2. Take out 2 and 2 from there common and keep it upon 2. Okay, now what is the question saying? Probability that A, B, C occur simultaneously is K square. What is the probability that at least one out of A, B, C occur? At least one out of A, B, C occur. What is the meaning? At least one out of A, B, C occur means A union B union C, which is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. Is this making sense, everyone? Is this making sense? It's a long class, Aditya. It's a long class. Okay. So from here to here, I know the value. It is 3 minus 4K upon 2. And A intersection B intersection C is nothing but K square. Check this out. Oh. So what are you getting? K minus half whole square. Huh? Come on, Aditya, tell me. Hi, Nidhi. So good to see you. It's always so good to see you. Yep. This is K minus 1 whole square plus half, which is greater than or equal to half. Obviously, this part is non-negative, no? This part is non-negative. Plus half is greater than or equal to half. Is greater than or equal to half. Is it okay? Is it okay? So the probability is at least half. The probability is at least half. It's greater than half. Okay? So understand the language. At least one, exactly one, and simultaneously occurring. All these things can be converted into set theory format, and then you have to compute the probability. Okay? Is it cool? Badhe aage? Come to this question now. See this, it says, this denotes GIF of x, alright. Sum of n plus 1 terms. Okay, sum of n plus 1 terms is equal to 2 to the power 100 into 101. What is this expression equal to? 2 to the power 100 into 101. Acha, sum of these n plus 1 terms. Let's check this out. What is the sum? See, na, are there n plus 1 terms? You have nc0 into 3, n plus 1 into 5, nc2 into 7, nc3 into whatever. What is the pattern? You want n plus 1 terms. So you are basically getting summation ncr, and here you have to write 2r plus 1, I believe. Please check this out. It's a formula. Huh? R is going from 0 to n. Does this work? Varying R from 0 to n. Does this work? When R is 0, you are getting NC0. ठीक है. When R is 1, you are getting 3 times NC1. Perfect. When R is 2, you are getting 5 times NC2. Perfect. These are your n plus 1 terms. Pakka. You want sum of these n plus 1 terms. This is so easy, na? 2 common summation RNCR plus summation RNCR plus summation just NCR. So this gives you 2 times, what is RNCR? N into 2 to the power n minus 1. What is NCR? 2 to the power n. Please tell me, do you remember this? Summation R NCR is n into 2 to the power n minus 1, and summation NCR is 2 to the power n, sum of all binomial coefficients. Yes? Yes, this gives you 2 to the power n into n plus 2 to the power n. So 2 to the power n as it is into n plus 1. What is this equal to? 2 to the power 100 into 101. So 2 to the power n into n plus 1 is 2 to the power 100 into 101. So n is coming out to be 100. So 2 times 100 minus 1 upon 2. What is this? 99 upon 2. Come on, tell me GIF. $49.5, so it's 49. Actually, the GIF is 49. 49 into 2 is 98. Yes? Ma'am, can you use white color? Okay, fine. I'll try. Is it okay, everyone? Is this question understood? Easy question using the fact of binomial results, summation R NCR and summation NCR. Chalo. Let's move ahead, talk about the next question now. Okay, yup. This is a question which I want you to little bit brainstorm upon. Why? Why? It says let 1 upon alpha into alpha plus 1, alpha plus 2 and so on, alpha plus 20 is this. What is the value of this expression equal to? I want you to try this out. You know why? Shall I give you a hint? I'll give you a hint. This question is based upon partial fractions. And it's very evident from the question statement only. It says 1 upon alpha into alpha plus 1 into alpha plus 2, alpha plus 20. Okay. This is equal to summation ak upon alpha plus k. That means a naught upon alpha plus a1 upon alpha plus 1 plus a2 upon alpha plus 2. Please listen to this. It's very interesting. Plus a20 upon alpha plus 20. Now the point is, when you take out the LCM on the right hand side, the denominator will get cancelled out. But what will you get on the right hand side? A0 into alpha plus 1, alpha plus 2 and so on. Similarly, with A1 you will not get alpha plus 1, but everything else, alpha naught into alpha plus 2 and so on. Not alpha naught, alpha into alpha plus 2 and so on. With A2 you will not get alpha plus 2, you will get alpha, alpha plus 1 and then alpha plus 3 and so on. And the denominator obviously here and here will be the same. Denominator here will be the same, denominator here will be the same. After taking out the LCM, it will get cancelled out. Now what? See, what you need is A14 plus A15 upon A13. How will you get A13? Do you know this? Let's start now with A13. How will you get A13? Arey Baba, with A13 here, common sense guys, with A13 here, you will not have alpha plus 13 sitting. Rest everything else will be sitting. But with every other term, alpha plus 13 will be sitting. So if I want to isolate A13, I will be using alpha equal to minus 13. In that case, what will happen? I will have A13 as it is. Alpha, alpha plus 1, alpha plus 2, alpha plus 3 and so on, alpha plus 10, alpha plus 11, alpha plus 12. What is alpha plus 12? Minus 1. Alpha plus 13 is not there. Alpha plus 14, alpha plus 15, alpha plus 16 and so on, alpha plus 20. That's it. This is what you will get on the right hand side. Rest everything else will have alpha plus 13. So the moment you plug in alpha as minus 13, everything will become 0. And on here you have a 1. Do you understand? So A13 will technically come out to be 1 upon 1 into 2 into 3 into 4 into 13 with a minus sign, which gives you minus 13 factorial. And 1 into 2 into 3 up till 7 is 7 factorial. Check this out. Yes ma'am, no ma'am. Similarly, for A14, you will plug in alpha as minus 14. So you will get 14 times 1 into 2 into 3 into 3 up till 14 along with the minus sign. So minus sign multiplied with itself 14 times will give you 1 only, plus 1 only. So you get 1 upon 14 factorial into 6 factorial, and A15 will be 1 upon 15 factorial into 5 factorial. That's it. That's it. The question is done. The question is done. That's it. You have your A13, 14, 15. Please plug it here, square it and multiply by 100. Your answer will very easily come out to be 9. Is this question clear? The approach is very nice. It might look like a lengthy question, but it's a partial fraction question. The moment you take out LCM, denominator cancels out. Now the numerator here has A1 also, A0 also, A2, A3, A4 and so on. But if I want A13, I just want A13 to stay here, rest everything should vanish. So obviously in A13 I don't have alpha plus 13, but in everything else I have alpha plus 13. So plug in alpha as minus 13 so that everything else vanishes and this A13 term stays. And when it stays like this. So it gives you the value of A13 and similarly A14 and A15. Interesting, right? Very interesting. Actually very interesting. This is a very important question. It's a very classic category of question which I want to discuss with you. Let this be a sequence such that A1 is 1, A2 is 1, AN plus 2 is 2, AN plus 1 plus AN for all n greater than equal to 1. What is the value of this expression? Tell me. See, the moment you are saying summation AN upon 2 cube to the power n going from 1 to infinity, understand what this is. This is A1 upon 8 plus A2 upon 8 square plus A3 upon 8 cube plus and so on. This is what it is, na? This is what you want. 47 times this summation is what you want. 47 times this summation is what you want, na? Don't try to skip completely Google G community. Please don't skip anything. That is not something which I would advise. Okay? But there is a recursive relation given to you which will help us reach the value of this expression. How? See, AN plus 2 is equal to 2AN plus 1 plus AN. I want upon 8. So upon 8 to the power, upon 8 to the power, upon 8 to the power, what? If you say take 8 to the power and 8 to the power and 8 to the power, and even then this relationship will get satisfied. But my target is, if there is an n plus 2 here, there should be n plus 2 here. If there is n plus 1 here, there should be n plus 1 here. And this is the only catch of this question. If there is n plus 2 here, I want n plus 2 here. So plus 2 here, minus 2 here means divide by 64. So multiply by 64. Please check this out. You will get a 64 here, no? Yes or no? Similarly, there is an n plus 1 here. I want an n plus 1 here also. So you multiply by 8. So you get what? You get 64 times a n plus 2 upon 8 to the power n plus 2 is equal to 2a n plus 1 upon 8 to the power n plus 1. 8 into 2 will give you 16 plus a n upon 8 to the power n. Good evening, Kirtika. Is it okay? And now the question is almost about to get done. See, take summation. Summation a n plus 2 upon 8 to the power n plus 2 is equals to 16 times summation a n plus 1 upon 8 to the power n plus 1 plus summation a n upon 8 to the power n. And n is going from 1 to infinity, 1 to infinity, 1 to infinity. Now, what my point is, please take this as x. Why? Because the moment you will start opening this up, you will get what? N equal to 1. So you get a3 upon 8 cube, a4 upon 8 to the power 4 and so on, equal to 16 times again a2 upon 8 square, a3 upon 8 cube and so on, plus x. But the good news about x is, what is x? X is equal to a1 upon 8, a2 upon 8 square, a3 upon 8 cube and so on. But a1 and a2 to I know na. a1 is 1 and a2 is 1. So a3 upon 8 cube and so on is x minus 1 upon 8 minus 1 upon 8 square. What is this? X minus 1 upon 8 minus 1 upon 8 square. Similarly, what is this? This is x minus 1 upon 8. Bingo. Now everything can be converted in terms of x. Everything can be converted in terms of x, na? Huh? Everything else is converted in terms of x. This will give you 47x equal to 7. That's it. You're done. You are done. 7 is your final answer. Did you get the approach? This much you have to resolve. It's very simple. Because here also you have x minus 1 by 8, there also x minus 1 by 8, minus 1 by 8 square, and there is a plus x. Everything will get converted in terms of x and constants. One equation, one variable. You get x or you get 47x directly, that's your choice. 47x is coming out to be 7. But is the approach clear? There is a recursive relation which is playing a massive role in this question. You analyzed your series in which you are interested and you realize that this is that series whose value you want to compute. Right? Whose value you want to compute. So what did you do? Recursive relation. You've exploited the recursive relation, people. You've exploited your recursive relation. Okay? Okay? And that has given you your answer. And what to take x as so that everything else is written in terms of x is something again very big catch step here. Okay, fine guys. Making sense? I will do important topics. Okay. Chalo, this is very nice. Let's check this out. S1, S2, S3 up till S10 are divided into 3 groups A, B, C so that each group has at least 1 student and C has at the most 3 students. Total number of possibilities of forming such groups. What do you think? So 10 students to be formed in, divided into 3 groups A, B, C. C has maximum 3 students. Maximum 3. That means case 1 is when C has 1 student. If C has 1 student, out of the 10, anyone can go to C. Once this 1 student has gone to C, 9 are left to be distributed among A and B. 9 are left to be distributed among A and B. And I want every group to have at least 1 student. That means no group is allowed to be empty. 1 student has gone in C. I'm left with 9. 9 are allowed to go in any one A or B. So each student has two options. Two options to the first kid, two options to the second kid, and so on to the ninth kid. Either to go in A or to go in B. So 2 to the power 9, 2 into 2 into 9 times. Every kid has two options, either go in A or go in B. But this includes the possibility that all students go in A or all students go in B, in which case A will be empty or B will be empty, which is not allowed. So those two cases I will have to remove. Is this making sense? Similarly, you have a case 2 when C has two students. If C has two students, same logic. Out of 10, any two students can go in C. Now, the remaining 8 students have two choices. So, 2 to the power 8 minus 2, because I don't want all students to go in A or all students to go in B. Exactly in the same manner, you have a case 3. C has 3 students. 3. At max, it can have 3, right? So, out of 10, choose any 3. Now, you're left with 7. 2 to the power 7 minus 2. Cool? Is this cool? So this number plus this number plus this number is your answer. Case 1 plus case 2 plus case 3 is your answer. Please remember the logic. If students are being distributed in the groups, each student has two choices. So 2 into 2 into 2, 9 times or 8 times or 7 times. Okay? That's the logic being used here. Let's come to this question, which is a fantastic, wonderful, and a must do. This is literally a must do question. Why, ma'am? Why is it a must do? If the remainder when x is divided by 4 is 3, what is the remainder when this is divided by 8? When x is divided by 4, bache, the remainder is 3. What is the remainder when 20 plus x to the power 22 is divided by 8? See, here there is a trick. What is the trick? When x is divided by 4, the remainder is 3. That means take x as 7 or 11 and so on, or 15. Each of these numbers, when divided by 4, are giving you 3 as the remainder. So the trick is take x to be any of these numbers. Let's say 7. So you get 20 plus 7 to the power 22. I have to divide this by 8. So I have to express my base number in terms of multiple of 8. Is that possible? When you 27 to the power 22. Okay. When you divide this number by 8, the remainder will turn out to be 7. So you will get basically 8 lambda plus 7 to the power 22. Now you know the go went gone method, the shortcut. Go went gone. You are left with 7 to the power 22. But this is nothing but 8 minus 1 to the power 22. 8 is again go went gone. Minus 1 to the power even number is 1, and 1 is your remainder. So in such a question, always remember, if it is talking about x, and this is true for any x, which when divided by 4 gives you remainder 3, you take a special x. No, you take a specific x. You take a specific x, for example, 7. And then you solve as ordinarily as you do. And you'll get the answer. Okay? Okay, people? Next. When a missile is fired from a ship, this is something I guess you can do. Again, Bayes theorem, everybody. Homework question. I told you after every 14-15 questions, I'll give you homework. Again, a homework question based upon Bayes theorem. You can 100% do it. Conditional probability, Bayes theorem. Please try it out. Try it out by yourself. Very easy. Very, very easy. That's why I'm giving you for homework. Number of ordered pairs. Now listen to this. Number of ordered pairs r, k for which this equation is satisfied where k is an integer. Let's see. Can you tell me? No, not why only 7 and 11. Once I said 7, 11, 15 and so on. Any number which when divided by 4 gives you 3 as the remainder. It's a huge list. From that list you take any number. I took 7, you can take 11, you can take 15. That's your choice. Okay, you can take 19, you can take 23, you can take 27, you can take 43. Any number which when divided by 4 gives you remainder 3, you can take any number. Okay? Tell me. See, the framing of this expression is very smart. It says 6 times 35 CR is equal to k square minus 3 36 CR plus 1. I'll give you a break after 2 questions. I'll give you a break, a nice break. 6 times 35 CR is k square minus 3 times 36 CR plus 1. There is a chalaki. What is a chalaki? You can say 35 CR upon 36 CR plus 1 is equal to k square minus 3 upon 6. Just simplifying, nothing else. Simplifying for my ease, nothing else. Do you remember the result that NCR is equal to N by R, N minus 1, CR minus 1? You can send this R here also. Right? Now you want 36 CR plus 1. 36 CR plus 1 you want. So let's say I replace N with 36 and R with R plus 1. What will this same result become? This will become R plus 1. 36 CR plus 1 is equal to N to is as it is. And N minus 1 is 35. CR minus 1 means R plus 1 minus 1 is R. Can you see this? I have done nothing. I've actually just remembered this result, and because of what I want, I have made this manipulation. Replace N with 36, replace R with R plus 1. This is what you will get. So you will get 35 CR upon 36 CR plus 1 from here. 35 CR upon 36 CR plus 1 is equal to R plus 1 upon N, which is also equal to K square minus 3 upon 6. Na baba? Upon n. N is what? 36. Acha, this is to 36. Chalo. 6 into 6 is 36. So R plus 1 is equals to 6k square minus 18. That means R is equal to 6k square minus 19. R is what? You have 35 CR everyone. That means R is a whole number and R is sandwiched between 0 and 35. That means 6k square minus 19 is sandwiched between 0 and 35. Yes or no? So 19 less than equal to 6k square less than equal to 9, 10, 11, 12, 13, 14. This is 54. So you get 19 by 6 less than equal to k square less than equal to 54 by 6. This is to chalo, yeah. This is upon 6. 6 into 9 is 54. Yep, and this is what? 3 point something. So k square is lying between 3 point something and 9. Can you see this? K square is lying between 3 point something and 9. K square is lying between 3 point something and 9. So what all k can be? Baba, k square is lying between 3 point whatever, 3.1, comma 9. What all k can be? Huh? Remember the graph of x square. If x square is lying between 3 and 9, what is x? And it is non-negative only. This is root 3 whole square. This is 3 whole square. So if your square is lying between 3 and 9, and of course you can come here and say minus root 3 square, and this is minus 3. Tell me. Baba, if k square is lying between 3 point something and 9, that means k square can be 4 or 9 because k is an integer. So what all possible values k can take? Tell me now. Baba, R is 6k square minus 19. K is an integer. If k is pakka an integer, that means k square is also an integer. If k is pakka an integer, that means k square is also an integer, and possible integral values of k square can be 4 or 9. So R will be equal to what? R will be equal to 6k square minus 19. 6k square minus 19. 6k square minus 19. 5, and this is Acha, okay, fine. 35. Is it cool? That's it. So K can be 4 values, R can be 2 values. K can be 4 values, R can be 2 values. See na, if K square is 4 or 9, that means K can be 2, minus 2, 3, minus 3. So K has 4 choices, R respectively has 2 choices. So what about numbers of ordered pair R comma K? R has 2 choices, K has 4 choices, 4 into 2, 8 choices. Is 8 the right answer or 4 the right answer? R comma K you want, na bachche, not R square comma K or R comma K square. Tell me. With R as 5 you have 4 options for K. With R as 35 you have again 4 options for K. So there are 8 options, na? 8 or 9? Harshita, 8 options, not 8 options. Is this question clear? K square was actually coming from here. But K is definitely an integer, question says. So K square also has to be an integer. So from this interval, what are the perfect squares? In this interval, what are my perfect squares? 4 and 9. So possible acceptable values of K square are just 4 and 9. So possible acceptable values of K, integral values of K will be 2 minus 2, 3 minus 3. And accordingly, R has come out to be 5 and 35. Okay? Is it okay, people? Yes? Chalo. This is something which is a very standard question, but I wanted to discuss with you because I wanted to remember the factorization of this biquadratic expression. The biquadratic expression. What is it? K to the power 4 plus K square plus 1. This is equal to K square plus 2K plus 1. Okay. हाँ ठीक है. K square plus K plus 1 into K square minus K plus 1. This is something you have to remember. Otherwise, this question is nothing. I want you to remember this. I want all of you all to remember this. Yes. Now you want K upon this expression. So this is to pakka factorized into product of 2 quadratic. This biquadratic is factorized as product of 2 quadratic. So you get summation. What is this? K square plus K plus 1 into K square minus K plus 1. If you subtract both these factors, you get K square plus K plus 1 minus K square plus K plus minus K plus K minus 1. So this cancels out, this cancels out. You're left with 2K. You are left with 2K. But I want a K, so I will divide by 2 as well. Okay, I will divide by 2 as well. Now I'm left with a K in the numerator, which I have successfully expressed as the difference of 2 consecutive terms. Can you see that? What is this? This is nothing but K square plus K plus 1 minus K square minus K plus 1. Yes, difference of 2 consecutive factors or 2 consecutive terms. This is what? 1 upon K square minus K plus 1 minus 1 upon K square plus K plus 1. That's it. That's it. K going from 1 to 10. Nothing now. Plug in 1 here, plug in 10 here. Got your answer. 1 by 2. 1 minus 1, 0. This is 1 minus 1 upon 1, 1, 1. 55 upon 1, 1, 1. 160 m upon n. 166. This is m upon n. So 166. Is it okay? This is something you have to remember, the factorization. Otherwise, it's very simple. You have written the numerator as difference of both the factors, but it was coming out to be 2K. I wanted a K, so I divided by 2. Now it is difference of 2 consecutive terms, which means it's a telescopic series. You can either open the entire thing up and cancel out the consecutive terms, or take the least value, the lower limit, plug it in the smaller expression, Upper limit 10, plug it in the larger expression and directly subtract, got your answer. That's also a shortcut. Okay? Ma'am, if I have not practiced much in math, if I do this question, can I get 20? Just this question. Just this question, no. Just this question, no. This session, yes. 100%. Okay, we're done with algebra, everybody, and we are about to dive into calculus. Are you ready? Are you ready? We're about to dive into calculus. Are you ready? I'll give you a quick short break. This is your homework question from algebra. This is your very, very nice homework question based upon PNC. Please try it out. And this is such an important question. If you're not able to do it, let me know in the comments below. Or you can let me know in the Telegram channel also, which is Study with Bhoomika Ma'am. Study with Bhoomika Ma'am. But we are starting with calculus in just a short while. This is your first question. Try it out. Let's take a 5-minute break. Let's meet at Get Back at 7:15. Okay? I might come jaldi also. Okay? So see you at 7:15. Alrighty, folks. Are we set? Can we continue? Are we set? Can we continue, everyone? All right, we're starting with calculus now. We're starting with calculus now. Okay, I feel some of you all have already started solving the question, which is awesome. What did you get? What did you get as the answer? It says small m and capital M are the maxima and minima values of this function. In the interval closed 0, closed pi by 8, what is small m plus capital M equal to? What is small m plus capital M equal to? Tell me. The moment it talks about closed interval, always remember we have to find out the values at the extreme points of the interval. Always. So please compute what is f of 0. Please compute what is f of pi by 8. Can you tell me? Maxima is at pi by 8. Okay. F of 0 will be what? Huh? Tell me. F of 0, 0, cos inverse 0, cos 0. Cos 0 is 1 and cos inverse 0 is pi by 2. So pi by 2 plus 1. What about f of pi by 8? Sine inverse pi by 4 plus sine pi by 4 plus cos inverse pi by 4 and cos pi by 4. Pi by 2 plus root 2. Is this clear? I simply calculate the values of the trigonometric or inverse trigonometric functions at these angles. Nothing more, nothing less. Is it okay? Is it absolutely fine? Tell me. Fine? F of 0 is sorted. F of pi by 8 is sorted. What next? Now I want to explore the nature of f. For that I will compute f dash. F dash x will be what? Who will tell me? Baba, sine inverse x plus cos inverse x is pi by 2 na? No matter where x comes from, how do I care? No matter where x comes from, how do I care? Yes or no? Hi Aditya, you're back, great. No matter where x comes from, sine inverse plus cos inverse is pi by 2. Yes? So what do you get? Pi by 2's differentiation is 0. You get cos 2x and there is a 2 here. Again sine 2x and there is a 2 here. So 2 times cos 2x minus sine 2x. Now the logic has to start. See, if x is coming from close 0 to pi by 8, 2x that means is coming from 0 to pi by 4. And in 0 to pi by 4, cos is greater than sine. You know this, right? This is your sine graph. This is your cos graph. This is pi by 4. So in 0 to pi by 4, very clearly you can see cosine is above sine. That means this is certainly positive. If this is positive means f dash is positive, or rather at max equal to 0, greater than equal to 0. At pi by 4, it is equal to 0 now. At pi by 4, it is equal to 0. It's a closed interval. So at max, you have f dash greater than equal to 0. So f is an increasing function in my interval. F is increasing in closed 0 pi by 8. If it is increasing, if f is increasing in closed 0 pi by 8, if f is increasing in closed 0 pi by 8, that means its minimum value is at f of 0 and maximum is at pi by 8. So f minimum is nothing but f of 0, which is small m, and f max is equal to f of pi by 8, which is maximum. Okay? So what is the sum? Small m plus capital M, pi by 2 plus pi by 2 is pi plus 1 plus root 2. That's it. Pi plus 1 plus root 2. Pi plus 1 plus root 2. Is this question clear, everyone? Is this question clear? Is this question clear, everybody? Is this question clear, everybody? M and M respectively be the minimum and maximum values of this function. What is m plus m equal to? Is this question clear? Let's come to this one now. G is a non-constant, twice differentiable function. G is a non-constant twice differentiable function on the set of all reals such that y is equal to g of x is symmetric about the line x equals to. Now understand, there is a big meaning hidden here that y equal to g of x is symmetric about the line x equals to. What do you mean by this? When you say g is symmetric about the line x equals to, what do you mean by this? Can you tell me? G is symmetric about the line x equals to. What do you mean by this? Do you know this? Do you know the meaning of G being symmetric about the line x equals to? What is the mathematical meaning of this? The condition which it satisfies when it is symmetric about the line x equals to? No, not even or odd function. It is G of 2 plus x is equal to G of 2 minus x. G of 2 plus x is equal to G of 2 minus x. That's it. This is the condition it satisfies. Now, this is something you have to remember. This is something that you have to remember. When a function is symmetric about the line x equals alpha, it satisfies G of alpha plus x equals G of alpha minus x. If you replace here x with x minus 2, what will you get? Replace x with x minus 2. What will you get? Here you will get G of x. Replace x with x minus 2. So x plus 2. This is 4 minus x. This is equivalent definition, people. So both these are actually equivalent. Both these are equivalent. When you say G is symmetric about the line x equals 2, both these are equivalent. You write this or this, both are equivalent. Is it okay? Is it okay? Question says G of minus 2 is 0, G dash half is 0, G dash 1 is 0. A is the minimum number of roots of f double dash. This is G double dash, not f double dash, G double dash. What is the value of G of 6 plus A? What is G of 6? G of 6 will be G of 4 minus 6, which is G of minus 2. This will be equal to G of minus 2. Okay. G of 6 is G of 4 minus 6, which is G of minus 2, and G of minus 2 is given to you as 0. That means G of 6 is 0. Okay, this is 0. I only need to compute A. I only need to compute A. A is my only agenda. And what is A? Minimum number of roots of G double dash. Now, please understand, if you know the minimum number of roots, or rather, if you know the number of roots of G dash, 1 less is the minimum number of roots of G double dash. You know this, right? Do you know this? If a graph is continuous and differentiable, cutting the x-axis at 1, 2, 3, 4, 4 distinct real points. If f has 4 distinct real roots, its derivative will have at least 1, 2, 3. Its derivative will have at least 1 less, 3 distinct real roots. If a function has 4 distinct real roots, its derivative will have at least 3 distinct real roots. It can have more as well. For example, like this. So again, f has 1, 2, 3 and 4 real roots. But its derivative, can you see it's vanishing so many times? The derivative is vanishing here, 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 here. Between any 2 consecutive roots of f lies at least 1 root of f dash. That is why if f has 4 roots, between any 2 consecutive will lie at least 1 root of f dash. So the conclusion is, if f has n roots, f dash has at least n minus 1 roots. If I want the minimum number of roots of G double dash, I want the number of roots of G dash. I want the number of roots of G dash. So listen to me. G dash is 0 at half. G dash is 0 at 1. Yes, I know G of x is equal to G of 4 minus x. Alright, if I differentiate both sides, I get what? G dash x equals G dash 4 minus x with a minus sign in front. With a minus sign in front. Now, I know x is equal to 4 minus x when 2x is equal to 4 or x is equal to 2. That means G dash 2 is equal to minus G dash 2. This gives you twice of G dash 2 is 0 or G dash 2 is 0. Or G dash 2 is 0. So one more point I've got where g dash is 0, which is at 2, it's 0. One more thing, guys. So this is, what did I do? I actually equated x with 4 minus x. Another thing I'm going to do is do this. Plug in x as half. When I plug in x as half, I get g dash half is minus g dash 4 minus half, which is minus g dash 7 by 2. What is g dash half? It's 0. So you are getting g dash of 7 by 2 is also 0. Another thing, this x equals 1. I know g dash 1 is 0, but g dash 1 is equal to minus g dash 4 minus 1, which is g dash 3. So g dash 3 is also 0. This is a fantastic conclusion that we are obtaining, that g dash is actually vanishing at 5 points. Are you understanding? So g dash has 5 roots. Its derivative will have at least 4 roots. 4 is the right answer. A is actually 4. So g of 6 plus 4 will be 0 plus 4, which is 4. How many of you all got 4 as the answer? Tell me. Huh? How many of you all got 4 as the answer? G of 6 was 0. So 0 plus A gives you 0 plus 4, which is 4. A basically is 4. Minimum number of roots of G double dash is actually 4. So the biggest takeaway from here is, when G is symmetric about x equals 2, the condition is G of 2 plus x is equal to G of 2 minus x, which is equivalent to saying G of x equals G of 4 minus x. Okay. Next is, how you have to exploit this condition by differentiating both sides. Number 1, when the inputs are same, you get what? G dash 2 equals 0. Equating the inputs x and 4 minus x, you get a number 2 at where g dash is 0. Next, I knew g dash half is 0, so I plugged in half, I got 7 by 2. Next, I knew g dash 1 is 0, I plugged in 1, I got 3 also. So like this, you have to increase the count, or rather get to the final count of numbers at which g dash is 0. The moment you are exhausted with all possibilities of g dash being 0, there are 5 such points where g dash is 0, minus 1. 4 such points minimum where g double dash will be 0. Is it okay? Is this completely sorted? Yep. Let's come to this question now. If alpha is the root of this equation, Are Baba, this is a very nice question. This is a very nice question. If alpha is the root of this equation, where alpha comes from pi by 2 to 3 pi by 2. Okay, let's see. Alpha is coming from pi by 2 to 3 pi by 2. Now, pi by 2 is 3.4 upon 2, which gives you around 1.57. And 3 pi by 2, 3 pi by 2 is 3 into 3.14 upon 2, around 4.7. That means alpha is actually coming from 1.57 to 4.7 approximately. Which of the following is correct? Okay, let's see. Let's see, I have x minus tan x equal to 3, everybody. Make sure you are focusing upon the approach of the question. Tan x is equal to x minus 3. Tan x is equal to x minus 3. Chalo, let's see. Pi by 2 to 3 pi by 2. Okay, this is pi by 2. Okay, this is 3 pi by 2. Okay. Is this okay? Yes, this is pi by 2. This is 3 pi by 2. This is, let's say, pi. Okay, now listen to me. Where is alpha lying? Pi by 2 to 3 pi by 2. Acha. What about x minus 3 line? What about the line x minus 3? Y equal to x minus 3. What about the line y equal to x minus 3, Baba? 3 is somewhere here, na? So the line is going to go something like this. This is 3. Yes or no? This is y equal to x minus 3. Now tell me one thing, okay? Tell me one thing. What about alpha? Alpha is lying between pi by 2 and 3 pi by 2. That is to fine. But if you carefully observe, where is alpha lying? Huh? Tell me. Where is alpha lying? Think, na? Think. I want you to think. Please think and tell me, where is alpha lying? Exactly where is alpha lying? Hmm? Think, Bhupendra. I want you to think, please. Alpha is the root of this equation. Alpha is the root of this equation. That means alpha is this point, bache. Alpha is the root of this equation. So alpha is the point where both these curves are touching or intersecting. And between pi by 2 and 3 pi by 2, that is the only point where the line and the tan curve is intersecting. So alpha is pakka greater than pi. But what about 4? What about the number 4? See, if I talk about 4, tan 4, this is tan 4 and this is 4 minus 3, which is 1. Is tan 4 greater than 1 is my question. Is tan 4 greater than 1 is my question, everyone. See, 4 is greater than 5 pi by 4. Yes, ma'am? No, ma'am? 16 is greater than 5 pi. This is true, na? This is true. If 16 is greater than 5 pi, that means 4 is greater than 5 pi by 4, which means tan 4 is greater than 1. Tan 4 is greater than tan 5 pi by 4, which is 1. That means tan 4 is greater than 1. Tan is greater than 1. Tan is greater than means what? What is this meaning? This is Baba tan graph. It is greater than the line. That means 4 is lying somewhere after alpha. Are you understanding? 4 is lying somewhere even after alpha. Can you see this? The situation is something like this. I'll draw it again for you to show you clearly. This is pi by 2. This is 3 pi by 2. And your line is going something like, let's say this. Let's say this is your line, okay? This line is actually y equal to x minus 3. Understand very nicely. Understand very nicely. The point at which they are intersecting is actually your alpha. Okay, this is your pi. Now you realize that after alpha, tan is upar, line is niche. After alpha, tan is above, line is below. And you realize that tan 4 is actually greater than 4 minus 3, which is 1. That means tan 4 is greater than the value which you are getting at 4 from this line. That means 4 is lying somewhere here. Baba, alpha is sandwiched between pi and 4. That is what I want to prove to you. If tan 4 is greater than 4 minus 3, which is 1, that means 4 is lying somewhere in that area where tan is above and line is below, which means it's lying here. So alpha is technically sandwiched between pi and 4, which approximately means it's sandwiched between 3 and 4. Now we have come to the options. If alpha is sandwiched between 3 and 4, come to the options. See option A, it says limit x tends to alpha from the right hand side, And don't forget, alpha is sandwiched between 3 and 4. Very, very, very important. GIF of maximum of tan x and what? Fractional part of x. What is fractional part of x? If x is sandwiched between 3 and 4, what is fractional part of x? It is x minus 3. Okay, whole upon x minus 3. All right. What about x minus 3 and tan x? When you are very, very close to alpha but to the right of alpha, what is bigger? Tan or x minus 3? When you are very, very close to alpha but to the right of alpha, tan is bigger than x minus 3. Tan is bigger than x minus 3. So maximum is tan x upon x minus 3. Limit x tends to alpha. Now as I told you, when you are very, very close to alpha, tan is bigger than x minus 3. If tan is bigger than x minus 3, that means tan upon x minus 3 is greater than 1. It's very, very close to 1, but to the right of 1. So GIF will be equal to 1. This is right. This is the correct option. Are you understanding the logic that I'm using? It's beautiful logic. I'll explain you again. The second part. Let's talk about the second part. It says limit. Let's rub this. This is 1. Okay. Limit x tends to alpha from the positive minimum of, okay, tan x And what alpha from the positive? Alpha is coming from 3 comma 4. Alpha is coming from 3 comma 4. If you're approaching alpha from the right hand side, if alpha is coming from 3 comma 4, what is fractional part of x? It's x minus 3 upon x minus 3, and this is the GIF. Now, if you are coming to from the right of alpha, the minimum of tan and x minus 3. To the right of alpha, everybody. To the right of alpha, minimum of tan and x minus 3 is x minus 3. It's x minus 3. The minimum is nothing but x minus 3. X minus 3 upon x minus 3 is 1. GIF is 1. This is also correct. If you are approaching alpha from the negative, that means alpha is now where? Huh? Tell me now. If we are approaching to alpha from the negative, this is to again x minus 3 only. That is fine because alpha is lying only in 3 to 4. So this is fine. Minimum of tan and x minus 3 if you are approaching alpha from the left hand side. If approaching alpha from the left hand side, line is above, tan is below. So line is above, tan is below. Line is above, tan is below. So minimum will be tan. Tan upon x minus 3. Line is above, tan is below. So tan upon x minus 3 will be less than 1. Less than 1 GIF will be 0. This is also correct. Hai na? Similarly, this is also x minus 3. Maximum will be what? Maximum out of tan and x minus 3 is actually x minus 3, the line before alpha. It is the line. So this will be x minus 3. X minus 3 upon tan x you will get. But you know x minus 3 is greater than tan x. So x minus 3 upon tan x will be greater than 1. It will be greater than 1. So GIF will be 1. This is also correct. Is this okay? Is this okay? Give me 1 second. Yep. Is it okay, people? Have you understood? Okay. Have you understood, everybody? Clear? Very, very insightful question, a must-do question. Graphical approach should be clear to you, and how we have concluded about the options, that should also be very clear to you. All right, folks? Okay. Come to this question now. Pretty interesting. H of x is given to you as sine inverse of 1 minus x square upon 1 plus x square, and g of x is x to the power 4 minus 2x cube plus x square plus 4. H increases here, decreases here, decreases here, increases here, whatever. Number of points of non-differentiability of mod of h dash, hx, mod of h of x. What do you think? Huh? G of x is given, na? Compute g dash. You will get 4x cube minus 6x square plus 2x. That means x common, or rather 2x common. You get 2x square minus 3x plus 1. So you get what? 2x. Again, 2x square. Yeah. Minus 2x minus x plus 1. Tell me quick. Break the middle term quickly. Two x common, x minus 1, minus 1, x minus 1. So what are you getting? You are actually getting a 0, half and 1. There is a plus minus. So decreasing, increasing, decreasing, increasing. Basically, question says, if about G I have to talk, G is decreasing in minus infinity to 0 and half to 1. That's it. And G is increasing in 0 to half union 1 to infinity. The question says G is decreasing in minus infinity to A1. Minus infinity to A1. Minus infinity to A1 means A1 is pakka 0. A1 is pakka 0. And G is increasing in A1 comma A2. A1 comma A2. A1 comma A2. A1 is 0. A2 is half. Oh, this is how you have to identify. Oh. This is how you have to identify. G is decreasing here. G is increasing here, which is clearly matching my setup, and I am able to get that, okay, minus infinity to A1, A1 is 0, and A1 comma A2, A1 is 0, A2 will be half. Also, it says G is decreasing in A2, A3. G is decreasing in A2, A3. Half, 1. A2, A3. That means A3 is 1. And it is increasing in A3, infinity. Very true. 1, infinity. Very, very true. Everything has matched. I have got A1, A2, A3. Perfect. A1 I have got. A1 is 0. A2 I have got is half. A3 I have got is 1. A4 I haven't yet got. A4 is what, everybody? A4 is number of points of non-differentiability of mod of h of x. Arey baba, how to get h of x's graph? Sine inverse of 1 minus x square upon 1 plus x square. Till here I feel everybody has understood. A1, A2, A3, everybody has understood. Any doubt, any confusion, stop me right now, guys. A1, A2, A3, any confusion? Stop me right now. Just keep the comments here. Yeah. Okay, now listen to me carefully. Listen to me carefully. As x tends to infinity, what's happening? H is tending to sine inverse what? Minus infinity, which is minus pi by 2. Tell me. If x tends to infinity, where is h tending to? Okay, 1 second. Yeah, tell me. Quick. H of x is sine inverse of 1 minus x square upon 1 plus x square. If x is tending to infinity, where is h tending to? If x is tending to minus infinity, where is h tending to? Answer. Baba, you can take out x square common, na? You will be left with 1 by x square minus 1 upon x square common, 1 by x square plus 1. This is tending to 0, this is tending to 0, left with minus 1. So basically you are left with sine inverse of minus 1. Which is what? Minus pi by 2. And as x tends to minus infinity, again same thing. Sine inverse minus 1, which is minus pi by 2. Yes ma'am or no ma'am? It's tending to minus pi by 2. And if you talk about h of 0, it is sine inverse 1, which is pi by 2. So what are you actually getting? What are you getting? Also, you are given h is increasing in minus infinity to a1, decreasing in a1 to infinity. If h is increasing in minus infinity to a1, a1 is 0, and increasing in a1 to infinity. Okay, fine, not a problem. This is minus infinity, infinity. This is minus pi by 2. Not a problem at all. At 0, it is pi by 2. It is decreasing and going like this. Making sense? It is increasing in minus infinity to 0 and decreasing in 0 to infinity. It is increasing in minus infinity to 0, decreasing in 0 to infinity. At 0, it's pi by 2. Towards minus infinity to infinity, it is approaching to minus pi by 2. What? This is a sharp edged turn. If you take the mod of this graph, whatever part is lying below the x-axis will get reflected and will start going above the x-axis. This will go above, this will go above. This is already above, so you will get 1, 2 and 3. 3 points of non-differentiability for mod h. You have h with you. To get mod h, what do you need? Whatever part is above the x-axis, let it remain as it is. The part which is below, reflect it above. Flip it above. Flip it above the x-axis. You will automatically get 3 sharp-edged turns, 3 points of non-differentiability for mod h. For mod h, which means a4 is equal to 3. So this gives you 4 plus 1 by 2. 4 into 2, 8 plus 1, 9 by 2. 4.5. Is this understood? Is this absolutely clear? Is this absolutely clear? Yes, I hope this is clear. The hint was already given to you, increases where, decreases where. So A1, A2, A3 was very easy to find. What about A4? What about A4? The plotting of graph should be clear to you. And also the limiting behavior, how to compute should be clear to you. And then how to transform the graph of H to mod H should be also clear to you. All right, let's come to this question now. F is given from R to R as this branch function. Okay, this is for x less than 0. This is when x is between 0 and 1. This is when x is between 1 and 3. And this is when x is greater than or equal to 3. Okay. F dash has local max. F dash is not differentiable at 1. F is on 2. F is increasing. What do you think? What do you think? Okay, 1 second. Just try this out. Give me 1 second. Yep. Could you solve? Yes. Could you solve? The first expression itself is something which should give you a big hint. X to the power 5 plus 5x to the power 4 plus 10x cubed plus 10x squared plus 3x plus 1 corresponding to x less than 0, then x lying between 0 and 1, then x lying between 1 and 3, and then x greater than or equal to 3. How to solve this? Look at the options. F is increasing, F is onto, F dash is not differentiable, F dash is a local max. First, let's talk about F is onto. You know the codomain is set of all reals. What about F being onto or not? Number one observation is F is continuous for all x real. You try to compute left hand limit, right hand limit and value of the function at each of the breakpoints at 0, at 1, at 3. You will realize that at each of the breakpoints the function is continuous. It's very simple. You can do it as an exercise. I have done it a lot of times when I've taught this question. I've taught this question I think 4-5 times. It's a very interesting question, very nice question. So please check it out. At the breakpoints, try to check the left hand limit, right hand limit and value of the function. It will match at all breakpoints. And apart from breakpoints, already the function is differentiable. You can see it's polynomial. And then here it's logarithmic. Basically, it's all continuous. So number one, it's continuous. Number two, as x tends to infinity, people, you are going to use which definition? This definition. As x tends to infinity, you're going to use this definition because this is what is valid for x greater than or equal to 3 beyond 3. So as x tends to infinity, this is what is valid. And as x is tending to infinity, log is tending to infinity. This is tending to infinity. Basically, f is tending to infinity, baba. And the third point is, as x tends to minus infinity, now I'm going to use this. Because this is the definition valid for x less than 0, before 0. Before 0, this definition is valid. That means as x tends to minus infinity, this is the definition I'm going to use, which is an odd degree polynomial with positive leading coefficient. So even this will tend to minus infinity. So f will tend to minus infinity. Now imagine function is continuous. As you go to infinity, it's going up, 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 up. As you're going towards the left, it's going down, 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 down. It's completely continuous and it is extending infinitely from bottom to top. That means it is covering all the real values along the y-axis, which means it is onto. This is onto. This is a fantastic approach to prove that your function is onto. It is continuous, and as you are extending towards infinity, your function is going up, up, up continuously. As you are going to minus infinity, your function is going down, 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 down continuously, which means from minus infinity to infinity, it is sweeping all the real values along the y-axis, which means it is completely onto. So f is onto. Is this clear? Is this clear? Now, let's talk about f is increasing in minus infinity to 0. Minus infinity to 0 is this. So, f of x in minus infinity to 0 is x to the power 5 plus 5x to the power 4 plus 10x cube plus 10x squared plus 3x plus 1. Yes, x is less than 0. Minus infinity to 0 basically. But what is this? Can you check what is this? Very interesting, very common. Huh? This is x plus 1 to the power 5 minus 2x. Binomial. Check this out. X to the power 5. 5x to the power 4. 10x cubed, 10x squared. Now I need 5x, but I have a 3x. So plus 2x minus 2x. You're left with minus 2x. That's it. And plus 1 is already there, which is 5c0. Substitute of 5c0. Now when you compute f dash x, what will you get? 5 times x plus 1 to the power 4 minus 2. Is it always positive is my question? No, it's not always positive. I am talking about x less than 0, na? For x equal to minus 1, which falls here, I get 5 into 0 minus 2, which is negative. That means for all x negative, f dash is not positive. For all x negative, f dash is not positive. That means f is not increasing before 0, because there is a minus 1 quantity before 0 at which f dash is negative. It's not positive. So that means f is not increasing in minus infinity to 0. Now question is talking about f dash has a local max, f dash is not differentiable. So let's start at 1. Question is about 1, right? Question is about 1. So let's only focus upon 1. This is one branch, this is another branch. Okay, let's only focus here. So f of x is given to you as x square minus x plus 1, 0 less than equal to x less than 1. And here you have 2 by 3 x cube minus 4x square plus 7x minus 8 by 3, 1 less than equal to x less than 3. Yes, I want to talk about f dash x. Chalo, let's see. So this is 2x minus 1. This is 2 by 3 into 3x square minus 8x plus 7. 0 less than equal to x less than 1 and x greater than equal to 1. All right, this 3 cancels out. Now tell me, f dash 1 from the negative and f dash 1 from the positive. Are you getting the same answer? Left hand derivative and right hand derivative is what I'm computing. So f dash 1 from the left hand side will give you what? 2 into 1 minus 1, which is 1. And f dash 1 from the positive will give me what? 2 minus 8 plus 7. 2 minus 1, which is 1. This means f is differentiable at 1. Okay. F is differentiable at 1. F is differentiable at 1, which means f dash exists. F dash exists at 1. F dash exists at 1. F is differentiable at 1. Achha. I didn't want f is differentiable. I wanted f dash is differentiable or not. So let's compute f double dash, which is derivative of f dash. This is derivative of f dash, na? What is it? What is it? 2 here. And over here you will get what? 4x minus 8. This is x less than 1 and this is x greater than equal to 1. Now f double dash 1 from the negative is 2. F double dash 1 from the positive is minus 4. Clearly not equal. That means f dash is not differentiable at 1. Now wait a second. When you say f dash is not differentiable, let's say you take this as g function. When you say g is not differentiable at 1, when you say g is not differentiable at 1, then 1 happens to be one of the critical points of g, na? You remember? What is a critical point? Critical point is a point where the derivative either vanishes or does not exist. At 1, derivative of g is not vanishing, it is not existing. This means 1 is a critical point for g, which is f dash. It's a critical point. It's a critical point, and what is happening before 1 and after 1? Baba, g dash, 1 from the negative is positive, 1 from the positive is negative. That means there is a sharp turn because the function is not differentiable at 1. But before 1 it is increasing, after 1 it is decreasing. That means 1 is a point of sharp maxima. 1 is a point of sharp maxima for g, which is f dash. For g, that is f dash, 1 is a point of sharp maxima. Is that making sense? Is that okay? Is that okay? Are you understanding till here? Any doubt, any confusion? Stop me right now. 1 is the point of sharp maxima for f dash. Question in the JEE Main paper will not ask you about smooth maxima or sharp maxima. I am telling you because at 1, the graph will not be smooth because the derivative is not existing at 1. The derivative is not existing at 1, so there will have, it's continuous function, but not a differentiable function because f dash is not differentiable at 1. Before it is increasing, after it is decreasing. Point of sharp maxima for f dash. Is it okay? Is it absolutely fine? So f dash has a local max at 1. Now you know the detail. It is sharp maxima. And yes, it is not differentiable at 1. Correct. Yes, it is not differentiable at 1. Is it okay? These type of questions are asked continuously in the paper and you must know how to crack them. What is the logic behind them? The thinking process, the direction, everything has to be very clear. Okay. Number of real and distinct roots of this equation is what? Number of real and distinct roots of this equation is what? Who will tell me? Now see, when you get a question like this in the paper, don't start differentiating. Generally, the moment question talks about number of distinct and real roots, you have to first, you start differentiating, then you start judging its sign. All of this here, if you start doing, it will take you ages to reach the answer. It will take you ages to reach the answer. Don't do this. Please don't do this. What will you do then? Understand. See, understand. The only way out is graph. The only way out is graph. As x tends to minus infinity, this is an odd degree polynomial and that to such a big degree. So f will also tend to minus infinity. And if x tends to infinity, obviously f will also tend to infinity. So one thing is sure, as you move more and more towards the left, the graph will go down, down, down. As you go more and more towards the right, graph will go up, 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 up. And obviously it is a continuous function. Obviously this completely is a continuous function, not a doubt at all. It is 100% continuous. Problem is how to draw the graph. To draw the graph, the hint or the catch or the trick or the shortcut, the hack is, please get the values of the function at some easy inputs. Get the value of the function at some easy inputs. For example, if I ask you compute f of 0, compute f of 1, compute f of 2, compute f of minus 1, compute f of minus 2, this is what you have to do, everybody. Okay, so f of 0 obviously will come out to be positive. F of 1 will be negative. Can you see this? Because there will be minus 119 equal to 0. So completely till minus 119, this is my f of x. Till minus 119 is my f of x. F of 1 will obviously be negative. F of 2 will be positive. F of 3 will be positive. F of 4 will be positive. Basically everything else it will be positive. What about f of minus 1? What about f of minus 1? F of minus 1 obviously will be negative. F of minus 2 again negative. F of minus 3 again negative. And so on. And so on. So this means kind of you are nearing the graph. Can you see this? Kind of you are nearing the graph. F of 0 I told you is positive. F of 0 in fact is 44. Okay, wait a second. Yeah. F of 0 is 44. That is okay. At minus 1 it is negative. But at 0 it's positive. Can you see this? At minus 1 it's negative. At 0 it's positive. At minus 1 it's negative. At 0 it's positive. Yes or no? At 1 it's negative. At 2 it's positive. So at 1 let's say it's negative and at 2 let's say it's positive. Roughly I have drawn. Only roughly. And after 2 though it's pakka positive, positive. Before minus 1 also it's negative, negative, negative. At 0 it's 44. Clearly. This is the rough graph. And number of distinct real roots are coming out to be 1, 2 and 3. 3 is the right answer. So please remember, you can get questions in the paper which are very difficult to differentiate. Very difficult to differentiate, very difficult to analyze their sign, that in what interval they'll be positive or negative. Are you understanding? Very difficult or very lengthy, I should say. That is when you have to use the shortcut or the trick or the approach of hit and trial. Plug in certain easy inputs, find the value of the function, or rather the sign of the function at those inputs, and approximately draw the graph. You will be fine. You will be able to sail through the question very smoothly. Very, very, very smoothly. Is it okay? Is it okay? Yes? See, consider this function. Let the total number of local max and minima points be alpha. Let the total number of local max and local minima points be alpha. Let the maximum value of f of x be beta. Let the non-differentiable points of f of x be gamma. Alpha plus beta plus gamma is equal to what? How do you plan to solve this question? Huh? Tell me. You know, as a matter of fact, the critical point here is 0 and the critical point here is 3. The critical point here is 0 and the critical point here is 3. So obviously the approach which is hands down the best approach is to break this function into pieces. You have to break this function into pieces. Yes or no? Yes or no? Tell me. Hi Harnish. Okay, so you want less than 0, you want between 0 and 3, and you want greater than equal to 3. Less than 0 means what? 1 upon 1 minus x plus 1 upon 1 plus. What is mod of x minus 3? Can you tell me? It is x minus 3 when x is greater than equal to 3, and it is 3 minus x when x is less than 3. Now, when x is less than 0, it means it's less than 3. So, this is 1 upon 3 minus x. This is 3 minus x. So, this is 4 minus x. Perfect. What about 0 and 3? This is 1 upon 1 plus x plus 1 upon, again, 4 minus x. Okay, all right. What about greater than equal to 3? This is 1 upon, this is minus x plus x. Yeah. 1 plus x plus 1 upon, this will be x minus 3, right? 1 plus x minus 3. So, this is x minus 2. Check this out. Okay. Huh? Got it? Akshita. Chalo, this is your f. Let me compute f dash here only. So 1 minus x to the power minus 1, n into x to the power n minus 1. So minus 1 upon 1 minus x whole square. So 1 upon 1 minus x whole square with a minus 1 and another minus 1 because of 1 minus x, it will be plus 1. Plus 1 upon 4 minus x again whole square. This is to pakka positive for all x negative. Can you agree with this? This derivative, this is derivative. This is derivative, na baba? This is derivative. This is pakka positive for all x negative. What about the next one? Let's compute the derivative of the next one. Let's compute the derivative of the next one. What do you get? 1 upon 1 plus x. This will be what? Minus 1 upon 1 plus x whole square plus 1 upon 4 minus x whole square. Tell me one thing. This is the derivative in the region 0 to 3. Will it be 0 somewhere, or it will be positive everywhere, or it will be negative everywhere? Can you tell me? Huh? This is 0 at x equals 3 by 2, which is 1.5, lying in my interval, which is 0 to 3. So my f dash is coming out to be 0 at 3 by 2. Okay, let's come to the last one. This gives me minus 1 upon 1 plus x whole square plus 1 upon x minus 2 whole square. What about this one? Is this everywhere positive or everywhere negative? Minus, minus. This is everywhere negative. So what does this give you as a conclusion? What does this give you? My derivative before 0 is positive. At 0, what is the function's value? Baba? At 0, it is 1 plus 1 by 4, which is 5 by 4. ठीक है. Before 0, it's a strictly increasing graph. At 0, it's 5 by 4. Between 0 and 3, what's happening? See, between 0 and 3, there is a 3 by 2 where your derivative is 0 and it says minus and this is plus. So the scene is this. 3 by 2 is point of minima. Can you see this? 3 by 2 is actually the point of minima. 3 by 2 is the point of minima, and then after 3 it is negative, which means it's decreasing. So now I'm kind of in a position to draw the graph. See, this is somewhere 5 by 4. 5 by 4 is 1 point something, na? Chalo, theek hai. This is 5 by 4, let's say. Theek hai. This is 0. This is, let's say, 3. And as you are approaching to minus infinity, see, as x tends to minus infinity, f is tending to 0. As x tends to plus infinity, again f is tending to 0, na baba? So what is happening? This is going like this. Yup, here somewhere let's say is 3 by 2, decreasing graph, increasing graph, and at 3 by 2, the value of the function is positive, you can check. And after 3, at 3 what is the value, guys? At 3 what is the value? Can you tell me? At 3 what is the value? 1 by 4 plus 1. It's 5 by 4. At 3 the value is 5 by 4 and after 3 again it is decreasing. Can you see this? Can you see this? So it says, let the total number of local max and minima points be alpha. Total number. At 0, can you see this? 0 is the point of local max. 3 by 2 is the point of local min. 3 is the point of local max. That means alpha is 3. Let the maximum value of f of x be beta. That means beta is 5 by 4. Let the non-differentiable points in f of x be gamma. What is non-differentiable points? 1 is this, 1 is this. So gamma is 2. Any confusion? Any confusion? You have alpha, you have beta, you have gamma, you can compute alpha plus beta plus gamma. Such a brilliant question. Such a brilliant question. So please save time and save your energy. Sometimes compute f dash there only. You have f written with you, compute f dash there only. Okay? Is it okay? Hashtag HTCC? Perfect. Wow. Thank you so much, Akshita. Lovely, lovely. I love your comment. Chalo, we'll move ahead now. Alrighty. Yeah, this is a homework question. This I deliberately wanted to give you for homework. Please try it out. It's very simple. Just at the corner points where the definition is changing, at the break point, you apply the definition of continuity and you will be able to sail through the question. If you're not able to do, let me know in the Telegram, okay? This is a fantastic question from where I want to test your knowledge over the shortcut. This shortcut is very, very highly favorable to be asked in your paper this time. So make sure that you are aware of how does the shortcut work. What does it say? F is given to you from minus half to 2, minus half comma 2 to r. G is also minus half comma 2 to r, defined by this and this. What is the correct option out of these four? Tell me. See, it's very simple. First of all, if I talk about f, this is GIF of x square minus 3. Understand carefully. This is GIF of x square and 3 is separate. Now, I know GIF, f will be discontinuous wherever GIF of x square is discontinuous. Here, it is not differentiable. Not differentiable. Okay. So, to talk about f, discontinuity for f, and I have to talk about non-differentiability for g. I have to talk about discontinuity for f and non-differentiability for g. So, where all is f discontinuous? Wherever GIF of x square is discontinuous. And where is that discontinuous? Wherever x square is an integer. So, x square is an integer. Where? Where? Tell me. When x square is 0, 1, 2, 3 and so on. This implies x will be 0, 1, root 2, root 3, 2 and so on. I am only interested in closed minus half to 2. Look at the options. Closed minus half to 2, closed minus half to 2. In closed minus half to 2, this implies x is 0, 1, root 2, root 3 and 2. But guys, you have to make sure you are not including 0. Because GIF of x square is not discontinuous at 0. When you plot the graph of GIF of x square, actually here and here, before 0 and after 0. the limit is 0 only. It breaks at 1, it breaks at -1, but it doesn't break at 0. The graph of GIF of x square does not break at 0. Does not break at 0. That is why please remember this as a word of caution that yes, corresponding to x equals 0, x square is an integer. But at 0, my GIF of x square is not discontinuous. It is in fact very much continuous. Okay, so in -12 to 2, f is discontinuous at 1, √2, √3 and 2. These are the 4 points at which f is discontinuous. So option says f is discontinuous exactly at 3 points. No, it is discontinuous exactly at 4 points. This is to pakka. Now comes G. Very interesting. This is mod x. This is f of x plus mod of 4x minus 7. And this is again f of x. So this means I can write this as mod x plus mod of 4x minus 7. All of this into f of x. Mod x plus mod of 4x minus 7 into f of x. Now listen to me one thing carefully. This is f. I know f is discontinuous at 1, √2, √3 and 2. This implies f is not differentiable at the same points 1, √2, √3 and 2. Pakka. This is to for sure. And if f is not differentiable at these 4 points, this complete function is not differentiable at these 4 points. Pakka. But the point is, I want to talk about non-differentiability for G in the open interval -12 to 2. In the open interval -12 to 2, I can't include 2. So there are only 3 points right now, till this stage. There are 3 points where f is not differentiable in the -12, 2 interval, and hence G is not differentiable. So till now, this implies in -12 to 2 open interval, G is as of now not differentiable at 3 points which are 1, √2 and √3. Till now. Let's see if there are more. Because of f, I have got 3 points of non-differentiability for G, but let's see if there are more. Let's see if there are more. Here I'm going to use the shortcut. This is not differentiable at 0. That means this completely is not differentiable at 0. Now, is f vanishing at 0 is what my question is. No, f is not vanishing at 0 because you are getting GIF of -3, which is -3. Therefore, G is not differentiable at 0. Similarly, next one. This part is not differentiable at 7/4. That means this complete bracket is not differentiable at 7/4. What about this? Is f vanishing at 7/4? GIF of 49/16 minus 3. This will come out to be 3 point something. 0.3. Basically 0. 3 point something minus 3 will be 0 point something whose GIF will be 0. So are you understanding? This part was not differentiable at 7/4 and the product part f of x is vanishing at 7/4. That means G is differentiable at 7/4. This is what is the shortcut, guys. Do you know the shortcut? Do you know the shortcut? If you have f into G, f is not differentiable at A and G vanishes at A. This implies f into G is differentiable at A. But if f is not differentiable at A and simultaneously G is not vanishing at A, then f into G is not differentiable at A. That's it. This is your shortcut. This is exactly what I have used here. This part was not differentiable at 0. This was not vanishing at 0. So my product is not differentiable at 0. But this part once again was not differentiable at 7/4 and this was vanishing at 7/4. So it is differentiable at 7/4. Clear? That means all in all I am getting what? G is not differentiable at 0. G is not differentiable at 1, √2 and √3. So there are 4 points for non-differentiability of G. 4 points, not 5 points. This is how the perfect approach goes in order for you to solve such a question. If you really want to ace these type of questions, you have to make sure you are very much aware of the shortcut. You should be very much aware of how do you have to proceed with such questions. Then these questions become a cakewalk for you. Literally cakewalk. Very, very simple. Is it okay? Clear? Chalo. Come to this one now. Fantastic again. Mod C is less than or equal to half. Let's see if that is a useful piece of information or no. F is a differentiable function at x equals 0 given by this. It's a differentiable function at x equals 0. It's a differentiable function at x equals 0, which first of all implies C. D implies C. So this means F is continuous at 0. The moment you say continuous, it means left hand limit is equal to right hand limit is equal to value of the function at 0. Left hand limit is equal to right hand limit is equal to value of the function at 0. Left hand limit is equal to right hand limit is equal to value of the function at 0. How will this proceed now? Tell me. Left hand limit at 0 will come from here. Value of the function at 0 is half. Right hand limit will come from here. How will you calculate? See, if I talk about left hand limit, it is limit x tends to 0 from the negative, b sine inverse c plus x upon 2. This is your left hand limit. What do you think? What do you think? If x is tending to 0, what will this tend to? B sine inverse c by 2. And this is equal to the value of the function at 0, which is half. So you are getting sine inverse c by 2 is equal to b by 2. Huh? Tell me, na? This is your left hand limit. If I talk about right hand limit, this is limit x tending to 0 from the positive e to the power ax by 2 minus 1 upon x. The problem here is, right now it may seem like this is 0 by 0 form, but what should you do? If it is a 0 by 0 form, we can either try and use standard limit approach or we can use the L'Hopital as well. So let's start. This is ax by 2 and this is 2 by a. E to the power something minus 1 upon something when that something tends to 0 is 1. So this is what equal to a by 2. This is a by 2 and this is also equal to the limit which is 1 by 2. So a ki value is coming out to be 1. So from left hand limit I was not getting anything significant, but from right hand limit I am definitely getting. From right hand limit I am definitely getting the value of a as 1. So the fact that f is differentiable at 0 but you are using it how? That f is continuous at 0. And that is giving you a equal to 1. And that is giving you a equal to 1. Is that making sense? Very good. Very, very good. Bhupendra. A की value तो 1 आ चुकी है. A is पक्का 1. Now question says f is differentiable at 0. That means I want left hand derivative of f at 0 and right hand derivative of f at 0. That's what I want. Those two I will equate and get my final answer. So what about f dash x? When you talk about f dash x, you want to differentiate this function in minus half to 0. So b as it is, sine inverse of c plus x by 2. How will you differentiate? Huh? Tell me. It's 1 upon root over 1 plus c plus x by 2 whole square into 1 by 2. Huh? Is this okay? This is when minus half less than x less than 0. है ना? But if I talk about 0 less than x less than half, Baba, here you can't differentiate directly. Here you can't differentiate d by dx of e to the power ax by 2. D by dx of e to the power ax by 2 minus 1 upon x. D by dx of e to the power ax by 2 minus 1 upon x. This you can't directly do. No. Because at x equals 0, denominator is 0, na? That is why you can't directly differentiate. You will have to use the first principle. You have to use the first principle, everybody. Limit h tends to 0, f of h minus f of 0 upon h minus 0. So limit h tends to 0. What is f of h? E to the power ah by 2 minus 1 upon h. A is 1, na? So let's just write h by 2. H by 2 minus 1 upon h minus f of 0 is half whole upon h. So this gives you what? 2 times e to the power h by 2 minus 2 minus h whole upon 2h square. Tell me. And h is tending to 0. So this to chalo is tending to 0. 2 cancels out. This 2, this 2, this 2. So you are actually left with e to the power h by 2 minus 1 upon h square. H into h. Tell me. Or rather, what you can do is, if you don't want to proceed with this way, you can also think of it as a 0 by 0 form. This is also true, na? Baba, you are simplifying. You can see it's a 0 by 0 form. So go ahead and differentiate. Go ahead and differentiate. What will you get? This will come out to be 2 times e to the power h by 2 into 1 by 2. 2 cancels out. You're left with e to the power h by 2 minus 1 upon 4h. I want h by 2 below as well. Remember e to the power theta minus 1 upon theta. So I want h by 2. So 4 is here. H upon 2 into 2. And you are done. You are done now. See, this much part is tending to 1. 1 by 8 is your limit. Can you see this? So your right hand limit, f dash of 0 from the right hand side is coming out to be 1 by 8. And f dash of 0 from the left hand side is coming out to be, see, b upon root over c square by 4. Yes or no? Everybody, please tell me. Huh? This is b upon root over 1 plus c square by 4. So 4 will come here and under root 4 is 2. 2 will go here. And there is an into 1 by 2. 2 cancels out. We're left with b upon root over c square plus 4. So f dash of 0 from the right hand side is equal to f dash of 0 from the left hand side. They are equal. Because f is differentiable at 0, that is why they are equal. Because f is differentiable at 0, that is why they are equal. So you are getting b upon root over 4 minus c square. Listen to this. 4 plus c square is equal to 1 by 8. What do you want? 4 minus c square upon b square. How will you calculate? Oh, there is a minus here. That's what I was thinking. Formula is minus, 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 minus. Yes. So you are getting root over 4 minus c square upon b is equal to 8. Squaring both sides, you get 64. 64 is the right answer. 64 is what this is equal to. But the question is very interesting. You know why? Why is this question interesting is because first of all, you are using the fact that f is differentiable at 0. How? That f is continuous at 0. From there, you are getting a equal to 1. Now, because f is differentiable at 0, left hand derivative equal to right hand derivative. But the right hand derivative you cannot find without using the first principle. First, once you've got right hand derivative of f at 0, similarly you get left hand derivative of f at 0, equate them, get the answer. Brilliant question. First class. One of its kind and very, very interesting, very rich variety. Okay, come here. This is a traditional question, I believe, but must do, must do. First of all, sin x square upon x square into x square. This is tending to 1. You have x cube in the denominator. Now, what you are left with is limit x tends to 0, alpha e to the power x plus beta e to the power minus x plus gamma sin x whole upon x cube. Obviously, I will be using the approach of expansion. Because the moment I use expansion, I know as a matter of fact that I will only expand till my denominator's degree, which is the minimum degree of the denominator, which is 3. That is exactly till where I have to expand, nothing else. Yes or no? This is exactly till where I have to expand. So you will get alpha 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. I will not expand any further. I'll write plus so on. I'll explain you, but I will not expand. E to the power minus x, tell me. Tell me. Come on. Minus x, just replace x with minus x. 1 minus x plus x square by 2 factorial minus x cube by 3 factorial plus and so on. Huh? This question seems hard at first, but now it's better. Great. Similarly, x minus x cube by 3 factorial, which is 6 plus and so on. Yes, whole upon x cube. So whole upon x cube, listen to me now. Listen to me now very carefully. Whole upon x cube. First, separate the x cube term. So rather, okay, let's start. Alpha plus beta. That's it. This is a constant. Now, coefficient of x is alpha minus beta plus gamma. This is coefficient of x. Now, x square. Alpha by 2 factorial, beta by 2 factorial. That's it. This is x square. Now, x cube. Alpha by 3 factorial minus beta by 3 factorial minus gamma by 6. This is x cube plus everything to the power 4, 5, 6 and so on. Upon x cube, upon x cube, upon x cube, upon x cube, terms which will come after x cube, which will have greater powers of x in the numerator, upon x cube. When you cancel out the powers, you will have some positive power of x left in the numerator. All of them will tend to 0. So everything beyond this will keep tending to 0. No sense? Now, listen to me. Here to x cube cancels out. You are only left with this term, which is your actual limit. Why? Because here if you cancel out, you will get a positive power of x in the denominator, which means something upon 0 tending to infinity. If this tends to infinity, my entire limit will be infinity. It will contradict the fact that my limit is a finite quantity. That means this has to be 0. This has to be 0 so that there is no x square term. Similarly, when you cancel this out, you have x square in the denominator. No, not possible. This has to be 0 so that this term vanishes. Similarly, here 1 upon x cube, that means infinity. If alpha plus beta is non-zero upon x cube, that means infinity. My limit will not be finite. That means this term has to vanish and hence this also has to be 0. So alpha plus beta will be 0, 110% alpha plus beta will be 0. Next was alpha minus beta plus gamma. This will be 0. Up next is alpha by 2 plus beta by 2. So 1 by 2 times alpha plus beta, again it is the same thing, is 0. And what you will be left with is just this quantity, x cube has cancelled out. We are left with just this quantity, which is my limit, alpha upon 6 minus beta upon 6 minus gamma upon 6. Okay, so alpha minus beta minus gamma upon 6 is 2 by 3. So alpha minus beta minus gamma is 4. Is it okay? Please check this out and tell me if there is any problem. We have many equations corresponding to alpha, beta, gamma. Okay, so you have this, and you have this. When you solve these equations simultaneously, alpha comes out to be 1, beta comes out to be minus 1, 2 and gamma comes out to be minus 2. What are you saying? Okay? Gamma comes out to be minus 2 and accordingly you can then obviously check. Plug in the values of alpha, beta, gamma in these expressions, in these options and then check. One second. Yeah. And then you can check which one is getting satisfied, which one is not getting satisfied. But the entire game revolves around finding alpha, beta, gamma and how we only expand. The sense only makes when you expand till the minimum degree of the denominator. Okay? That is the main catch. Okay? Alrighty, folks. Chalo. Let's come to this one. This is a very easy question and a must-do question from functional equations. Must do, must do, must do. What is it? It says f of 3x minus f of x is equal to x. Now, obviously, I want f of 14. I am given f of 8. So, somehow I am interested in f of x. So, let's replace x with x by 3. If I do that, I get f of x minus f of x by 3 is equal to x by 3. Again, do it. X replace with x by 3. You get f of x by 3 minus f of x by 9 is equal to x by 9. Again, you do it. You get f of x by 9 minus f of x by 3 cube is equal to x by 3 cube. Okay, this is 3 square. Okay, do it again, do it again, do it for the, okay, this is once, this is twice, this is thrice. Now apply it nth time. X going to x by 3. This will be f of x upon 3 to the power n minus 1 minus f of x upon 3 to the power n is equal to x upon 3 to the power n. Can you see this? That's the connection, na? If there is 3 cube, here is 3 square. Here is 3 square, here is 3 to the power 1. Here is 3 to the power 1, it is 3 to the power 0. So here if it is 3 to the power n, here it will be 3 to the power n minus 1. Okay, now add. When you add, what do you get? This cancels out, this cancels out, this cancels out, and so on, this cancels out. You are left with f of 3x minus f of x upon 3 to the power n is equal to, add all the right hand sides. You will get x common 1 plus 1 by 3 plus 1 by 3 square plus 1 by 3 cube plus 1 upon 3 to the power n. Is this making sense? Yes, as n tends to infinity, 3 to the power n tends to infinity. That means this completely tends to 0. Yes, so you get f of 3x minus f of 0. We are making it tend to infinity, okay, is equal to x. And then 1 plus 3 plus 1 by 3 square and so on. This is like an infinite GP as n tends to infinity, guys. As n tends to infinity, this will be an infinite GP. What is the common ratio? 1 by 3? A upon 1 minus r. A upon 1 minus r. 1 upon 1 minus 1 by 3. This is 2 by 3. This is actually 3 by 2, which is 3x by 2. Okay? What is f of 0? You don't know? What is f of 0? Huh? Tell me, how will you get f of 0, Baba? You have f of 3x minus f of 0 is 3x by 2. Chalo, cool. This much is to chalo, cool. If you plug in x as 8 by 3, you get f of 8 minus f of 0. 3 by 2 into 8 by 3. This cancels out. You're left with 4. That means an f of 8 is 7. So f of 0 is 7 minus 4, which is 3. Acha, this is 3. Now what you want is f of 14. So you plug in x as 14 by 3. Plug in x as 14 by 3. You will get f of 14 minus 3 is 3 by 2 into 14 by 3, which is 7. So f of 14 comes out to be 10. That's it. F of 14 comes out to be 10. Is it okay? So questions like these from functional equations are very common, very popular, and you must know how to crack them. The approach should be something which is familiar to you, and the procedure, the methodology, you should be comfortable in applying it. Not just learning, applying as well. Chalo. Let's go ahead. Let's go ahead and talk about integration. How do you think you're planning to solve this? Come on, people. Integral 1 to root 2 plus 1, x square minus 1 upon x square plus 1 into 1 upon root over 1 plus x to the power 4. What do you think? Hi, JEE Tamil. Okay. You're ready for it? Then tell me. It's not a very difficult question, I believe, because if you try to do it like this is root 2 plus 1, chalo, cool, x square common 1 minus 1 by x square upon x square common 1 plus 1 by x square. Okay, deliberately I'm doing this. And then you have 1 upon, again, root over x to the power 4, 1 plus 1 upon x to the power 4. But root over x to the power 4 is what? X square only. And there is a root here. So what is the point of doing all this? What is the point of doing all this? Huh? Tell me, what is the point of doing this? Come on, answer, people. Chalo, I'll tell you one thing. See, this part is sorted, x square common 1 minus 1 by x square. This is x square plus 1. I can write this as x common x plus 1 by x. Yes, ma'am, no, ma'am. X square plus 1 only you will get, na? I've taken out x common x plus 1 by x. Okay. 1 upon root over. This is x square. Don't take out x to the power 4 common, because when we took out x to the power 4 common, we were landing nowhere. So let's take out x square common. I'll be left with 1 by x square plus x square. And root over x square is x. So you are basically getting x outside x square plus 1 by x square. Now the magic is x into x is x square cancels out. You are left with 1 to root 2 plus 1, 1 minus 1 by x square upon x plus 1 by x, and root over x square plus 1 by x square dx. This is the beauty. This is where the thought goes. This is the only place where the thought goes. So tell me, which substitution will work in my favor? X plus 1 by x? If I take x plus 1 by x as t, obviously 1 minus 1 by x square dx will be equal to dt. Yes, so this is dt upon t. What about root over? Huh? And what about the limits? When x is 1, t is 2. When x is root 2 plus 1, what is t? See, root 2 plus 1 upon root 2 plus 1. So root 2 plus 1 into root 2 minus 1 into root 2 minus 1. This too is 1, root 2 plus 1 plus root 2 minus 1 gives you 2 root 2. 2 root 2 is your upper limit. Huh? This will be t square minus 2. That's it. Now so I feel you can complete, no? Linear into under root quadratic. Yes or no? This is dt upon linear into under root quadratic. Very famous. Can you complete? What is the way to complete? What is the way to complete? Always, 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 always. This t that you can see here, take it as 1 by u. So dt is minus 1 by u square du. That's it. Now you can complete. Okay, I've given you all the hints, all the processes, all the procedures, all the nitty-gritties where you would need help. That is done. The algebraic part I want you to complete, please. Will you do it? Will you do it? Yes? Is it understood? Whenever you get a question like this, people, you know what to do now. And the moment you reach this stage, it's very evident that take x plus 1 by x as t. So 1 minus 1 by x squared dx will be dt. My limits will change. The moment I get linear into under root quadratic, take the linear part as 1 by u and you are sorted. Very good. Very good. This will be the right answer. Okay? Chalo. Good, good students. Very good. Come to this one. I'm only solving those integrals which are literally very popular or which have been asked tremendously in the past, and the pattern of them being repeated, the probability of that pattern being repeated is super duper huge. Now this looks very complicated, but I'll tell you one thing. See, x to the power 332 is an even function. X to the power 998 again even function. X to the power 1664 even, but it's multiplied with sign which is odd. So this completely is odd. That means basically what I can do is see the smartness. -1 to 1, 2x to the power 332 plus x to the power 998 upon 1 plus x to the power 666. Okay, fine. Again -1 to 1, 4x to the power 1664 into sine of x to the power 691 upon 1 plus x to the power 666. As I just told you, bache, this is an even function, but this is an odd function. Even into odd is odd. Yes or no? This is to pakka even. Even upon even is even, but there is an odd involved, na? So minus a to a odd function's integral is nothing but big fat 0. This completely is an even function. So minus a to a becomes equal to twice of 0 to a. Minus a to a becomes equal to twice of 0 to a. 2 times x to the power 332 plus x to the power 998 upon 1 plus x to the power 666 dx. So unnecessarily they had given us expressions which were scary, but technically it's not that scary. The odd part has completely vanished. You are only left with the even part. So what do you think? The odd part has completely vanished. You are only left with the even part. What do you think? Odd part has vanished. You are only left with the even part. What do you think? Huh? Baba, look at the numerator, na? This is x to the power 332. If you take out common, you're left with 2 plus x to the power 333. 666. 6, 7, 8, 9 and 9. Yeah, 998. Whole upon 1 plus x to the power 666. Now can you tell me what to take t as? What do you want to take t as? X to the power 333 will be t. So 333 x to the power 332 dx will be equal to dt. Are you understanding? So this is 2 upon 333. This is dt, and 2 plus x to the power 666 is actually t square. This is dt. Whole upon 1 plus. Is this understood? And the limits are from 0 to 1. So this is very funny. Like the question has somehow become very simple. This is 0 to 1, 2 plus t square. This is t square plus 2 upon t square plus 1. Simple now? Huh? It's easy now. You can write this as 1 plus 1. So this is 1 plus 1 upon t square plus 1 is tan inverse 1 from 0 to 1. Tan inverse t basically from 0 to 1. So this is 2 by 333. So this is 2 by 333, 1 plus pi by 4. That's it. That's your answer. So the question looked very difficult. That is why I always say, don't judge a book by its cover. Try to scan the expression a bit. Try to figure out the even odd part. The odd part is completely going to vanish. It's a 0. The only thing is the even part. From there also we are getting common outside, and it's giving me a very direct hint to take what as t, to substitute what as t. Okay? Cool? Yup, another very famous category, people. This is the Newton-Leibniz rule, and I want all of you all to please pay attention. F of x is x square plus this integral. Okay, fine. What is summation k going from 1 to 9 f of k? Let's see. Let's see. F of x is x square, 0 to x e to the power minus t f of x minus t dt. Please do not apply the Newton-Leibniz rule right now. I have always told you, at the top of my voice, I've told you, for applying the Newton-Leibniz rule, the integrand has to be a single variable function. The integrand has to be a single variable function. To apply my Newton-Leibniz rule, my integrand has to be a single variable function. Right now, this is not single variable. How will I make it single variable? It involves t and x both. How will I make it single variable? And the biggest problem is x minus t sitting like an implicit part. How to separate x and t? It's not possible. So I'm going to use the King's rule. This is where the King's rule will come and help me. What does the King's rule say? What does the King's rule say? My variable of integration is t. So replace t with 0 plus x minus t. That is my King's rule. So I will get f of x as x square plus 0 to x e to the power. What is t? X minus t. This is t minus x. F of x minus x plus t. So this is just t. And this is how you have made your input free from x. Now this is e to the power t minus x, e to the power t into e to the power minus x. I told you can very easily make it free from the unnecessary variable. Bring it outside. Just bring it outside. You will get x square plus e to the power minus x, 0 to x, e to the power t, f of t dt. Are you understanding? Now my integrand is a single variable function. Now my integrand is a single variable function, and now I will go ahead and differentiate. So I will get what? I will get f dash x is equal to 2x plus. This part to chalo is differentiated. This part is differentiated 2x. What about this part? You will apply, bachche, your product rule to differentiate. No. So let's apply. Let's apply. This is first function. Differentiation of second. Apply the Newton-Leibniz. E to the power x into f of x. E to the power x into f of x. First function, differentiation of second, plus second, which is 0 to x, e to the power t, f of t dt. This is the second function. Into differentiation of first, which is e to the power minus x into minus 1. Now, you know, as a matter of fact, this is just 1. So you are left with 2x plus f of x minus, what is this complete part, Baba? What is this? This is nothing but 0 to x e to the power t minus x f of t dt. And this integral is nothing but this integral only, na? So its value is f of x minus x square. So replace this completely with f of x minus x square. That's the catch. That's the catch. This is the catch. So you will get 2x plus f of x minus f of x plus x squared. This cancels out. 2x plus x squared. That's it. F dash x is equal to 2x plus x squared. So f of x comes out to be what? 2x square by 2 plus x cube by 3 plus c. Now, it's very simple for you to get the initial value condition. F of 0 I know will be 0 to 0. This to completely will be 0. F of 0 will be 0. If f of 0 is 0, c will also turn out to be 0. That means your f of x finally is x square plus x cube by 3. That's it. Okay, now you want what? Summation f of k going from 1 to 9, right? So summation x square and then 1 by 3 summation x cube. That's it. That's it. Sum of squares of first 9 natural numbers. N plus 1, 2 into 9 is 18 plus 1, 2n plus 1 by 6 and then 1 by 3. This is n plus 1 by 2. n plus 1 by 2 whole square. That's it. Interesting? Very interesting. Very, very interesting. Okay, very famous category, bache. I hope you understand how to crack these questions. Chalo. Yup. Come to this one and tell me. This is again a category where, one second. Yeah. This is again a category which is very famous. And I want you all to please brainstorm upon how will you crack this question. Generally, students say, ma'am, take out the highest power common. Please see if that is working in your favor. Please check if it is working in your favor. If it is working, bahut badhiya. Very good. But please check first. Take out the highest power common. You know, if you do that, highest power means x to the power 15 plus x to the power 9 plus 1 whole square means I'm asking you to take out x to the power 30 common. So if you take out x to the power 30 common, here you'll be left with 1 upon this is 1, 9, 10, 11, 12, 13, 14, 15. This is to the power 6 and 1 upon x to the power 15 whole square. Check this. Yeah. And here you will have 6x to the power 23 minus 9x to the power 8 dx. So 6x to the power 23 upon x to the power 30 is x to the power 7. 9 upon x to the power 22. Chalo. This is 1 upon 1 plus 1 upon x to the power 6 plus 1 upon x to the power 15, and this is whole square. Correct? Very common category, people. Very common, but there is a catch. Generally, when you take out the highest power common from the denominator, after that, when you simplify, you are left with the possibility that when you take denominator as t, the differentiation will come out to be the numerator. Yes or no? When you take the denominator as t, when you substitute the denominator as t and differentiate both sides, your numerator will be produced. But is that happening? Is that happening? If you take the denominator right now as t, the differentiation is not the numerator. If you take the denominator as t, the differentiation is not the numerator, and that is why taking out the highest power common, take out the highest power common doesn't work. What works is instead take out second highest power common. Take out the second highest power common. That's it. That's it. What is the second highest power? It is 9. Tell me. Yes? So you will take out x to the power 9. 9 square is 18. So this is it. 9, 10, 11, 12, 13, 14, 15. This is 1 plus 1 upon x to the power 9 whole square. Now here you will get what? 6x to the power 23 minus 9x to the power 8. That's it. So you are getting, now you will get 18, 19, 20, 21, 22, 23. So x to the power 5 minus 9x to the power 10 upon x to the power 6 plus 1 upon x to the power 9 dx. That's it. Now you will get your answer. Now it's very simple. This is square. So you take x to the power 6 plus 1 upon x to the power 9 as t. And the numerator will turn out to be dt. So you will get 1 upon t square, that's it. Minus 1 by t plus c. This will be integration 1 upon t square dt, which is minus 1 by t plus c. That's your answer. So you are taking just this part as t. So differentiation is coming out to be the entire numerator. That is for sure. But how is it working? When you are taking out the second highest power from the denominator common, not the highest power, the second highest. Okay? So if you remember this question, it's a very classic question. Generally, the tendency of students is to take out the highest power common, but that doesn't work all the time. So you have to make sure that if that works, great. If that doesn't work, take out the next highest, basically the second highest power as common. Okay? Is that making sense, everybody? Nidhya is asking, how long is this session? This is going to be a little long. It's math at the end of the day. Yes? And if you want to crack those 40, 50, 60 marks by just watching one session, this is that session. Let's start. Why is the solution of this differential equation satisfying this if the right hand limit is r, left hand limit is l plus r is equal to what? See, dy upon y minus 1 into y minus 3 is equal to dx. Obviously I'm going to apply my partial fractions. Obviously, I will apply my partial fractions. What will I get? See, 1 upon y minus 1 into y minus 3 is a upon y minus 1 plus b upon y minus 3. Now, understand the shortcut. Y is equal to 1. Plug it here. What are you getting? Minus 2. Minus 2. This is minus 2. And y equal to 3. Plug it here. What are you getting? 1 by, this is minus 1 by 2. Yes? Plug in 3, this is 1 by 2. So basically you are getting 1 by 2 as it is, 1 upon y minus 1 minus 1 upon y minus 3. That's it. That's it. So integration 1 by 2 as it is, 1 upon y minus 1 minus 1 upon y minus 3 dy. Yes, this is equal to integral dx, which is x only, plus c. This much though is very cool. What is this? Log of y minus 1 minus log of y minus 3 is log of y minus 1 upon y minus 3, and there is a 1 by 2 and there is an x plus c. Now y of 0 is 2. 2. That means log 1 is 0 and this is 0. So c is 0. Okay. Y of 0 equal to 2 say we have got c is 0. So you are getting 1 by 2 log of mod of y minus 1 upon y minus 3 is equal to x. Or rather 2x. Very good, Priyanshu. Yes, this means mod of y minus 1 upon y minus 3 is e to the power 2x. Now tell me, I want limit as x tends to infinity and limit as x tends to minus infinity. See, as x tends to infinity, e to the power 2x tends to infinity. So mod of this also tends to infinity. That means y minus 1 upon y minus 3, mod of something tends to infinity means they are also going to infinity. Hai na baba? Y minus 1 upon y minus 3 also goes to infinity. But this is only possible when y minus 3 tends to 0 or y tends to 3. This is your right hand limit. Are you understanding? Similarly, y minus 1 upon y minus is e to the power 2x. As x tends to minus infinity, e to the power 2x tends to 0. That means this mod tends to 0. Mod of something tends to 0 when that something tends to 0. Na? But this is only possible when y minus 1 tends to 0 or y tends to 1. This is your left hand limit. So L is 1 and R is coming out to be 3. L is 1, R is coming out to be 3. That means your answer is 4. L is 1, R is coming out to be 3, so your answer is 4. This is a different type of differential equation question. Of course, the standard ones, so you have done a lot. That also you'll be practicing, but this is a different type which you must be aware of. Be aware of. Okay? Yup. Come to this one, people. What it says is y plus y cube by 3 plus x square by 2 dx, x by 4 plus xy square by 4 dy. Satisfying f of 0 is 0. What is f inverse of minus 1? Who will tell me how to crack this? It's very interesting. Very interesting. Tell me. Huh? Tell me. So you can write it as y plus y cube by 3 plus x square by 2, divide by dx throughout, plus xy square by 4 dy by dx is equal to 0. Homogeneous, you are saying. You know what? Catch hold of this. Y plus y cube by 3 is t. 1 plus 3y square by 3 dy by dx is equal to dt by dx. This cancels out. So 1 plus y square dy by dx is equal to dt by dx. Is this useful? Yes, because you know what? This is x plus xy square. Take out x common. This is 1 plus y square and this is x by 4. So 1 plus y square dy by dx is actually dt by dx. Okay. So you are getting t plus x square by 2. Can you see the magic? T plus x square by 2 plus x by 4 dt by dx. That's it. That is it, people. That is it. Are you understanding? So x by 4 dt by dx plus t is equal to minus x square by 2. तभी तो सिखा रही हूँ प्रियांशु. Okay. Now divide by, multiply by 4 by x you can say. So you will get dt by dx, multiply by 4 by x. 4 by x times t equal to minus x square by 2 into 4 by x. So this comes out to be 2x. So minus 2x. Are you understanding? Dt by dx, then you have plus 4 by x times t is equal to minus 2x. What is this? This is now a linear differential equation and you have a big smile on your face. You have it or not? Yes, dy by dx plus py equal to q, e to the power integration of p dx, which is e to the power 4 times log x, which gives you x to the power 4. Check this out. So y into integrating factor is integration of q into integrating factor dx plus c. Will you do it now? Will you do it now? T into x to the power 4 minus x to the power 6 by 3 plus c. Nishant. Yep. Plug back the value of t, cross multiply. Can you get the answer? See, y plus y cube by 3 into x to the power 4 is minus x to the power 6 by 3 plus c. But f of 0 is 0, na? Because f of 0 is 0, f of 0 is 0, c will be 0. If c is 0, I don't need to write it here. Achha, now you tell me, how will I compute f inverse of minus 1? Tell me, na? See, 3y plus y cube and this is minus x square. Chalo, most simplified. Most simplified is this. Okay? Now, what do I want? I want f inverse of minus 1. Y is f of x. If I say f inverse of minus 1 is p, that means minus 1 is f of p. This means minus 1 is f of p. That means p comma minus 1 is the point which lies on f. है ना? So p comma minus 1 lies on f. If x is p, y is minus 1. So minus 3 minus 1 is equal to minus p square. 4 is equal to p square. P is equal to plus minus 2. P is what? X coordinate. But x coordinate is only allowed to be positive. That means p is 2. P is 2 means f inverse of minus 1 is 2. Is this okay? Nice question, right? The end was a good twist. End was a very good twist. Yes, such a good twist. Okay. Very, very, very nice type of a linear differential equation which initially demanded substitution because it was a Bernoulli's equation which got converted to linear. And after that, what happened? Towards the end, a direct value finding was not given to you. You had to take f inverse of minus 1 as p. That means p comma minus 1 is what satisfies the equation and from there you get the value of p. Okay. Cool. This is a very nice homework question. I would love to give you as homework. Please make sure you are solving it carefully, corresponding to x positive and negative. I have solved it a lot of times and I don't want to solve it again. Please brainstorm upon it and let me know in the comments what is the answer. Okay? It's an easy question, small question. The only problem which students have here is they don't consider x to be the variable. X can be positive or negative. Depending upon x being positive or negative, you get two definitions of f. That is the only catch. Okay? Chalo. This is a fantastic question. Let me solve this for you. If the area of the bounded region is this. Okay. What else? If the area of the bounded region, max of 0 and log x, less than equal to y, less than equal to 2 to the power x, when x is sandwiched between half and 2. Yeah, graph is the only way out. Graph is the only way out. Y is sandwiched between maximum of 0 and log and less than equal to 2 to the power x. Chalo, okay. So if I talk about just half to 2, let's see. Half to 2. Here somewhere is half, then 1, and then here somewhere let's say is 2. Between half to 2, this is the log function. It is 0 at 1, whatever at half I don't care, and it is whatever at 2. Chalo, cool. This is my log function. And in the same interval half to 2, I want the 0 function. 0 means x-axis. Okay, fine. I want the maximum. Now here the maximum is 0 and here the maximum is log. That means the function maximum of 0 and log in the interval half to 2 is my blue rail ki patri wala graph. You know, the zigzag graph is actually my final graph, which is this one. Okay, fine. Next is 2 to the power x in the same interval. So 2 to the power half is root 2, 1.414. Okay, fine. And 2 to the power 2 is 4. 4 is to bapre. Okay, fine. Y is greater than equal to this and less than equal to this. That means actually the question is about computing this area. How many of you all understood? It's about computing this shaded region. How will you do it? It's very simple. You integrate from half to 2 the entire area below the upper curve. This is 2 to the power x, na? So 2 to the power x dx. This to completely under this entire curve you have computed. Now from here you will subtract 1 to 2 everything in this region which is below log x. That's it. Are you understanding? Are you understanding? So your answer is half to 2, 2 to the power x minus 1 to 2 log x. So this is 2 to the power x upon log 2 from half to 2 minus x log x minus x from 1 to 2. Okay, so 1 upon log 2 as it is, this is 2 square minus root 2 minus 2 log 2 minus 2 minus this plus 1. 2 log 2 minus 2 minus this plus 1. Yeah, minus 2 plus 1 is minus 1. See this? है ना? This is 4 minus root 2 log 2 की power minus 1 plus beta times log 2. So this is minus 2 times log 2 plus 1. That's it, guys. This is done. This question is done. So this is your alpha, beta is minus 2 and gamma is 1. That's it. Okay. Okay, not that challenging. Okay, fine. Don't get scared by just looking at the question. It's just a question. Please don't get scared by looking at the question, okay? Is it okay? I don't want you, my students will not get scared by just looking at the question. This is the last question for calculus and then we'll move on to conics. But let's solve this. A is a positive real number such that 0 to a e to the power x minus gif of x is fractional part of x. Chalo, is 10e minus 9. 10e, okay, fine. Then a is equal to what? How will you solve this? How will you solve this? How will you solve this? Shall I give you a hint? See, a is gif of a plus fractional part of a. That is what is a. Now you want to integrate from 0 to a. You want to integrate from 0 to a. What will you do? Tell me. It's like this, na? This is 0. This is say gif of a and say this is a. Like, right? In general, a is a real number. It's fractional part and it's integral part. So you can write this as 0 to gif of a plus gif of a to a. Right? Now 0 to gif of a. And here you have e to the power fractional part of x. How will you resolve? See, it's very simple. This is gif of a times 1. 1 is the period of e to the power fractional part of x because it is the period of fractional part of x. So gif of a will come outside and you will be left with just 0 to 1. And in 0 to 1, fractional part of x is x. What about this? When you go from 5 to say 5.6, 5 to 5.6, what is fractional part of x? X minus 5. So this is x minus gif of a. That's it. That's it. Okay? Okay? This is gif of a as it is. This is e minus 1. E to the power x minus gif of a from gif of a to a. That's it. This you can solve further. I just wanted to give you a flow, a hint as to how can you use the fact that a is equal to gif of a plus fractional part of a and then solve. Periodicity bhi bhul gaya. Don't forget periodicity. Because of the periodicity factor, this integral was so simple. It came out to be so simple. Okay, rest I guess you can complete. This is very simple. The right answer is 10 plus log 2. Yeah. Just simplify, nothing else. The only catch or the difficult or the tough part is to start this question. That's it. Otherwise, it's very simple. Okay, cool. So let's take a quick 2 to 5 minute break. We'll be back at, let's say, 21. At 21, let's say 20. Okay, I'll see you in 5-6 minutes. Okay. Alrighty. Are we set? Are we set to dive into conic sections now? Are we set? Okay. Yup. All set? Priyanshu is love. Okay. ABC are given to you as vertices of ABC. I believe you should be able to do this question if it comes in the paper. If this is the circumcenter of the triangle, which of the following is not correct about ABC? Now, the best part about the coordinates given to you is that you can very easily, very smoothly plot them. See, okay, give me 1 minute, guys. Give me 1 minute. I'll just quickly add the slides and come back. Give me 1 minute. All right, people. Okay. Chalo. Are we set? This is done. Yup. Let's see this. So as I was saying, it's very simple for you to be able to plot the triangle involved in this situation. It's very simple because it's alpha comma minus 2, then alpha comma 6, and then alpha by 4 comma minus 2. Tell me. So alpha comma minus 2, then there is alpha comma 6, and alpha comma 6 and alpha comma minus 2 obviously are perpendicular to my x-axis, right? They're joined by a line which is vertical. This alpha comma minus 2. Yep, and then there is what? See this? Alpha by 4 comma minus 2. So it will lie like horizontally. Alpha by 4 comma minus 2. When you join this, what you end up getting is a right angle triangle. This is a right angle triangle. This is A, this is B, and this is C. It's a right angle triangle. Now question says circumcenter of this triangle is 5 comma alpha by 4. You should know as a matter of fact, everybody. Very good. Yes, Raj, you should know as a matter of fact that inside a right angle triangle, the circumcenter is nothing but the midpoint of the hypotenuse. It is the midpoint of the hypotenuse, that is the circumcenter, which is given to you as 5 comma alpha by 4. Because M is the circumcenter, which is sitting at the midpoint of the hypotenuse, I know that M, which is 5 comma alpha by 4, is actually using the midpoint formula. It is alpha plus alpha by 4 upon 2, comma 6 minus 2 upon 2. Midpoint formula, nothing great, just midpoint formula. Okay, so it will be 5 alpha by 8 comma 4 by 2, which is 2. This is 5 comma alpha by 4. So if you know this, you know alpha by 4 is equal to 2. So alpha is equal to 8. The moment you get alpha as 8, you know this point is 8 comma minus 2. You know this point is 8 comma 6. You know this point is 8 by 4, 2 comma minus 2. Yes, absolutely correct. Absolutely correct. Now what? It says area is 24. How to get the area? Half into base into height. What is the base length? Tell me, this is 2 comma minus 2, 8 comma minus 2. Base length is 6. What about the height? Height is equal to what? 2 units down, 6 units above. Height is 8. Height is 8. So half into base into height. This is half into 6 into 8. This is 24. Which of the following is not correct? This is so correct. Perimeter will be what? This is 6. This is 8. Under root of 64 plus 36. Under root 100, which is 10. So hypotenuse is 10. Perimeter will be 8 plus 6 plus 10. 24. Perimeter is 24. Perimeter is 8 plus 6 plus 10, which is 24. Here it's written 25. So this is right. What about circumradius? Circumradius, what is the formula for circumradius? This is ABC upon 4 del. What is circumradius? ABC upon 4 del. But because my circumcenter is lying on the midpoint of the hypotenuse, if I go ahead and I draw the circle, if I draw the circumcircle of this triangle, I know M is actually the center, which is a circumcenter. So from M, if you go here, this is my circumradius. From M, if you go here, this is my circumradius. From M, if you join this, this is my circumradius. So complete hypotenuse is of length 10. Its half will be 5. 5 will be my circumradius. But if you use the formula as well, ABC means 10 into 6 into 8 upon 4 times area, which is 24. And this is also 5. So because this is a right angle triangle, you can very easily compute the circumradius because it is half of the hypotenuse. Yes, but even if you don't know this, ABC upon 4 del is the formula. Yes, so this is correct. That means option is wrong. In radius, what is the formula for in radius? Who will tell me? In radius, come on. Yes, absolutely correct. Del upon S. Del is 24. S is semi-perimeter, which is 12. So this is 2. That's it. You're done. Easy peasy, right? So centers of a triangle is very important. Don't underestimate the importance of orthocenter, circumcenter, centroid, incenter. Don't underestimate their importance. All right. Moving on to the next question, everybody. Let's attack this one. AB is a chord of length 12 of this. Very important. Very important. Okay. This is the circle. Tangents drawn to the circle at points A and B intersect at point P 5 times the distance of P from the chord AB is equal to. So the question is talking about something like this is happening, I believe. Something like this is happening. So there are 2 comma minus 1 is the center. Chalo. 2 comma minus 1 is the center. 13 by 2 is the radius. Radius is bache 13 by 2. Tangents are drawn to the circle at points A and B from point P. Chalo, cool. This is my AB chord. 5 times distance of P from the chord AB. When you join this with the center, this is 90 degree. This is, let's say, D. I want 5 times PD. This is what my target is. My target is to compute 5 times PD, everybody. 5 times PD. How do you think I should proceed? If I join this here, I know this is the radius, but I want to talk about something even bigger. If this is theta, this completely is 90, this is also 90, That means what? What is this? This is 90 minus theta. But Baba, this completely is 90. That means this is theta. If this is 90 minus theta, this leftover part is theta. Let me draw it using the red color. This is theta, no? If this is theta and this is also 90, from within this triangle, can I compute cos theta? From within this triangle, can I compute cos theta? Cos theta is curly brown hair. That means what? AD upon R. What is AB? AB completely is 12. So AD will be half of 12, which is 6. 6 upon R. What is R? R is 13 by 2. This is 12 by 13. I am talking about the small triangle here, which is ADC. Let me name this C. Okay, so I'm talking about cos theta in triangle ADC. Baba, perpendicular from the center to the chord bisects the chord. So complete AB is bisected at D. AB is of 12. So AD is of 6. BD is of 6. What's the issue? Cos theta is 12 by 13. Now what do I want is 5 times PD. Oh, I want 5 times PD. Let me come to the triangle, the big triangle, in triangle PAD. Okay, in triangle PAD, what is tan theta? Through proper brushing, that means it will be AD upon PD. Acha, okay. What is AD? AD is 6. PD I don't know. What about tan theta? If cos is 12 upon 13, understand, if cos is 12 upon 13, what is tan? This is 169 minus 144 is 25. This is 5. So tan theta will be equal to what? Through proper brushing, now, so 5 by 12. That means 5 PD, cross multiply. 5 PD is equals to 6 into 12, which is 72. That's it. That's the answer. But more than the question is seriously very easy. Trust me, question is easy. More than the question is this concept of theta being the same angle here. Theta being the same angle here. Also, guys, the area of the triangle formed by the tangents and the chord, length of the chord, all these formulas which are RL cube, R cube plus L cube, all those formulas I have discussed in my coordinate geometry formula revision section. So in that session, so please watch that section out. If you don't want to watch the entire formula series, do not watch. Just watch that section out, which is related to this figure, this complete figure. It's very important and all those formulas should be on your fingertips. That's a must, non-negotiable. Come to this one now. If the length of the lattice rectum of this ellipse is 4 and L is the length of its major axis, which is lambda plus L. Very trendy JEE Main question, everyone. Tell me, how will you crack this? Huh? First of all, you are given ellipse in a non-standard form. So you have x square plus 2x. Then you have 4y square plus 8y equal to lambda. So x square plus 2x plus 1 minus 1. 4 common. Y square plus 2y plus 1 minus 1 is lambda. So this gives you x plus 1 whole square plus 4 times y plus 1 whole square equal to lambda. This is minus 4. So plus 4 plus 1. This gives you plus 5. So you get x plus 1. Very interesting question. Upon lambda plus 5 means root over lambda plus 5 whole square. Plus y plus 1 whole square upon lambda plus 5. Root over lambda plus 5 upon 2 whole square. Hai na? Right. This is equal to 1. Now it's but obvious. A is root over lambda plus 5 and B is root over lambda plus 5 upon 2. So A is greater than B. That means it's a horizontal ellipse. That means it's a horizontal ellipse. So length of lattice rectum will be 2B square by A, which is given to you as 4. Yup. है ना? 2B square by A is equal to 4. That means 2B square is equal to 4A. या फिर B square is equal to 2A. This is one relationship between A and B. है ना? B square equals to A. B is what? Root over lambda plus 5 upon 2. This is B. Square I want. square I want is equal to 2 times root over lambda plus 5. Chalo, then lambda plus 5 upon 4 is equal to 2 times root over lambda plus 5. Yes? So this is what? See, lambda is not allowed to be equal to minus 5 is something you should keep in your head. If lambda is minus 5, you will get root 0. And I want positive distances. So lambda is not allowed to be equal to minus 5. So that means this is root over lambda plus 5 whole square. So one of this and this cancels out. You're left with root over lambda plus 5 is equal to 8. Lambda plus 5 is 64. Lambda is equal to 59. Easy? Completing the square is exactly correct. Okay, and if I talk about major axis, the length of major axis is in a horizontal ellipse is given by 2a. So 2 times root over lambda plus 5. Yes, that is a. 2 times root over lambda plus 5, 2 times root over 59 plus 5, which is 64. That is 8 into 2, 60. That's it. This is L. Now you can find L plus lambda. Easy peasy. But the fact that you have completed the square to kind of reach to the conclusion of which type of ellipse this is, horizontal or vertical, accordingly use the LR's definition and then use the major axis definition. That is the main catch. Okay? Easy? Understood? Any confusion? Easy, right? Okay. Come to this one now. If the common tangent, now don't say tangent is not in the syllabus, it is very much in the syllabus, please. If the common tangent to the parabola y square equals 4x and x square equals 4y also touches this circle. If the common tangent to the parabola this and this also touches this circle, C is equal to what? What is the approach? What is the approach? POI, point of intersection you're saying. Chalo, try it out, try it out. Try it out. If the common tangent to the parabola this and this also touches the circle. Arey baba. Common tangent to both the parabolas. So if I talk about y square equals 4ax, y equal to mx plus a by m. Yes. If I talk about x square equals 4ay, y equal to mx minus am square. Yes, this is upward openings, slope form of tangent, rightward openings, slope forms of tangent. Yes, this should be on your fingertips, people. Because this is common tangent, that means it's representing the same line. What are you getting? 1 by m is equal to minus m square. So minus m cube is 1 or m cube is minus 1. If m cube is minus 1, this seriously implies that m is minus 1. Acha. Now, this also touches the circle. If m is minus 1, that means my tangent actually looks like y equal to mx plus 1 by m. So, this is minus 1. This is my tangent and my tangent is touching the circle, baba. My tangent is y equal to minus x minus 1 is touching the circle. X square plus y square equals c square. So, center is origin and radius is c units. That means what is c? From the center, when you compute the perpendicular distance to the tangent line, that distance is coming out to be c. Yes or no? What is c? Mod of, what is this? Y plus x plus 1. 0 plus 0 plus 1 upon root over 1 square plus 1 square. This is 1 by root 2. Easy peasy, lemon squeezy. Yes, so don't get scared when you see the common tangent questions, because yes, they demand from you the equations of tangent in slope form, parametric form, depending upon the situation. But the moment you remember them, after that equating the y-intercept, equating the slope and then moving ahead with the question becomes very easy. It's literally very easy. Okay, so just remember all the formulas for slope form of tangent for all the conics. All right? Yup. Let the points of intersection of this line, and this line are the midpoints of the sides of this triangle. What is the area of triangle ABC? I just wanted to discuss this question with you to tell you about the logic. What is the logic? Points of intersection of this, this and this are the midpoints of the sides of the triangle. Now see, you have this triangle. This is your A, this is your B, this is your C, this is the midpoint, this is the midpoint, this is the midpoint. Okay? This is D, this is E, let's say, and this is F. Question says, this is say line 1, this is say line 2, this is say line 3. Line 1 intersection line 2 you find out, line 2 intersection line 3 and line 1 intersection line 3. You will get 3 points. One will be 1, 2, one will be easy here but labor work here. Okay. This will be 7, 5 and this will be 2, 3. So basically each of these intersections will give you a point which is representing the coordinates of the midpoint of the sides of the triangle. What is the area of triangle ABC? Now see, always remember when you join the midpoints, the moment you join the midpoints like this, you get 4 congruent triangles. You get 4 congruent triangles having all the same area del, 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 del. So area of triangle ABC is actually 4 times the area of triangle DEF. Will you remember this? Will you remember this? So find out the area of triangle DEF. It is 4 times what? Half determinant of x1, y1, 1, x2, y2, 1 and x3, y3, 1 mod of this. So this is 2 times the determinant which comes out to be, I believe 3. This is 6. That's it. Are you understanding? So half times this determinant comes out to be 3 by 2. Basically I write it like this, wait. 4 is to chalo, okay fine. Eventually we have to multiply. This comes out to be 3 by 2 which is 6. Did you understand? Again easy question. Just wanted to convey the logic. Just wanted to convey the idea. If you get something like this, you know what to do. Okay? Chalo. If the variable line, this is very interesting. If the variable line lies between the 2 circles, this and this, without intercepting a chord on either circle, sum of the integral values of alpha is what? One says done. Okay. Very good, Harry Potter. Now, please understand the question is very interesting. Variable line lies between the 2 circles without intercepting a chord on either circle. Now, there are 2 ways in which this can happen. One way is the line is lying purely somewhere in the middle, neither touching circle 1 nor touching circle 2. Or it can happen the line is touching one of the circles but not creating a chord on that circle. Okay. So basically this line should not create a chord on either of the 2 circles. Is this okay? Is this okay? See now. Line to chalo I know 3x plus 4y is equal to alpha. 3x plus 4y is equal to alpha. Now, center is 1, 1. One of the circles has center 1, 1. Other one has 9, 1. Okay. This is say 1, 1 and this is say 9, 1. Now, listen to me. Sum of the integral values of alpha is what they want. Done this? Very good. See, I'll tell you one thing. The concept which is used to crack this question is position of a point with respect to a line, everyone. That's it. Such an easy concept. Position of a point with respect to a line. The moment you say that the line is between the circles, you automatically are wanting to say that distance between the centers is greater than the sum of the radii, isn't it? Distance between the centers is definitely greater than the sum of the radii. Distance between the centers is greater than the sum of the radii. Can I conclude that? Distance between the centers is greater than sum of the radii. Sum of the radii is 1 and 2, which is 3. Right? Yes. And distance between the centers is what? Under root of 9 minus 1 whole square plus this. This is true. This is 8. It is greater than 3. 100% for sure. For sure. Now, the first thing that you have to do is, listen to me carefully. As I said, position of a point with respect to a line. If you plug in on this line, if you plug in 1, 1 and 9, 1, the sign will be opposite. The sign of L at 1, 1 and the sign of L at 9, 1 will be opposite. Yes, very good. So what do you get? You get 3 plus 4 minus alpha. Okay, multiplied with 9, 1 na. So 27 plus 4 minus alpha. This is negative. This is exactly what I'm talking about. Or you can say alpha minus 7, alpha minus 31 is negative. So alpha belongs to 7, 31. This is one condition. Second condition, everybody. You know what is another condition? You know what is another condition? The distance from the center to the line. Listen to me, okay? Very, very, very important. Distance from the center to the line. The perpendicular distance from the center to the line is greater than the radius. The perpendicular distance from center to the line is equal to the radius. At max, it can happen that perpendicular distance from center to the line is either greater than the radius or equal to the radius. It will never be less than the radius. Because if that distance is less than radius, it would mean the line is creating a chord, actually intercepting the circle, which is not allowed. So my D, which is distance from the center to the line, can be greater than the radius or equal to the radius. This is my next condition, that my D is greater than equal to the radius. What is D? Tell me, what is D? Distance from the center to the line. Take any center, take 1, 1, let's say. So you get 3 plus 4 minus alpha inside the mod upon under root of 3 square plus 4 square is greater than equal to the radius. What is the radius of the first circle? Radius of the first circle is 1. Yes. So D1 is greater than equal to R1. Similarly, you have third, that D2 is greater than equal to R2. What is this? Same. From second center, you compute the distance to the line. You get 3 into 9, 27 plus 4 minus alpha upon under root of 9 plus 16 is greater than equal to 2. That is the radius of the second circle. Okay. From here, you will get alpha is greater than equal to 41 or less than equal to 21. Please check. Similarly for second circle. That's it. Now you just need to take intersection of this set, and of this set. Okay. This is A, let's say, this is B, let's say, this is C. Then your final answer is A intersection B intersection C. Okay, and you know what it comes out to be? It comes out to be 12, 20. You want what? Sum of all the integral values of alpha. This is where alpha belongs. 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh. Yep. 12, 13, 14, 15, 16 up till 21. So sum is 12, 13, 14, 15, 16 till 21. How many terms? 10. 10 by 2 first term plus last term. So 5 times 33. 165. Is it okay? Nice question, right? A very fresh concept came into picture, wherein number one, distance is greater than or equal to r. Very, very important. That's why the visualization is very important. If the visualization is not correct, you will not reach the correct condition. You will not be able to reach the correct condition if the diagrams are not correct, even the imagination if it is not correct. And obviously position of a point with respect to a line. Yes, ma'am? Few more. Hanif. Chalo. Tell me, two circles each of radius 5 units touch each other at the point 1, 2. Okay, fine. If the equation of their common tangent is this, C1 is this, C2 is this, C1 and C2 are not equal, they are their centers. What is this? Tell me. Two circles each of radius 5 touch each other at 1. Each of radius 5. Each of radius 5. Be very careful. Each of radius 5. Two circles. Two circles each of radius 5. Okay. Touch each other at 1, 2. Acha. If the equation of the common tangent is 4x plus 3y equal to 10, C1 is alpha comma beta, C2 is gamma comma delta. Chalo, theek hai, this is C1 and this is C2. Okay, what else now? Now, you can use the concept of D is equal to R. Are you understanding? From the center, you compute the distance till the line. It is equal to the radius for the first circle and for the second circle, and then solve it simultaneously. But that is not the method I want to promote right now because it's not very efficient for this question. What is the different method that we can use right now? Once calculus is finished, differential calculus, integral calculus, everything is finished. We are now into conics. हाँ, तो Priyanshu, what you are saying is what I am saying, na? कि distance between the centers is equal to sum of the radii. Don't use that. Don't use the technical approach. Can you bring in something else in picture? Do you know something like, see, line is touching, or circle is touching the line at 1, 2. This is 4x plus 3y equal to 10. How will the equation of this circle look like? Do you know? X minus 1 whole square plus y minus 2 whole square plus lambda times 4x plus 3y minus 10 is 0. I am talking about the concept of family of circles. You will just see how easy situations get when you use this concept. So any circle which touches this line at 1, 2 will look like x minus 1 whole square plus y minus 2 whole square plus lambda L equal to 0. Very good, Harry Potter. Very good, Priyanshu. Okay, so you will get what? X square plus y square plus 1 plus 4 minus 2x minus 4y plus 4 lambda x plus 3 lambda y minus 10 lambda is 0. So you get x square plus y square. Take out the x part common, na? 4 lambda minus 2. 4 lambda minus 2. 4 lambda minus 2 x, 3 lambda minus 4. Yes, plus 3 lambda minus 4y. And you have what? 4 plus 1, 5. 5 minus 10 lambda. That's it. Is equal to 0. Now, any circle which touches this line at 1, 2 looks like this. I know the radius of each of these circles. I know the radius of each of these circles is 5. What is the center? Center of this circle is minus g comma minus f. Minus half of coefficient of x. This is 2 lambda minus 1. Okay. Minus half of coefficient of y. So 3 lambda minus 4 upon 2. This is your center. Minus half of coefficient of x, comma, minus half of coefficient of y. This is the center. Everyone? This is the center. What is the radius? Radius is 5, which is under root of g square. 1 minus 2 lambda whole square plus f square. 3 lambda minus 4 upon 2. This is it. G square plus f square minus c. So minus of 5 minus 10 lambda. This is 5. G square plus f square minus c. Under root of g square plus f square minus c is actually the radius, which is 5. When you solve this, which is very simple, just square both sides, and when you open up the squares with the identity, everything will get very smoothly cancelled out. Your answer will come out to be lambda equal to plus minus 2. Yup, that's what I was saying. That is exactly what I was saying. When you take, now what is the problem? Now, corresponding to lambda as 2, you will get one center. Corresponding to lambda as minus 2, you will get another center. So you basically are solving for one circle, but your answer is coming out to be for both the circles. So when you take lambda as plus 2 and when you take lambda as minus 2, what happens? See? Tell me. Huh? What is alpha comma beta and what is gamma comma delta? Baba, if lambda is 2, what is the center? It is 1 minus 4, which is minus 3, comma minus 1. So 1 is minus 3, comma minus 1. And next, if you plug in lambda as minus 2, lambda as minus 2, 1 plus 4, 5, 5, comma 5. That's it. This is your alpha, comma beta. This is your gamma, comma delta. That's it. Now so you can compute anything. Now you can compute anything. Is the concept clear? It's a very beautiful question. See, people, when it comes to circles, the tangents, lines touching the circles, all of these concepts are very important and hot shot in the paper. So you have to make sure that you are using the best possible approach to get these questions right. For example, over here, there were many multiple approaches which we could have used to crack this question, but family of circles happens to be the most efficient one, quickest one to tackle it. All right? Yep. Let's go to the next question. On this ellipse, P is the point in the second quadrant, so the tangent at P to the ellipse is perpendicular to this line. S is dash are the foci, E is the eccentricity, A is the area. What is this? Let's plot. Let's plot, because without imagining, I can't crack this question. I to pakka can't. This is A is greater than B. So you have a horizontal ellipse. Okay, fine. You have a horizontal ellipse. P is the point lying in the second quadrant, such that tangent at P. Okay, fine. This is tangent at P. This is your tangent at point P. A cos theta, comma P sin theta. Tangent at P is perpendicular to this line. That means the slope of this line will be what? Minus 1 by 2. This is 2. Baba, perpendicular means product of slopes is minus 1. This is the line x plus 2y is 0. So what is the slope? What is the slope of this line? Tell me. Minus of coefficient of x upon coefficient of y. So its negative reciprocal will be 2, na? So slope of my tangent line is pakka 2. Chalo, okay. S and S dash. Okay, this is S, let's say this is S dash. S and S dash are my foci. So distance between the foci is what? 2AE. That is so for sure, I know. Okay, S and S dash foci is the centricity. I want to talk about the area of triangle PSS dash. Acha, okay. If I want to talk about the area of this triangle, I should know if I drop a perpendicular from here, this will be my height. This is D. This is my height, PD, which is what? B sine theta. Remember, it's the second quadrant, so y coordinate is positive. So my area actually will be, area is half into base. Base is 2AE. Distance between S and S dash, and height is what? B sine theta. Acha, okay. 2 cancels out. What is A? A is 2 root 2. And B is what? 2. A and B sorted. E I don't know. Sine theta I don't know. So I get 4 root 2 E into sine theta. What is E? If you know A and B, you can calculate E. 1 minus B square upon A square, which is 1 minus 1 by 2, which is 1 by 2. So you get 1 by root 2. You get 1 by root 2, na? What else? Yes or no? 1 by root 2. So this is what? 4 root 2 into 1 by root 2 into sine theta. So this basically comes out to be 4 sine theta. Achha, theek hai bhai. Cool. 4 sine theta. Now I only need sine theta. My answer will come. But how? How should I get sine theta? Use the fact that you know the slope of the tangent line. Now compute the tangent line in the parametric form. What is it? Huh? What is it? Tangent in the parametric form is x upon a cos theta plus y upon b sin theta is equal to 1. What is the slope? Minus of coefficient of x upon coefficient of y, which is minus cos upon a into b upon sine, which is minus b by a cot theta. That is the actual slope of this tangent. So b is what? B is 2 and a is 2 root 2. This cancels out. We're left with cot theta. So you get minus 1 by root 2 cot theta. Acha, this is the slope, but it is given to be equal to 2. Remember, that means cot theta, because it was perpendicular to the line, na? So it's given to be 2. So you are basically getting, where is it? Yeah, cot theta equal to minus 2 root 2. This means theta lies in the second quadrant first of all. Yes, now if this is 2 root 2, cot is minus 2 root 2 means what? 2 root 2 and this is 1. So 8 minus 1 is 7. Is this what you are getting? 2 root 2, 8 plus 1. 2 root 2 is 8 plus 1, 9. So this is 3. That means sine theta is 1 by 3. See, it's 1 by 3. Sine theta is 1 by 3. The moment you know sine theta is 1 by 3, you get 4 times 1 by 3, which is 4 by 3. If A you have got as 4 by 3, E you know is 1 by root 2, 5 minus E square times A you can easily compute. That also you can do. Here, because you have already used the height as b sine theta, that means you are kind of considering the parametric coordinates. So write the parametric equation might as well. Not that what you are saying is wrong, but I don't know. Because I considered the height as b sine theta, you can use that. And of course, you can use that as well. Okay? Guys, is the question clear? Yes? Yes, ma'am. No, ma'am. What is the scene, ma'am? This is a question which I don't wish to do because I believe you very well have it within your range to do it. This is one question I want to give for homework. Please try it out and let me know if you are facing any difficulty at any stage. Bas Priyanshu, couple of more questions. Couple. See, I'm giving you easy question for homework, tough ones or maybe a little bit more conceptually heavy ones. I am only explaining. See, if the tangent to this parabola is at the point alpha comma beta is also tangent to my ellipse, what is alpha equal to? This is a very classic question, okay? The parabola is what? Y square equals x. At alpha comma beta, I want the tangent. So replace y square with y1 equals x plus x1 upon 2. So you get 2y beta is equal to x plus alpha. This is the tangent to my parabola at point alpha comma beta. Or rather you write it as y equal to 1 by 2 beta times x plus alpha by 2 beta. This is my tangent to the parabola at the point alpha comma beta. Yes, now what is the next one? This is an ellipse. So x square by 1 plus y square upon 1 by 2 is equal to 1. So tangent to this curve will look like what? Yes. Now your slope form will come into action. Y equal to mx plus minus root over a square m square plus b square. B is 1 by root 2. This is 1 by root 2 whole square. So this is 1 by 2. A square m square plus b square. See? Now, because both the lines are representing the same tangent, first of all, m is equal to 1 by 2 beta. And see, alpha by 2 beta is equal to this. Can you see this? Alpha by 2 beta is equal to under root of m square plus 1 by 2. Na? You can take plus minus also because eventually you will square both sides. Okay, so alpha square plus 4 beta square is equal to m square plus 1 by 2. Yes, correct. Okay, but what is m square? 1 by 4 beta square. So this is 1 by 4 beta square plus 1 by 2. Yes? Yes or no? So 2 cancel, 2 cancel, 2 cancel. So alpha square by 2 beta square is equal to 1 by 2 beta square plus 1. See, this will be 2 beta square and that's it. This cancels out. That's it, no? Alpha square is equal to 1 plus 2 beta square. Couple of calculations you should know how to skip also. Okay, this is the relationship between alpha square and beta square. One thing which I always stress upon and students definitely forget is that point is lying on the parabola, it will satisfy its equation. So you get beta square is equal to alpha, na baba. If beta square is alpha, plug it here, you get alpha square equal to 1 plus 2 alpha. This means alpha square minus 2 alpha minus 1 is 0. Alpha is what? 1 plus root 2 and 1 minus root 2. But Baba, beta square is alpha and beta square is positive. Beta square is positive, so alpha will have to be positive. That means I will accept 1 plus root 2, not 1 minus root 2. 1 minus root 2 is rejected, 1 plus root 2 is accepted. Any doubt? Easy, right? 1 plus root 2 is accepted. Any doubt? Anyone? Cool hai? Chalo. 2 more questions. This don't do. Don't do this. Try it out for homework. This is something which I don't want to prioritize right now. Tomorrow there is a last paper predictor session. There I'll try and bring this question and explain it to you in more detail. But right now, please don't bother about this question. Don't bother about this question. Hi, Adarsh. Okay. Yup. Tell me. Ellipse intersects the hyperbola orthogonally. This is something which you know. But this question is different from what you have done. That is for sure. An ellipse intersects the hyperbola. This is the hyperbola orthogonally. Orthogonally means both the conics are confocal. Confocal means they have the same foci. Eccentricity of the ellipse is reciprocal of the eccentricity of hyperbola. If the axis of ellipse are along the conjugate axis, then equation of ellipse, foci of ellipse, equation of ellipse, foci of ellipse. Yup, very good. X square minus y square or x square upon 1 by 2, y square upon 1 by 2 is 1. This is your a square and this is your b square. What is eccentricity of the hyperbola? Root over 1 plus 1, which is root 2. Again, because you can see A and B are same, na? So it's a rectangular hyperbola. It's a rectangular hyperbola. Yes. So eccentricity of the ellipse will obviously be 1 by root 2 as per the question because they are reciprocals of each other. Now for my hyperbola, foci will be plus minus AE comma 0. Yes. What is A? A is 1 by root 2. What is E? It is root 2. Plus minus and 0. So this is plus minus 1 comma 0. These are also the foci for my ellipse. है ना? These are also the foci for my ellipse. So for my ellipse, A eccentricity of ellipse is equal to plus minus 1, or rather just take it as 1. Now, eccentricity of your ellipse is 1 by root 2. It's 1 by root 2 is equal to 1. That means A is equal to root 2. This is for my ellipse. My ellipse right now I don't know. It is x square by a square plus y square by b square is equal to 1. So A has come out to be root 2. Eccentricity of ellipse is 1 by root 2. I can compute B also, na? Huh? Yes or no? Eccentricity of ellipse is root over 1 minus b square by a square. So eccentricity of ellipse is 1 by root 2. Yes, is equal to root over 1 minus b. So I don't know. A square is what? A square is 2. But that's it. 1 by 2 is equals to 1 minus b square by 2. So b square by 2 is 1 by 2. This implies b square is 1. That means my ellipse I have got. My ellipse is x square by a square plus y square by b square is 1. Please check this out. Yes, x square by 2 plus y square by, this is correct. And foci are plus minus 1 comma 0. Confocal, na? It's the same foci. It's the same foci. Okay? Is it okay? Any doubt in this question? Orthogonally, you should know when two curves intersect orthogonally, that means they are confocal or they have the same foci. That is what drives the question. Okay? Come to this question, the last question, everybody. Let's pay attention. The circle, this and the hyperbola intersect at A and B. Equation of the circle with AB as its diameter. So the circle is what? X square plus y square minus 8x is 0. Oh my God. Oh my God. X square plus y square minus 8x. See, this is x square minus 8x plus y square is 0. X square minus 8x plus 4 square minus 4 square plus y square is 0. This is x minus 4 whole square plus y square equal to 16. This is how you have to complete the square to reach the center and radius of the circle. So now you know that my circle actually is centered at 4, 0 and is of radius 4 also. That means it will touch the y-axis at origin. This is your 4, 0 and the radius is also 4 units. Okay, fine. Chalo. Hyperbola is x square minus 9, x square by 9 minus y square by 4 is 1. Intersect at points A and B. Acha, okay. So x square by 9 and minus y square by 4. Okay, fine. So y-axis ke about symmetric will be the branches. And the branches will look like what? This and this. You can see this, na? X square by 9 and y square by 4. So the vertices are actually plus minus 3, 0. So this is 3, 0. This is minus 3, 0. Yep. This is how it will look like. So they are intersecting each other at points A and B. Tell me, this is my circle, intersect it with x square by 9 minus y square by 4 equal to 1. Please intersect this and tell me. Intersect this and tell me, na? From here, you will get what? X square by 9 minus 1 is equal to y square by 4. So x square minus 9 by 9 and this is 4 is equal to y square. Plug the value of y square here. And tell me what is x coming out to be. When you will do this, x will come out to be 6 and minus 6 by 13. But I will not take x to be negative. You can clearly see they're intersecting in the first or the fourth quadrant where x is positive. So I can't take this. X has to be 6. If x is 6, 6 minus 4 is 2. 2 square is 4. 16 minus 4 is 12. Y square is 12. Okay, 12 means 2 root 3. Y is 2 root 3. Y is plus minus 2 root 3 basically. So this gives you what? A 6, 2 root 3 and this is 6, minus 2 root 3. Question is, considering A and B as the end points of the diameter, considering A and B as the end points of the diameter, what is the equation of the circle? Considering A and B as the end points of my diameter, what is the equation of the circle? X minus x1, y minus x minus x1 into x minus x2, y minus y1 into y minus y2. That's it. Okay. X square plus y square minus 12x plus 24 is 0. Is it okay, people? Is it okay? With this, we are done with conics. I'll just solve 2 questions with you and rest I'll give you for homework. I have collected some questions from Vector 3D which I wanted to discuss, but I feel it's going to really exceed the time. So I'll solve 2 questions with you. This is the homework question. Yeah. This is a homework conic question. I'll solve 2 questions with you and then I'll give you a few questions for homework. Okay? Let's start. Tell me, equation of the line passing through this point parallel to the plane and intersecting this line. Now, I know there is plane involved, but somewhat in between, for one miniature concept, they can include planes in the syllabus. Legit, just plane oriented question, they will not give you because planes is deleted from the syllabus, but indirectly for some miniature intermediate concept, they can bring in the planes. So, I want a line passing through minus 4, 3, 1. Okay, 1 second, people, give me 1 second. Let me quickly add some slides. Yep. Just give me 1 second. Yep. All right. Chalo, tell me. Equation of the line passing through this point, okay? If it is passing through this point, it will look like, this is my required line. It will look like x plus 4 upon a is equal to y minus 3 upon b, z minus 1 upon c. ठीक है? Oh. Okay. My line will look like x plus 4 upon a equal to y minus 3 upon b equal to z minus 1 upon c. Yes, this is cool. I don't know ABC till now. I know my line is parallel to my plane. If the line is parallel to the plane, the drs of the line will be perpendicular to the drs of the normal of the plane. Yes or no? If line is parallel to the plane, the drs of the line will be perpendicular to the drs of the normal of the plane. That means what are the drs of the normal? 1, 2 and minus 1. So you will get A, B, C's dot with 1, 2, minus 1, 2b 0. So you will get A plus 2b minus C is 0. That is okay. This is one equation involving ABC. It also says that my line, this is very important. This is supremely important. My line is intersecting this line. When two lines intersect, what is the concept you use, bache? When two lines intersect, what is the concept you use? Huh? When two lines intersect, very good. What is the concept you use? Shortest distance is 0. When two lines intersect, the shortest distance between them is 0. And you should know the shortcut which is used to get to the shortest distance. Don't use the formula of B1 cross B2 and all of that. No. See, you have your line. What is it? X plus 4 upon A is equal to y minus 3 upon B, z minus 1 upon C. And you have another line which is x plus 1 upon minus 3, y minus 3 upon 2, z minus 2 upon minus 1. Both these lines are intersecting. That means their shortest distance between them is 0. Very good. Yes. What is the shortest distance? Remember the shortcut. Difference of the points. Minus 1 plus 4 is 3. 3 minus 3 is 0. And 2 minus 1 is 1. Then the DRs A, B, C and minus 3, 2, minus 1. This is 0. You get upon under root of this square plus this square plus this square. But eventually if that is 0, my denominator makes no sense. Just this much is 0. So what do you get? This is the next relationship between A, B and C, using the concept of shortest distance 0. The moment you solve both these equations involving ABC, you get your ABC as 3 minus 1 and 1. The moment you get ABC as 3 minus 1 and 1, that's it. 3 minus 1 and 1, you've got your ABC as 3 minus 1 and 1. 3 minus 1 and 1 is this. Done. 3 minus 1, 1. Okay, is the concept clear? So because the line is parallel to a plane, its DRs will be perpendicular to the DRs of the normal, and because the line is intersecting another line, the shortest distance between them will be 0. That's the most interesting part. Because as it is, the concept of shortest distance is very important. They can either give you directly or they can give you indirectly. Okay? Formula is the same. A is this, B is this, C is a vector such that this is 0 and A dot C is 4. What is mod C square equal to? Very classic traditional question. Tell me. A cross C plus B is 0. That means B is nothing but minus of A cross C, or it is C cross A. है ना? It is C cross A. Now tell me, if I take cross of A both sides, I will get A cross B is equal to A cross C cross A. But how is this advantageous? Okay. I can do this, right? So A cross B is to chalo something which I can compute. I know I can compute. This is I, J, K. This is 1, minus 1, 0. This is 1, 1, 1. This is VTP, everybody. This is vector triple product. So A dot A times C minus A dot C times A. What is this equal to? Very good, Saurabh. This is equal to 2. This is equal to 4. So you get 2C minus 4A. VTP correct. And this comes out to be minus I minus J plus 2K. Okay, so this, see, basically what you are getting is a very traditional question. Very. Minus I minus J plus 2K is equal to 2C minus 4A. Yes, 4A is what? I minus J. I want C, so you will get minus I plus 4I minus J minus 4J plus 2K is equal to 2C. So plus 4I, this is plus 4J, so minus 4J. So minus I plus 4I is 3I minus 5J plus 2K is equal to 2C. Now you know how easy this is. Yes? Yes, na? Yup, very good. हाँ, वो भी कर सकते हैं प्रियांशु, not a problem. एक बार करके देखना. Try to do that once. हाँ, I get your logic. Okay, so this is upon 2, all of this, and this is your C. The moment you get C, you get mod C square as well. Okay, is this okay? Is the question clear? We started with B equal to C cross A, and then of course cross multiplied A pre-multiplied, basically pre-cross multiplied with A, and that was it. Hashtag HDCC. Okay, let's do one more question. I'm being very greedy to solve the questions, but I'll bring the remaining questions in my tomorrow's class. So don't worry, I'll bring the remaining questions in my tomorrow's class. Tomorrow I'll be focusing more upon the chapters or the topics which are yet left to be covered, which are just a few, handful, but I'll make sure I bring those questions tomorrow. Tomorrow is the last mock test, everybody. So please be attentive. Do attend the classes. Don't miss out on the classes, okay? Tomorrow is the last day. After that, of course, we are starting with our JEE Main. Oh my God. Chalo. This is a very interesting question. I just can't go without discussing this question with you. Chalo. And I'll give you one question for homework, okay? I've given you some questions for homework, but of course, I know how much you solved the homework questions. But now if I give you, please make sure you solve, because a lot of thought has gone into deciding to keep them as homework questions. Okay. Chalo guys, tell me. Last question, everybody. So I've said that this is the last question at 10 o'clock. Now it's almost 10:30. A and B are vectors in space given by A is this, B is this. What is the value of this? Now see, one thing you know is A dot B cross C is actually box of ABC. Exactly the same logic let's apply here. And don't think box product and vector triple product is not in the syllabus. It is there in the syllabus. So this vector dot with this cross this means the box of these three. It's the box of these three. This is 2A plus B, A cross B, A minus 2B. Now, instead of actually computing 2A plus B, A cross B and A minus 2B and putting it over here and then resolving and computing the determinant, don't do that. Please don't do that. Instead, use the splitting property. Please use the splitting property. please use the splitting property. What is the splitting property? Do you know this? Yeah, this is where I'm going to split. So I will have 2a, a cross b as it is, a minus 2b as it is, plus b, a cross b as it is, a minus 2b as it is. Now I will split this. I will get 2a, a cross b, and then a. Then again 2a, a cross b, and then minus 2b. Again split this. You will get b, a cross b, and then a, plus b, a cross b, minus 2b. Interesting. Interesting. Now see, I can pull this 2 outside. I will have a cross b, a. 2 same means value is 0. When two quantities inside the box are same, it means 0, because what does this mean? This clearly means a cross b cross a. Obviously, 0. A cross a is 0. You can also write it as a cross b dot a cross b. A cross b dot a cross a. And a cross a is 0. A cross b dot a cross a cross a is 0. Similarly here, if you take out the minus 2 outside, you will have b cross b. Again, the situation says it's 0. Inside a box, if any two quantities match, the answer is 0. You know this, right? This is 0, right? Because b is matching. Here also it's 0 because a is matching. Huh? Here what happens? 2 into minus 2. Minus 4 comes outside. Inside you are left with a cross b, and b. And from here, this is plus b, a cross b, and a. Let's see if there is a similarity. Let's see if there is a similarity. So b and a cross b. This a and this b, if I interchange, what will happen? Tell me. Cyclicity, na? A comes here and b comes here at the cost of a minus sign. Okay, right. This much is clear. Now, see, I want a cross b to come here. So, you write it as minus 4. Then a cross b here, a here, b here at the cost of a minus sign. So, this minus will vanish. Similarly, I want a cross b to come here. So, again, this minus will become plus. I will get a cross b, a and b. One time if you are interchanging, the cyclicity gets changed by minus 1. Basically, a minus sign comes into picture. That is the cost you have to pay. So, what does this give you? 4 plus 1, 5 times. This is 5 times a cross b dot with a cross b. This is 5 times mod of a cross b whole square. And this is where the magic starts. Last one is 0. Yeah, last one is 0. This is 0 and the first one is 0. We are only talking about these two. We are trying to make them similar looking so that it is easier for us to solve. Okay. Now see, now the magic starts. If you take dot of a and b, guys, you're given a, you're given b. This is something which you always have to do to check to make your life simpler. If you perform a dot b, it will come out to be 0. This means angle between the vectors is 90 degree. So now what is this? Mod a square, mod b square, sine square 90. And what is this? Unit vector? Unit vector? Is it unit vector? Huh? Check this out. It is unit vector, right? Sine 91. Answer is 5. Okay? The answer is simply 5. Okay? Is it cool? Very interesting question, very voluminous question, highly property based, rich variety. Is that cool, guys? I'm going to give you one last question for homework, and rest of the questions we'll do tomorrow in the class, which is in the mock test. Okay, this is your homework question. Now, this homework question, I will be beginning my session with this question because this is a very trending pattern wherein you bring everything on the left hand side and you use the concept of collinear vectors or parallel vectors to proceed further. Please try it out. Very famous high weightage concept wherein one of the vectors matches and you bring everything to the left hand side, you get b cross c minus d is 0. So, b is parallel to c minus d, and what you do next is something which is worth spending time upon. All right. So on this note, it's me, Bhoomika, signing off, everybody. I hope you enjoyed today's class. We have covered a lot of topics. Almost everything is covered. A handful of questions were left, and I would be discussing them tomorrow with you, definitely in the mock test or in the paper predictor session, which is scheduled to happen from 3 to 6 p.m. Definitely log in sharp at 3. We'll be starting, I don't know, with chemistry and then moving on to the other subject, depending upon how we are pacing up. So, of course, you have to make sure you tune in at 3 p.m. only on the Rankplus JEE English channel. And if there is any doubt in any question which we've solved today we solved so many questions, plethora of questions. If there is any doubt, please reach out to me at study with Bhoomika Ma'am. All right. Okay, dokie. I hope you enjoyed today's class. People, let me know in the comments below if you loved it, if you liked it. If there's any feedback, feel free to share. Don't forget to hit the like button and also don't forget to subscribe to the channel. Thank you so much. Bye-bye. Take care. Good night.